appreciate the work that we're doing here on Standing for Truth, please hit that subscribe button because we are just getting started. Okay, looks like we are live, guys. And this is an extremely exciting event that we have today. We have Michael J. Oard with us for a presentation titled Astounding Evidence for Noah's Flood. We will also be having a question and answer period, okay, following the presentation. Please share around. I promise you this is going to be one to remember. The question and answer is going to be not only from us as the hosts, I've got George here as well, but also from our awesome audience today. So please make sure you are tagging me at Standing for Truth or at George Bond, just to make sure that we see your questions and we can save them for Mike. Now, before I go over a brief introduction into who Mike Oard is, I first want to thank him for giving us his time today for this incredibly important show. So I'm going to bring him into the stream, as well as George, our awesome co-interviewer here. Mike, thanks so much for being so generous with your time and giving us your time today.
You're welcome.
Yeah, really looking forward to this. So real quick, I'm going to go through a brief introduction, Mike, and of course, correct me if I'm wrong on any of this. So Mike Oard has an MS degree in atmospheric science from the University of Washington. After 30 years as a meteorologist with the U.S. National Weather Service, he retired and now is fully devoted to research on the compelling evidence for Noah's flood and the post-flood ice age. He has done considerable study on the woolly mammoths in light of Noah's flood and the ice age. Mike has published several research papers in his field in journals of the American Meteorological Society. His creationist research has been published in technical books, layman's books, and children's books, as well as in many creationist journals. He also lectures on these subjects and serves on the board of directors of the Creation Research Society in the U.S. I'm also happy to say I've got George here again with me for this show. So George, thank you for being here.
Thank you, SFT. Firstly, Mike, I'm Australian. We don't have an accent. You guys have an accent.
Okay.
Firstly, I want to point out that the information provided by SFT can be found in the description box. I urge you all to go and have a look at it. There are some links there to his Genesis website, I believe, his own website and many others. As we said, his website is linked in the description box, so please have a look. He has a number of books and videos which are excellent, by the way. SFT and I have read some of his papers and watched his videos on YouTube. He's a wealth of knowledge, especially in the area of the Ice Age, coming from the MS degree in atmospheric science. Mike, we like to be a little bit lighthearted on this channel, and we like to start with a few jokes. So I hope I don't turn you off by some of them. Okay.
Okay.
I'll start off with the first one. If you were in a freezing room and want to stay warm and comfortable, you should always stick to the corners because they are all 90 degrees.
Good. I never heard that one before.
Oh, well, I hope you haven't
never heard
this
that one either.
Someone told me, I can associate with this one, by the way. Someone told me I could make ice cubes out of leftover wine, but I'm confused. What is leftover wine? Anyway, I hope I haven't discouraged you now. You must be thinking, what on earth have I got myself into? So I'll give it over to you, Mike. So yeah, I believe you've got a fantastic presentation for us, and I think SFT will share your screen and let's go.
Okay.
Yes, let me get your screen going, Mike.
Okay.
Okay, here we are.
Am I good to go?
Yep.
You're all good to go, Mike. Screen
Okay,
looks
my
good.
topic is Noah's flood. Actually, an issue I've been working on for 45 years with research, besides the Ice Age. Anyway, this title is Astounding Evidence for Noah's Flood. What I'm going to give you is just a summary and just the highlights of the summary of all the details you can fit into the what can be called as the flood model. But you know, there's a lot of secular researchers and even some Christian geology professors who say there isn't any evidence for the flood. Here's one from Davis Young, retired professor of geology from Calvin College, in a book titled, of all things, The Biblical Flood. He says, there is no geological evidence to confirm the idea of a universal deluge. Boy, isn't that an amazing thing? And I'm going to go back to that towards the end and kind of have a suggestion of why. I'm going to talk for maybe about 45 minutes, an hour, and I'm going to open it up to questions and go from there. Anyway, when I hear challenges like that, and by the way, I try to keep up with 50 earth science journals in the local library here at Montana State University, and I run into challenges all the time in the earth science, but I see them as just research opportunities. But when I look at these secular articles, I glean the raw observational data from their interpretations, and I separate them. I'm looking for the real raw data. That's the science that I'm looking for. And I go from there. Anyway, this is my theme verse for research. It's a good theme verse for all of life. Examine everything carefully, hold fast to that which is good. 1 Thessalonians 5:21, New American Standard Version. I can't emphasize carefully enough, because if you examine an issue just superficially, you might know enough just to get into trouble. You got to go carefully, dig. So I dig into the research, and then that's how from there I write my articles and books. So anyway, I want to start with this graph. When we're talking about the flood, I want to first of all say a little bit about what was the pre-flood world like before the flood. And we have some clues, not only from the Bible, but from geology and the fossils. One big clue is that the estimated amount of coal in the earth is about 10 times the amount of carbon than in the current biosphere, meaning that we probably had about 10 times as many plants and trees on the pre-flood earth. And there's hardly any frost rings, if any. So it's a warm climate with a huge amount of vegetation before the flood. And the interesting thing about vegetation is it gives off water vapor, transpiration. 10% of the rain we get on the continents is from transpiration through the leaves of trees. And so they'd add a lot of water vapor to the pre-flood earth. So we can, from that, we know we're going to have a pretty good greenhouse effect. And we need to water all that. So we had a different hydrology. There's a question whether it rained before the flood. I kind of lean that it did, even though it's uncertain from the Bible. And I must say that we don't know what the geography was before the flood, and the topography, they were both much different. So we don't know those things. One thing from my field, it doesn't look like there's a vapor canopy, as some people thought in the early days of creation research, due to the research of Larry Vardaman. It'd be too hot on the surface of the earth. It's plain and simple. And so that's a big problem. I haven't given up on it. You might be able to tweak it with a three-dimensional computer model with clouds and so forth, but my hope isn't up. Anyway, I don't do anything more in that. But we had the pre-flood Earth. We have some clues from the fossils and the amount of coal. Okay, when we look at just the Bible, we can kind of diagram the flood. Like any flood, there's a rising stage, called the flooding stage, and a retreating stage. And all floods are like this. So if we use that, we can realize that it appears that even though there's controversy over it, the flood peaked at day 150. That's generally the most common view, and I subscribe to it. And so during the flooding stage, we can divide it up into two phases. And each phase that you see at the top up here on my screen produces different signatures in the rocks. And so the first phase, by the way, this comes from Dr. Taz Walker from Creation Ministries International in Australia, who first reported on this in 1994 at the International Conference on Creationism, and I subscribe to it wholeheartedly. And based on this template, I've been able to see things from this point of view and see just a tremendous amount of evidence for the flood, which I'll just be summarizing for you. So two phases. The first phase is probably the most violent, when the mechanism of the flood erupts. And the fountains of the great deep and the windows of heaven opened, and the result of these were rain for 40 days and 40 nights. So that first phase probably was 40 days, and then it lessened and the rain lessened, and so we went into phase 2, which is a general rise. In phase 1, it was probably a rapid rise, lots of turbulence, fast currents. I'm not going to talk much about the mechanism. I lean towards a particular mechanism, but there's several models of flood mechanisms out there. But this is kind of doesn't depend on any one particular flood mechanism. This is just a diagram from the Bible. We should look at the rocks from the point of view of the Bible. That's the beauty about what Taz Walker does, not from assuming the geological column, for instance. And a lot of times they line up anyway, but sometimes they don't. Anyway, the first, I think Taz Walker calls it the eruptive phase. So it's about 40 days, I think, and then it tailed off, and you had a gradual rise of the floodwaters. Phase 2, called the ascending phase in Taz Walker's terminology. Now, during that ascending phase, you had a lot of oscillating currents due to tides and about 4 other mechanisms I can think of, and a gradual rise. So we had gradual sedimentation with cyclical sedimentation going on, forming coal seams and other cyclical depositional patterns that you see commonly in the rocks. So the flood peaked at day 150. And this was the time when all that breathed there and lived on land died, and all the sediments were deposited, and the fossil and the organisms were in the sediments that turned to rock. Pretty quick. Cementation is a very interesting, difficult thing. I've been working on it for the last couple of years for sand, and it's very complicated. But anyway, during the flood, you can cement these sediments pretty fast and fossilize the organisms at the same time. So that's where all the strata fits, right in there. And not only all the strata we see on the continents today, on the continents today, we have an average of 1,800 meters of sediment, about 6,000 feet average. But at the peak of the flood, based on the amount of sediments that ran off during the retreating stage, which I'll get to, there was actually about twice as many sediments on the continents as the 1,800 meters we still have left on the average, about 3,600 meters. So we have to develop 3,600 meters of sediments on all the continents average. And just on the continents, which is not on the ocean basins, which is very interesting, but they're making me think about a lot of things to add to this flood model in the future. So at the peak of the flood, Psalm 104, verse 8 says, the mountains rose, the valley sank down. So you had differential vertical tectonics starting at phase 3, the peak of the flood. And when that happens, the floodwater is running off, the retreating stage. The continents are coming up, the ocean basins are sinking. And during phase 4, the currents are very wide. There's hardly anything exposed. Nothing's exposed except, nothing exposed at the peak of the flood. Then finally more mountains and plateaus were exposed with time. But for a while, nothing was there. And so you had big, wide currents moving at high speed from off the continents, just eroding a huge amount of sediment. And there's evidence for this all over. I can show you big chunks of where sediment's been eroded off. I've done a lot of erosion studies on the continents, and I get huge numbers of erosion in many places. Southeast England, for instance, Southwest Africa, the Colorado Plateau, the Appalachian Mountains. I get huge numbers. And from a new paper in the journal called G-Cubed, which stands for Geochemistry, Geophysics, Geosystems, it's a journal of the Geophysical Union. And they know now how much sediments ran off that are in the ocean basin, especially along the edges of the continents, where that's where you'd expect the deposition from all the continental erosion to end up. So, and that's where I get now that there's probably 1,800 meters were eroded off the continents on the average. Remember, we're talking about the average. So you had what's called, phase 4 is sheet erosion, and certain features affected the surface of the earth during that. And from the field of geomorphology, the study of the surface features of the earth and landforms, we can see these features, what happened during what's called the sheet flow phase. Sheet flow means big, wide currents and not very deep, kind of the consistency of a sheet. Like a current might be 2,000 kilometers wide and 10 kilometers deep. So it's very wide and not very deep. It's like a sheet. So you had sheet flow eroding as a sheet, the sediments, and depositing them as a sheet along the continental margins that are now the continental shelf and slope. And then as more mountains and valleys show up above the floodwaters are forced to channelize, go around these, and they mark the surface of the land with different landforms due to channelized erosion during phase 5. And I'm going to show you examples of all these phases from now on. Anyway, these are slides from a talk I normally give, but I'm skipping number 1. This is evidence from strata, which is a geological jargon for sedimentary rocks. So a good place to see strata is Grand Canyon, mile deep cut in the earth. And you see the strata, it's about a mile deep or 5,000 meters deep. And you notice several things here. You see these what they call formations, rocks that are similar, and you can trace them for mostly across the 200 and some odd miles of the canyon. Like there's a bottom layer here called the Teton sandstone. I'm going to make a point of that coming up. And so you have these layers, and we can trace these layers at other locations in North America. Also, we see one layer, one on top of another, with little or no erosion between them. Yet the secular scientists say that this deposition here in Grand Canyon, from the bottom to the top, represents 250 million years. Okay, I'm going to get back to that. Another thing you see at Grand Canyon is that flat surface up there. Wow, you can be going along hiking in a flat surface and all of a sudden see this huge chasm. It's quite breathtaking. And if you've never been there, you should visit it. Anyway, this flat surface is a planation surface, which I'll talk about when I get into the section on geomorphology on the runoff. Now, that surface represents the erosion of about 3,500 meters of strata as a sheet taken off the whole Grand Canyon area. We know this because we see the strata in Utah to the north, about 100 kilometers, 150 kilometers to the north, where it's dipping down to the north and a series of steps called the Grand Staircase. And all that strata used to be up over the Grand Canyon area, about 3,500 meters, and it's been eroded off the whole area, forming a planation surface after it's eroded. So I'm going to talk more about that later. But anyway, here's the Tepete sandstone. It's a very unique sandstone, and it has a unique position. It's on top of the granitic and metamorphic crust, upper crust of the earth, of the continents. So it's a unique location. It's a unique sandstone. It's coarse grained. You can see some of the coarse particles in it. And sometimes you might call it a conglomerate. There's so many quartz grains in it. Small cross beds. It's about about 80 meters thick on the average. It varies some. But anyway, we can trace this same sandstone over half of North America, believe it or not. Up in my area, about 150 kilometers north of Grand Canyon in Montana and Wyoming, we see the same sandstone, but it's given a different name because the researchers didn't know they were connected. So up in my area, it's called the Flathead Sandstone, and it sits on top of granite of the upper crust. And here it is right here at Cody, Wyoming. Same coarse grained sandstone, and on top of granite of the upper crust. And when you trace it all out, this is where you find it. Most of it's below the ground in the Midwest and towards the Appalachian Basin. And it occurs up in Canada through the Rockies and up into Northeast Canada, up in the Queen Elizabeth Islands. So it covers about half of North America. Now I want to ask you and it's generally about the same thickness too, 80 meters about. Doesn't deviate a whole lot from that, but it does deviate some. I ask you, if we assume that all this sedimentary rocks was deposited by slow processes over millions of years, which is the secular uniformitarian idea, how are they going to deposit a sand on top of the upper crust of the earth over half of North America? That makes no sense, because deposition today is sand and it changes to clay, mud, gravel in short distances, both horizontally and vertically. It's a mess. And you wouldn't have something like this, not at all. This totally defies secular uniformitarian geology. This is exactly what you expect in Noah's flood, where we had layers laid down over huge areas, one on top of another. And so we're going to get back to the lack of erosion and the layers in here. 5,000 feet, or about 2,000 meters or so, something like that, 1,700 of sediments. They say 250 million years. But you know, erosion on a million-year time scale is huge. So huge that all the continents can be eroded to sea level in only 10 million years at today's rate. But there's some caveats on that, because man has caused some of this erosion, so you got to deal with that. And as the mountains decrease in height, the erosion rate decreases too. But it does not include coastal erosion, which is generally about 7 meters a year along the Arctic coast. But you can put a maximum on this of 50 million years to wipe out the continents to sea level. If erosion is that fast, then where's all the evidence of canyons and valleys in the walls of Grand Canyon? They're not there, indicating that one layer is laid rapidly one on top of another with no millions of years involved at all. So here's a little schematic of the Grand Canyon. Let's say this is just for 1 million years. And here we have the bedrock of the upper crust, and we have 4 layers deposited over the whole Grand Canyon area, 200 and some odd miles. Then we'll give it, say, 100,000 years of time, and this is what would happen. You erode valleys and ridges, and then suddenly it will say it dropped below the sea, and you had more layers deposited. It'd fill up the valleys like this with more layers. And then you do it for another 100,000 years exposure, and more valleys are cut, and so forth and so on. This is sort of what you see. If it's just 1 million years, or maybe just 100,000 years, you should see huge amount of valleys and canyons in the walls of the Grand Canyon, especially since the uniformitarians claim that these layers, these formations, are a lot of times terrestrial formations or shallow marine formations. Usually that, and in those environments, you'd expect a lot of canyons and valleys to be cut. But this is normally what we see in the Grand Canyon, generally layers that don't change thickness all the way across, but some layers will change thickness a little, pinch out, few pinch out, and that defies secular science. And we see this pattern everywhere where we see sedimentary rocks. We see layers. The deformation or the breaking up of those sedimentary rocks occurred after they were all laid down. Then you had faulting and erosion of them, but they're laid down generally without little deformation at the start. And up in the Grand Teton Mountains of Wyoming, I got a book where 3 geologists admitted this. So here's a sequence of sedimentary rocks right in here, one layer on top of another. That's the top of Grand Teton Mountain, which is granitic or gneiss that's been bowed up, but on the north and south edges, the sedimentary rocks were not washed off. And here's a thickness of about 3,000 feet, or about 900 meters. That is almost the same as in the Grand Canyon, 1,000 kilometers to the south, same sedimentary rocks up here. And there's one layer right after another. This represents maybe about 190 million years in the secular time scale. Anyway, these 3 geologists in this book, the Chronicles of Jackson Hole and the Teton Range, said the regularity and parallelism of the layers in well-exposed sections that I just showed you a picture of suggests that all these rocks were deposited in what? A single uninterrupted sequence. Yes, that's what they say. That's what you look like. That's what we observe. Do they believe it? No. You say, however, the fossils and regional distributions of the rock units show that this is not really the case. They go to their theories of deep time, the millions of years, stretch out everything. The incomplete nature of the stratigraphic record becomes apparent when the spans of time represented by each of the various formations are plotted on the numerical time scale. And this is their time scale. Most of it's missing time. The blue is the time for the formations. And here's the formation names up here. Here's 80 million years missing. Here's their time scale right here, 500 million up to 300 there. And I might add that when you look at these individual formations, it looks like maybe this one was deposited in 10 million years, but you find out that even these formations are full of gaps of time. So you should see little white areas all through these formations, so that when you add it all up, and secular scientists admitted that, they only have 1% of the record of time, 1% about. The rest, 99%, is totally missing. And the important thing is there's no erosion between these layers over about 180 million years. The Flathead Sandstone being the bottom formation in the Cambrian, on top of the Proterozoic granites and gneiss of the upper crust. So, evidence from fossils. Now, I might add that when we talk about Grand Canyon, I put the deposition of Grand Canyon and practically all the sedimentary rocks in phase 2. I believe phase 1, when the mechanism was unleashing turbulence and a lot of chaos, but not everywhere, that you form deep basins. And so the only sedimentation that occurred during phase 1, I believe, is in deep basins, forming your Pre-Cambrian sedimentary rocks, which I have come to believe are from the flood. Why? Because up in my area, here in the Northern Rockies of Montana, I'm privileged to be next to one of the biggest Precambrian formations in the world called the Belt Supergroup. And that Precambrian formation, dated 1.5 billion years according to the secular timescale, is conformable to the Flathead sandstone right above in numerous places, as if there's no change in sediments. And it's just one big deposition from the Precambrian up in through the Cambrian and the Ordovician and all the other rocks that you see on top of it. So that's, to me, pretty good evidence that the Precambrian sedimentary rocks are from the flood. And it's interesting, practically all Precambrian sedimentary rocks are found in what were used to be basins, deep basins, like the Belt Supergroup was deposited in a basin 25 kilometers deep, big hole. I think it's an impact crater, and so do 2 other secular scientists, filled up rapidly with sediments coming from the west off the current Pacific Ocean, I might add. A lot of details can be filled in, and I'm kind of doing this as I go because there's a lot more research. I'm just giving you a quickie summary. But so this, I think the real sediment that started in the Cambrian, the flat sediments with little deformation, as you saw in the Grand Canyon, they had to be deposited during a calmer period of the flood. And I think it was during the ascending phase when the chaos of the flood, of the mechanism of the flood, lessened a lot, so that all the churned up sediments, instead of moving in the water column, which is probably very deep, now settled out. And in all those sediments, we have fossils. And, you know, when we look at the details of fossils, they're strongly against uniformitarianism and show the flood. First of all, how to form a fossil? Well, you have to bury it rapidly. So that's one thing. Not only must it be fossilized rapidly before decay sets in. And right now, fossils are hardly ever forming. You can form them in hot springs areas with a lot of silicon dioxide. But even that is rare. There's hardly any fossils being formed up near Yellowstone Park, where I live near, due to all the hot springs and the silica and carbonate in those hot springs. And chemicals must be forced into the bones and shells rapidly. That's a pretty tall order, and that's one of the main reasons why fossilization is extremely rare today. And yet we have billions, if not trillions, of fossils out there. That's why I think Ken Ham's statement really has a lot of wisdom. He says, billions of dead things buried in rock layers laid down by water all over the earth. Evidence for the flood. It's exactly what we see. And not slow process of deposition. You can't form fossils that way. And we have these monstrous fossil graveyards. Here's a unique fossil graveyard from Venezuela of ammonite fossils. And then up in my area, we have a lot of dinosaur graveyards. North of me, about 150 kilometers, is a graveyard of 10,000 duck-billed dinosaurs, all of the same species, I might add, with no babies or young juveniles, all older adults and older juveniles, which is an unusual feature. There's a number of unusual features on that dinosaur bone bed. But there's a number of other bone beds in Alberta and some in Wyoming. There's lots of dinosaurs around here. That's why I've written one children's book on dinosaurs and one layman's book on dinosaurs. And we also have indications of rapid fossilization, fish eating fish in various locations, and an ichthyosaur that was fossilized in the process of giving birth. So these are indications of rapid deposition. But one of the strongest evidence of rapid deposition all over the world are mollusks. 95% of fossils are mollusks, like clams, and that'll include brachiopods and oysters. And anyway, it's interesting. Most mollusk shells, when you find them as fossils, are closed. But when a mollusk dies, the muscles that keep the shell closed detach, and it opens up quickly and it decays, because even the shell is made of partly organic matter. So it doesn't take, it takes days, maybe weeks for the shell to open up. The fact that we have so many closed shelled mollusks all over the world indicates rapid deposition globally. And here's a sample from Washington State, where I was raised, Seattle, Washington. And these are clams, brachiopods, and oysters found in just fossils in Washington State. Okay, now we're going to transition to evidence from geomorphology, the study of the surface features of the Earth. There's a whole lot of surface features that defy uniformitarianism. They can't explain them. And let's go back to this diagram. I've talked about mainly, especially phase 2. That's where most of the deposition occurred on the continents, and even twice as much as we see, as I found out. And by the way, this is a recent discovery I made about the amount of sediments that were eroded off. But we're going to transition to the retreating stage. The waters are running off the continents. The continents are rising, the ocean basin's sinking. Just think of the potential energy where you have water pushed up and then water going down. You can have tremendous movement of the currents and causing tremendous erosion, which we infer from a lot of indications in the sedimentary rocks. There's a lot of ways to determine the amount of erosion, and I'm working on one research project that we hope to send out to the Creation Research Society here soon on the cementation of sandstones that give you an indication how much pressure of sediments were above that were eroded, to explain the thin section analysis of these sandstones. So the retreating stage. So I'm going to start with phase 4. And I'm not going to talk about all the evidence for the mountains rising, the valley sinking down. Lots of evidence for that. So that's a whole different subject, but we'll just transform into the landforms, the geomorphology part of it. So phase 4. So here's a block diagram I made quite a long time ago when I didn't know how much sediment eroded off. And here's the peak of the flood at day 150 would be this area up in here. And this represents all the eroded strata, retreating stage erosion. This is the current continental surface with a nice dinosaur fossil there at the top. And this is the current continental sedimentary rocks, 1,800 meters average. So I figured this is maybe 500 meters, even though in a lot of areas I was getting some big numbers. There's a lot of areas that look like they weren't eroded a huge amount. We don't know, because there's no erosional remnants or eroded anticlines to determine how much erosion. But there's other ways. We can tell from sandstone and the rank of coal generally too. And Peter Kleberg at Great Falls, Montana, and myself are working on this topic. But because of this new paper I discovered a couple of months ago in the scientific literature, this should go up as high as this right here. The amount eroded is the same as that, approximately the same as that left. Not 500 meters, but 1,800 meters were eroded off the continents. Wow. That is huge. And as it eroded, it left on the surface of the continents that we can see today various features of this erosion that the secular scientists cannot explain, even though they've been trying for at least 150 years. So the first one we're talking about is Planation Surfaces. I showed you that one in the Grand Canyon area. I think I might have another picture of it here, unless I deleted it. I have lots of pictures of Planation Surfaces. So let's first of all define what a planation surface is. Well, I have to go to an erosion surface. Erosion surface is, in the dictionary of geological terms, a land surface shaped and subdued by the action of erosion, which is really not saying too much, but especially by running water. What they're telling us is that the land surface has been shaped by erosion by running water. Oh, and that's kind of sounding like runoff of the floodwaters. Why do they say running water? Because a lot of these planation surfaces have rounded rocks on the top of them, left over after they rounded the rocks, and as the current slowed, it deposited what the stones that were being used to erode the surface. Rounded rock. I'll show you some pictures of all this. The term erosion surface is generally applied to a level or nearly level surface. Now, erosion surfaces can be kind of rolling, but a planation surface is generally dead flat, almost flat as a pancake. And I'm going to just mainly talk about planation surfaces because they're more so distinct. And here's one in north central Wyoming, in the Bighorn Basin, which is about 200 kilometers north-south and about 100 kilometers east-west. This is the northern part. You can see this sedimentary rocks dipping to the west. That's to the right here. I'm looking south. It used to probably be a area bowed up there and just sheared off, forming a planation surface and forming about 15 feet of rounded rocks, which are over here too. It continues over here. But it's been dissected by either late flood channelized erosion and or post-flood river erosion. So it leaves this as a small erosion surface. So up in my area and in adjacent Canada, it's the plains consist of about 4 levels of planation surface in relation to the Rocky Mountains, which are over here to the west. This is the high plains of Alberta, Saskatchewan, northern Montana, part of North Dakota. And it has generally 4 levels. We found out it was a simplification because this level right here, called the Wood Mountain Plateau, is in between the top and the second from the top, this green area. Anyway, this is the Cypress Hills right here. This is a continuation, Swift Current Creek Plateau. I'm going to emphasize mainly the Cypress Hills Plateau because it's the highest one. This west end sticks out 2,500 feet above the river to the north, the South Saskatchewan River, and the river to the south of Milk River. 2,500 feet high above the rivers. And it was probably continuous in here. It's about, here's the scale here, 100 kilometers. It's about 120 kilometers long and probably was continuous before late flood channelized erosion eroded it and or river floods from the Ice Age melting, catastrophic river floods. It's called the Cypress Hills, and it's probably about 20 kilometers wide on the average. Probably was continuous at one time. It's a high planation surface, dissected. Many planation surfaces are dissected. These are all planation surfaces right in here. This is the next level. It's been tremendously dissected into isolated, semi-isolated plateaus called the Flaxville Plateaus. All these plateaus in here, and even the ones lower down in this area, are covered by rounded quartzite rocks. And here's a rose diagram right here from the direction where the quartzite came from. You see directional indicators in the quartzite as well as in the interbedded sandstones. And this one said that the rocks that are found on the top of this Cypress Hills, as well as all these plateaus, came from the west-southwest. Another report said the southwest. Well, if we go down to the southwest, we go down to here. The nearest outcrop where you find bedded quartzite rocks is in central Idaho. And this is acknowledged by secular scientists and Peter Kleberg and I that have studied this extensively. Came from central Idaho. All these quartzite rocks on here came from central Idaho. I'm going to talk about quartzite rocks next after planation surface. So let's take a picture. Here's the Cypress Hills, the northwest part. your Reeser Lake. Here's a central part right here. Here has been dissected by a glacial river because I found huge erratic boulders of continental shield rocks in here, indicating ice age erosion. And here's the eastern part of the Cypress Hills right here, all flat as a pancake. You drive up on it, and that's what it looks like, flat as a pancake. And then when you drive to the north edge, here's another planation surface. I'm going to talk about the quartzite rocks driving to the north edge soon. This is that planation surface in the Grand Canyon area. Probably about 300 kilometers east-west and about 200 kilometers north-south, the area where it's eroded as a sheet, forming this planation surface. Here's the north rim of the Grand Canyon. I assume everyone can see my cursor, and the Grand Canyon's between in there. But anyway, that's a planation surface. I'll talk about the quartzite rocks when I get to that session. Anyway, all planation surfaces were once much larger in the flood, but they got re-eroded and faulted different altitudes and broken up so that now we just have remnants of these planation surfaces. Anyway, Lester King said that these planation surfaces, which is evidence of runoff of the floodwater as a sheet flow, phase 4, were once huge on all the continents, exactly what we expect during the flood on all the continents, runoff. He says a planation of extraordinary smoothness developed over enormous areas in all the continents. From it, most of the world's present scenery has been subsequently been carved by renewed erosions. Yeah, after it was formed, it got broken up, eroded into remnants, and partly destroyed, forming mountains. A lot of planation surfaces are at the tops of mountains. Here's a planation surface in north central Montana, flat as a pancake. They even have an airport to the left there that's not in the photo. And what we observe with planation surfaces today, they're being eroded, they're being dissected. Like this one, it's being eroded from a stream coming out of the mountains to the right, the Little Rocky Mountains. That's what we see. Planation surfaces are being destroyed, not being formed today. And here's what we expect based on uniformitarian erosion. It'd be slow over millions of years. So in dipping sedimentary rocks, which are fairly common on the surface of the earth, we have generally hard rocks and soft layers. The hard layers would end up as ridges, and the soft layers would be eroded with some of the erosional material left in the valley, unconsolidated sediment. That's what we should see everywhere if uniformitarianism is true. We should see no planation surfaces because they're not forming today, except where a river will come out of its bank and erode tilted rocks and can form a flat surface, but that's only local, very local. So we don't see that this today. Well, actually, we do see a little bit of this, and this can be formed by slow currents. But this is commonly what we see. Both hard and soft rocks sheared off the same, implying a very fast current, leaving rounded cobbles and boulders on the top. That's commonly what we see. So, summary, they're not forming today, they're being destroyed. They're against uniformitarianism, they should not exist, but they're not only common as erosional remnants, we have indication they are once much more extensive on the continents. They're worldwide, difficult, if not impossible, to explain by slow processes over millions of years of erosion, powerful evidence for the global flood. So I'm going to get into the second sheet flow, phase 4 landform. It's not quite a landform, it's more an erosional feature and depositional feature. The quartzite rocks spread hundreds of miles from their source. Now, a quartzite is a metamorphic sandstone. After you form a sandstone, you cement the sand, you have to bury it deeply in big, deep holes, and you have to heat it up to about 500 degrees centigrade. And what happens is, since the sand is mostly quartz, you recrystallize it and it forms a kind of a glassy texture. I think I have some pictures here. If not, I have lots of pictures, but only so many I have here. And then after it's buried, in fact, I don't think it was buried too deep, because I think a lot of these basins that were formed early in the flood, the rocks were hot and the water was very hot. That's probably why you don't find any Precambrian fossils. And I think probably acidic water in a lot of areas too. And as you deposit sand and you buried it fairly deep, not as deep as you think from the geothermal gradient down in the earth, it heated up to 500 degrees and formed quartzite. Then you had this uplift, differential vertical tectonics, where the mountains came up, valleys went down, and you eroded huge parts of this, getting down to the hard quartzite rocks. By the way, quartzite is one of the hardest rocks in the world. Can hardly break it open with a rock hammer. And this is the most resistant rock in the Rocky Mountains. The other rocks are fairly soft. And so in fast turbulent currents, they're going to pulverize, but round the quartzite rocks. And here's kind of the big picture: a sheet flow current hitting the northern Rockies of Idaho, western Montana, and eroding and rounding the rocks. They start off large. By the way, they are large. They're sometimes about that far, that much in diameter there. And then as you get further out, they get smaller and smaller. And they do. We found some in North Dakota 2 years ago that were only about that big. I have found them in central Saskatchewan. They're reported in southwest Manitoba, north central North Dakota. And if they came from central Idaho, we're talking about 1,200 kilometers from their source to where we find them out in here. Now what kind of rivers are going to deposit these rocks and spread them out there? No rivers, no uniformitarian river can explain it, especially when the Continental Divide is right here. All this, the source is west of the Continental Divide, and now they're across it and way out. You find trillions of these rounded quartzite rocks all over these areas. And then as the Continental Divide area came up, the current split. And so you have a water flow going through the Pacific Ocean, and then one continues towards the Mississippi River Valley. And so the current splits, and it's taking quartzite rocks from the northern Rockies and spreading them clear to the Pacific Ocean. I have found them quite a bit in Puget Sound area. I'm from Seattle, which is right there. I've even found them near Vancouver, British Columbia. And they're supposed to be out here in the ocean, even though we looked for them for a day and couldn't find them, around Willapa Bay, which is one of these little bays here in Washington. They're all along the Columbia Gorge. They're found on tops of the mountains in here. Anyway, there's a lot of sensational aspects. Anyway, here's where the belt supergroup forms right here. It's from the belt supergroup. And that's the source, generally source of the quartzite rocks. And so here's a plot of the quartzite rocks from northern Idaho, southwest Montana, and Wyoming. These big green areas are thick accumulations. These accumulations occurred in a deep crack in the rock and piled up rounded quartzite rocks. And here east and northeast of Jackson, Wyoming, the quartzites are 11,000 feet thick. And yet, the state geologist of Wyoming says 80% of it's been eroded. So it's probably about 20,000 feet thick at one time. And all this area got eroded, spreading them way out in here. And here's the Teton Mountains right here. There are quartzites on the very top of the Teton Mountains, like right here. We took a 3-day hike up here. And here they are. Here's some of the quartzite, rounded quartzites. The northern Tetons are some of the sedimentary rocks that were not eroded off the upper crust. It's the top of it's limestone, but the rounded, and it's angular, and the rounded rocks are quartzites. The largest one I found is this. Notice how rounded it is from the water of action. Now, how did these rocks get on the top up here? I think it's because they spread first and the mountains came up. So it gives us a timing for some of the mountain ranges in the northern Rockies. And here's another one on top of the Teton Mountains. And it's interesting that these quartzite rocks, no matter where I find them, I find these semicircular cracks on them. Remember, this is one of the hardest rocks in the world. This is called a percussion mark, caused by banging of rock against rock. We can't duplicate this, so it must have been turbulent fast flow going 100 miles an hour, 150 kilometers per hour, in very turbulent flow, banging up, but some kind of a water cushion to form these. But anyway, the secular scientists agree it is caused by torrential flow, is the way one person described it. And yet these percussion marks on some rocks by the hundreds. I find them all over with these percussion marks, indicating the tremendous pounding that occurred by all this flow of these resistant rocks. And I might add, percussion marks are not forming today on quartzite rocks. Not forming today. It's against uniformitarianism. But it has powerful, it tells us powerful evidence for the flood. And here's a plot of all the ones in Washington State. I've been to many of these. And I want to focus in on, here's one at the top of the Blue Mountains, north of Burns in Central Oregon. And here's a bunch of them on top of the Wallowa Mountains, up to 8,200 feet above sea level. And they're draped over the tops of these mountains. In fact, they're so thick up there that they used to have a placer gold mine on the top of one of the mountains in the Blue Mountains, where they took the quartzite rock and all the finer debris in between, sent it through a sieve to find the gold. There is a lot of gold. In fact, this hill right here is called Gold Hill, because there's a lot of gold that is in with the finer particles in the quartzites. But they had to shut the mine down because it became a wilderness area. Anyway, and oh, by the way, I found them numerous places in the Puget Sound area, even on the San Juan Islands and up here near Chilliwack, British Columbia. And here's pictures. This is 8,200 feet on top of the Wallowa Mountains on a ridge. This is the quartzites right here on the top of this ridge. There's supposed to be one 1 meter in diameter, but I never found it. It's probably in this snowbank. But this is the largest one I found. The nearest source of quartzites 100 miles to the east across what is now Hell's Canyon, the deepest canyon in North America, even deeper than Grand Canyon, I might add. It's 8,000 feet deep on the Idaho side and 6,000 feet on the Oregon side, and it's about 50 miles long. So you can see some of the finds where the gold is found right in here, but that's the largest. That takes a tremendous current to do that. And look at how rounded and polished it is. And I'm going to the Cypress Hills now. All these Planation surfaces and ones I don't show here at lower altitudes are capped by quartzite. And this is the quartzite below this, the gravel of the glacial till, glaciation, out in this blue formation right here. Here's the Cypress Hills. It's capped by 75 feet of rounded rocks cemented together, forming a conglomerate. I'm here on the north edge of the Cypress Hills, looking down at the next Planation surface, which is 1,000 feet below me. You can kind of see what it's capped by, rounded rocks on a high plateau, indicating that this plateau probably was very extensive, north and south, east and west, and then it got eroded all around, just leaving the Cypress Hills an erosional remnant. Tremendous action and evidence of the flood, huge catastrophism. Here's a more close-up of those rounded rocks. There you go. I find a lot of them are iron stained, so this must have been a lot of iron in the water, probably hot water, so that the iron would stay in the water, and it coats a lot of these as a patina on these quartzite rocks. And here's some percussion marks that are really big on this quartzite right here. Here's the big picture. you had currents running off the Rocky Mountains. The Rockies were coming up, and it was eroding all the plains area. And it was eroding the plains. It deposited the quartzite rocks. Now, the medium-sized rocks were carried up in the suspension, come crashing down, forming the planation, the percussion marks. The larger rocks were carried along the surface, eroding the surface down. That's what does the erosion. They call them tools, geological jargon, and they erode the surface. And after the current wanes, it leaves a capping of these rounded rocks. That's how come you have 75 feet on the Cypress Hills. And based on civil engineering equations, open channel flow equations, we can put some minimum currents to these. A 6-inch bullet wide rock, which is like this, round and like the shape of a bullet, we figures this is the largest rock carried up in suspension and come crashing down, and implies currents over 65 miles an hour in water depths over 180 feet. So we put some numbers to these things. What is this saying? It's powerful evidence for the runoff of the floodwaters at high speeds, eroding, forming planation surfaces, then eroding those planation surfaces into erosional remnants. Here's a summary of the quartzite. They're spread 800 miles east from their source in the Western Rockies, west of the Continental Divide. They're spread 400 miles west of the Pacific Ocean. Percussion marks indicate torrential flow. Planation surfaces, long spread of quartzites. Percussion marks aren't forming today. Powerful evidence for the flood runoff. So this is the last feature I'm going to talk about, and then I'm going to open to questions and answers. I'm going to shifting to phase 5, the more channelized phase, where the water is forced to channelize around obstacles, forming more linear valleys and canyons rapidly, and a lot of times superimposed on the wide planation surface, like a Grand Canyon. You erode the whole area as a sheet flow, phase 4. And then you form Grand Canyon, Zion Canyon, and other canyons in southwest Colorado Plateau during the channelized flow phase. It's a great 1-2 punch, and one superimposed on the other. Exactly what you expect during flood runoff. So I'm going to talk about one landform for the channelized phase, and that's what's called water gaps. A water gap is essentially a gap through a mountain ridge or mountain range or even plateau where the water from a river or stream starts on one side and passes right through a gorge to the other side. They're called water gaps. And in my area, this is north central Wyoming. Here's a water gap right here through the Rattlesnake Mountains. Yellowstone Park is further to the west that you can't see, or maybe this mountain is part of it, but this is a range of mountains east of Yellowstone, and here's a gap, a cut through the mountains, kind of white at the top, and it narrows it to very, very much like Grand Canyon, and that starts out wide and goes very narrow. And this is about 2 miles to the end there. Now the Shoshone River starts in southeast Yellowstone Park, moves east out of the park, and comes to this Rattlesnake Mountains. Instead of going around it this way, like this, and come out near Cody, Wyoming, it continues east and cuts right through the Rattlesnake Mountains, which are 2,500 feet tall. That water gap's 2,500 feet, cut in hard granite, and the dipping sedimentary rocks. You see the sedimentary rocks dipping towards me, which is east. And there's granite in the center. Here's a close-up of it. Of course, they built a road through it. And in the water gap, they formed a dam. Good place to dam the Shoshone River. And that they did. Here's the water gap right here. Shoshone River goes through there. And here's the dam. Look at how low and wide that area is. The water, when the sediments were a little bit higher, say 100,000 years ago, the Shoshone River was running, it should have easily gone around those Rattlesnake Mountains there, out this way, and drained through the Bighorn Basin there at Cody. In fact, this is so low, they had to form another dam there so the water wouldn't run out. and that's where they get their irrigation water. But the river ended up going through there. Why? Well, you know, they don't know, but they have approximately four hypotheses for the origin of water gaps, which I've analyzed and published, which I'll give you some links on how you can get a hold of a lot more published information. And there's 1,700 water gaps through the Appalachian Mountains, so the ridges of the Appalachian. Here's a famous one north of Harrisburg, Pennsylvania. And this is the first of about 3 or 4 aligned water gaps, aligned in a curve, gentle curve like that. And you got to ask yourself, why did the river end up cutting through these ridges when it could have easily gone around the ridges? Because there are low spots that it just cut right through them. And there's 1,700 of them in the Appalachians alone. So water gaps, there's thousands of them across the surface of the earth on all continents. And I have analyzed them in southern England and in North America, including Alaska, west coast, east coast of the United States. And I've looked in the literature for places in Africa and Europe. They're there. Anyway, the guy did a PhD thesis on the Zagros water gaps in southwest Iran. And then he wrote a book. There's at least 300 water gaps in the Zagros Mountains, up to 8,000 feet deep, deeper than Grand Canyon, which is a long water gap. Grand Canyon is the longest, but not the deepest by far. The Zagros Mountains, the way he describes this is the rivers don't normally go down valleys like they're supposed to. Oh, they do for a little while. Then they cut through obstacles, mountains. And then not only do they cut out, they sometimes come back out. Really strange things. When I read this book, I was laughing all the way through it because they were all uniformitarian conundrums that can't be explained. And here's just one little quote from Thomas Oberlander, who's an expert on water gaps, I might add. The Zagros Mountain drainage pattern is distinctive by virtue of its disregard of major geological obstructions. Disregards them, both on a general scale and in detail, local scale. Certain streams ignore structure completely. Some, I like the wording here, some appear to seek obstacles to transect. Now, what kind of normal river is that? And this is not unusual. This is probably the best example in the world of the craziness of the drainage patterns of the world through water gaps. They can't explain them, even though they wing it. They try. They don't like to leave theoretical vacuum with no explanation. They always have explanations. You look at the explanations and you find out that they don't hold water either. And they're just winging it because they don't know what else to say. The deepest water gaps are in the Himalaya Mountains, where 9 rivers start in the southern Tibetan Plateau and they head for the Himalayas. And the mountains do cause them to, the rivers to form, go down the valleys for a while. Then suddenly they cut right through the mountains in deep water gaps. There's one water gap east of Mount Everest that is 4 miles deep, the Aran River that cuts through the Himalayas into the Indian Ocean. By the way, we have an analog for water, formation of water, and another thing called wind gaps, which I'm not going to get into. There's a lot of things I can't get into. I mean, I can write a 5,000-page book on all this. We have an analog in the Great Lake Missoula flood, in the Channel Scablands of Washington, my home state, which I've done a lot of research. I have one book and one DVD out on this topic. For Glacial Lake Missoula, 500 and some odd cubic miles of water by an ice dam in northern Idaho broke and emptied in 2 days and spread through eastern Washington, cutting up into deep canyons, flat bottom canyons called coulees there. And J. Harlan Bretz pointed this out in 1923. And no one believed him for 40 years. And they're all against him, as this quote says. They rejected it because they don't believe in floods this big. It was too biblical, some people said. We just don't believe it, period. Until they went out there. And then we had overhead pictures, and we could see ripple marks and gravel and many other features of flood, big gravel bars. But anyway, in the southern part, here's a Snake River right here. So I'm going to jump down to this right down in here. And in the Snake River, which is right here, between the Snake River and this Washtuckna Coulee, the Palouse River used to go down like this. But in the Lake Missoula flood coming down from the north, cut across this 500-foot high ridge and eroded in this area, about 8 miles wide here, and then narrowed down to a narrow canyon. After the flood, the Palouse River, instead of continuing down the Washtuckna Coulee, takes a left-hand turn through Palouse Canyon and into the Snake River. This is where a gigantic Lake Missoula flood formed water gap, as well as a wind gap over here I'm not going to talk about, in a monstrous flood. And here's kind of a summary of this. You had sheet flow transitioning into channelized flow. And so here you got flow, a sheet flow, going perpendicular to a ridge. The ridge is probably coming up and the waters are draining. Remember, the waters are draining during all this, and the mountains are rising. And no ridge is perfectly flat, so the low areas end up being eroded more than the higher areas. And with time, the tops of this ridge show, and it funnels the water through these gaps. And then when it funnels it through, the same amount of water has to go through a more narrow area that's to accelerate. And the velocity of flow is approximately equal to the fourth power of the erosion. You cause 10 to the fourth erosion with a doubling of the current speed. Erosions to the 10th to the fourth power of the velocity. And here it's going through here too. But then with time, shifting currents, other features that happened during the flood, a lot of chaotic things occurred. And so all the water ended up flowing in deeper and deeper, and this gave up. And so at the end, it formed a deep water gap where the rivers will end up going through. And this left high and dry would be a wind gap, only winds going through it. You find thousands of wind gaps on ridges in the mountains too. So this can easily be explained by the flood, these water gaps. Yet they have 4 hypotheses which have serious problems. So I'm going to get back to why can't mainstream scientists see it? Why can't Davis Young and other geologists that teach on Christian campuses, but teach you evolution and deep time and uniformitarianism? Why can't they see it? Well, I think it's a psychological phenomenon. There's room for psychologists in all this. I picked this up from a book called The Promise of Sleep. Being a shift worker that worked rotating shifts for 30 years, I had sleep issues, so I wanted to know how to deal with it better. So I got this Dr. William Dement book. He was a professor at Stanford University. He was one of the discoverers of REM sleep. He says on page 34 of his book, by the way, you can get quotes from geologists that say the same thing. Even when they are looking, people usually see only what they expect to find, and they do not see what they assume for whatever reason could not exist. So those professors that teach on Christian campuses that got their education at secular universities got essentially brainwashed in uniformitarianism. So they got uniformitarian glasses on. So all they see is slow processes over millions of years. They don't see catastrophism out there, the tremendous evidence for the flood. And I only gave you a little tiny bit of the evidence. It's a psychological phenomenon. They don't believe it exists. They don't see it. Interesting. And by the way, one of the reasons that attracted me to this area is I was a weather forecaster for 30 years in the National Weather Service. And I did this to a lot of people. I ruined probably thousands of picnics and outdoor activities. Today's forecast, 100% chance of sunshine and pouring down rain. But of course, you know, the period of verification is 12 hours, and after the rain goes, you might see some sunshine. So in a way, it could verify. But anyway, tell me why I should trust scientists when they can't even tell about the Earth over millions of years, when they cannot barely forecast the weather. By the way, we're doing a lot better job forecasting the weather, I might add. The models are doing, computer models are so much better. Anyway, if you want to know more about this, this is a summary of generally what I said, but more. And that is just a summary too. How Noah's flood shaped our Earth, just kind of an outline starting from before the flood and going through the phases of the flood in chronological order, and then talking about the ice age after the flood caused by the flood. And I've even written for children to explain a lot of this geology, exploring geology with Mr. Hibb. We have one about dinosaurs too. You can get it from Creation Ministries International. And I just wrote a book just recently about the time issue. I didn't get into that here. That's a whole different topic, lots of problems. It's called The Deep Time Deception, Examining the Case for Millions of Years. So I recommend those 3 books for those that want to search more. I want to read you, leave you with a Bible quote from 1 Corinthians 2:5. Your faith should not rest on the wisdom of men. The wisdom of men trying to figure out earth science without God is where they get evolution, deep time, millions of years, and uniformitarianism, all under the aspect that God does not exist. We should not have our faith depend on that, but on God's power. God has the power to create, cause a flood, and all the miracles in the Bible are no sweat to him. If he can create the universe, it's a small thing to create a lot of aspects of the earth and do miracles. And here's some websites I want to leave you with. This is the final slide. Creation Encounters is a group that does tours in the Western U.S. if you ever want to get involved in a tour. And probably most of you heard of these 4 major sites. Creation.com is CMI, Creation Ministries International. That's the one I mainly do my research with, but then there's Creation Research Society also, do a lot of research. And I want to mention my website. On my website, I have 2 free ebooks in color. I have one about 800 pages, I think, going through what I've just talked about in more detail with color pictures throughout it. And it'll give you a lot more information about the runoff or the retreating stage of the flood. Then I got a second ebook on where is the flood post-flood boundary. And I go through about 32 evidences that it's in the late Cenozoic, assuming the geological column, but not any one spot because we can't depend on their precise dating methods. Generally in the late Cenozoic, which is defined as the Miocene, Pliocene, Pleistocene. And every area has to be examined on its own merits. I've seen places where it's probably in the Miocene and other places it's in the Pleistocene, using the geological column as a template. So now I will open it up to questions, and that's the end. And so.
Well, thank you, Mike. Let me remove this from the screen real quick. And I have to say that was looks like you're good. I got to say that was a remarkable presentation.
Yeah, well, thank you.
You're good.
How do I get off?
I think you're. Yeah, I think it's not shared anymore, so you should be good, Mike.
Okay. All right. I gotcha.
Awesome. Let me adjust my mic here. And I mean, just like the title of your lecture there, there's just so much astounding evidence for the global flood.
There is.
It brings me, it's amazing. And it brings me to 2 Peter 3, where the scoffers are willingly ignorant of the world that then was being overflowed with water perished.
Right. Mm-hmm.
I just wanted to say God bless you for all your amazing work and research. You know, I'm not the only one who agrees that I very much appreciate it. And I like the way you ended it. you pointed out that it is a psychological issue.
Mm-hmm.
And as you said, you could literally write a 10,000 page book on this. I've got a couple here that I'd like to recommend as well. Frozen in Time, on the mammoths. That's a great book.
And the Ice Age.
Yes. Yeah, and the Ice Age. This one has been a huge help for me. Rock Solid Answers.
Mm-hmm.
I think you co-authored this. So especially for the audience, we've got
edited on that with John Reed. We got a bunch of creation scientists to give us 14 geological challenges, and we gave answers about fairly detailed answers, and about an average of 20 pages each.
Yes. Yes, I felt they were very technical, very detailed answers, and it's a book that I wish everybody would have on their bookshelf. So, real quick, I want to say we've had a lively audience. We've got a ton of questions, ton of great questions. You've answered a lot of questions too, just directly in your lecture and presentation there.
Mm-hmm.
I hand it over to George. I don't want to dominate the mic, George. Maybe we'll have you. You've done a great job gathering the questions, George. Maybe you had a couple comments you wanted to make on the show, and then if you want, you can have the opportunity to ask the first question, George.
Oh, thank you. I'm just going to give you the standard secular sort of answer to this. Sorry, Mike, I'm not convinced. There's no evidence for a global flood. But seriously, I was interested in the mega sequence of the sandstone that you've shown, but there are far larger sequences than that. And I'm referring to the limestone, which effectively there's evidence for it from England through Europe, the Middle East, through to America, and then even Australia. And that sort of leads me to a question that we pose to most of our guests here, specifically John McKay and some of the other geologists that have appeared on our show. They suggest that limestone is predominantly a chemical process.
Mm-hmm.
We've even observed it forming during volcano eruptions.
Really?
Do you have any thoughts on this and how possibly the heat could have assisted in this formation?
Yeah, limestone, let's see, it makes up about 15 to 20% of sedimentary rocks. It's a chemical precipitate. There's a lot of organisms in some limestones, but it mostly looks like it's a chemical precipitate. I must say that right now, since I'm up on all the research, we really don't have a good answer for, I'll say carbonates, because there's more to just limestones. There's dolomite. And I'm thinking that there's so much carbonate there around that I think a lot of it came from below the ground in the fountains of the Great Deep. Same with a lot of other unique chemicals we find, like iron, banded iron formations, chert, silicon dioxide, and iron oxide layers, and also we have unique sands as well as limestones and dolomite. And it's interesting that you have a huge amount of carbonates in the Pre-Cambrian, and also dolomite. And we don't really, the secular scientists, I don't think they really know where all this comes from, but I think it had to come from below the ground in the fountains of the Great Deep, because where else could it come from? I think a lot of other chemicals came from the fountains of the Great Deep and explain a lot of these unique Precambrian formations. This is an area I'm doing research on. Dolomite, which is calcium magnesium carbonate. Mostly you find a lot of it in the Precambrian and Paleozoic, and it decreases Mesozoic and Cenozoic, using the geological column as a general template, which I do believe in a general geological column with exceptions. Dolomite, I'm trying to find the conditions of when it could precipitate. Apparently, there is some research, but they all think it's the replacement of limestone at ambient temperatures we find on the surface today. But I think it's a precipitate. Some of these dolomites cover huge areas and can be over 1,000 meters thick. And so it has to be a precipitate, and early in the flood, and mostly. And the temperatures are well over 100 degrees centigrade. I think this is giving us a hint that the early floodwaters, especially in deep basins, were hot, and therefore dolomite formed. And I think even a lot of carbonates would form with these temperatures and temperature changes in the water. So those are some areas I'm working on. And remember, this is all part of the early flood for me, and it tailing off through the flood, and for the carbonates. And so it's a research project that I'm working on actually right now. I'm reading a lot of papers on dolomite, but I'm frustrated because they don't get to the point of exactly what you need. Dolomite is not only interesting in that it's magnesium carbonate, but it's also, you have to have the right proportions of 50% magnesium, 50% carbonate. There's a lot of them that are formed today in tidal pools in southern Australia, and it's called sapkas in the Persian Gulf. But they're formed by microorganisms, help them form. But there's a tremendous barrier for magnesium forming dolomite, a kinetic barrier, as they say. But heating it up 100, 200, 300 degrees centigrade gets rid of that barrier. And not only do you have the barrier, you have an ordered arrangement of you have a layer of calcium, carbonates, magnesium, carbonates. It's layered. It's called ordered. And a lot of the dolomite we find is ordered. And that is very difficult to form today. Oh, actually, it doesn't form today. And even in the lab, it's difficult to form without microorganisms. So carbonates are very interesting, and I'm doing active research on that right now.
Well, Mike, I'd like to follow up. In terms of, thanks for that honest answer, by the way, but I'd like to pose to you the secular explanation. They have limestone forming at 1 centimeter to 15 centimeters per 1,000 years. Yet we find it hundreds of meters thick in places, and it's pure.
Yeah.
So when we talk about an honest answer, what is there? You can't sort of argue that is an honest answer, that hundreds of millions of years and all you got was lime deposit and no other sediment mixed with it.
That's a problem they have all through the formations that they talk about, whether they're talking about chalk or thick sandstones. I mean, it's a typical problem in practically every sedimentary formation in the world. So, yeah, it's pure. And yeah, they go about 1 centimeter, 1,000 years is about their typical deposition rate. And so we would probably form it by chemical from hot going to cooler water, just dumping all at once out of there and precipitating in big, thick areas is kind of how I look at it at the moment.
Actually, George, if I could jump in there real quick, just because before I forget, this is a question that a lot of people have. So I take all these questions into one, and then I know you had a follow-up in regards to heat, George. So maybe after I ask this, just so I don't forget, you can jump into that question, because I've read some of your work on this, Mike, in regards to the KT boundary. So I and a lot of other people were curious as to your thoughts on the KT boundary and the associated iridium layer. How do we fit this into the global flood model exactly?
Okay, boy. First of all, I don't see the KT as being the flood post-flood boundary for lots of reasons. You can look in my website in that free book. I give you 32 reasons. Tim Clary gives a couple more reasons. So there's about 35 reasons why it's not down there. And I've been actively working on the fossil issues that have been given to me as challenges. For instance, Australian marsupials. And so the KT boundary is, they define it by an iridium layer, but I think, if I recall, I wrote an article on this about 25 years ago in Journal of Creation. I'm thinking that those iridium layers generally, they're probably not at the KT exactly, but they moved the KT to those iridium layers in some cases. And I think there's an iridium layer, and the iridium layers in some places are very thick and they're not thin like they're supposed to be. And they don't find the iridium around the supposed impact in the northern Yucatan Peninsula, the Chicxulub impact crater. And I think you'll probably find, if you'd look, a lot of iridium layers all through the sediments, but they don't look for them because they don't think they're there. So they only look for them around the KT, and then of course they find a bunch, and sometimes they don't line up with it, but then suddenly the KT drops down to where that iridium is. So I think there's a bit of circular reasoning in all this. And I think there's a lot more iridium layers in the sediments than you find at what the supposed KT. Those are some thoughts on that.
So
I think I answered part of your question, but there's a lot of aspects that shoot off from that.
Yeah, that's fair enough. Just because we don't know the answer now doesn't mean we won't find it, which is what they tell us a lot of the times when we ask them the tough questions. But Mike, we constantly hear this argument from many of the critics. They will frequently avoid answering all the astounding lines of evidence for a flood by pointing to a heat problem, which you've probably heard before. So yeah. What are your thoughts on this common criticism of the global flood? And I'm curious, does your theory of vertical plate tectonics have a solution to the often mentioned heat problem?
I think all flood models have a heat problem. The one I lean towards is meteorite impacts, probably about 1,000 of them, followed by differential vertical tectonics, and that drains the floodwaters. But there's problems with that model. I'm doing a little bit of research here, off and on it. But I do see evidence for catastrophic plate tectonics too. So I favor that about 20%. And I see. Since I read the current literature and even the old literature I've been reading for years, I find tremendous problems with plate tectonics that no one hardly knows about. Yeah, they sweep it under the rug, but we need more research on that. But there is evidence for it. And there's evidence for impacts. They claim there's about 200, actually 190 is the last I just looked here a few days ago. But I think there's evidence for many more that they ignore because their criteria is so stringent. So with catastrophic plate tectonics and impacts, we do have a heat problem. This is acknowledged. And at this point, we haven't got a good solution to that. Now, Russ Humphrey's working on some exotic idea about the expansion of space absorbing the heat, but I don't know. I'm kind of unsatisfied with the little bit I know about that. Another one is that, God's in control of the flood. You got to remember, Psalm 104, 6-9, he started the flood and he ended the flood. And also it says, I think Psalm 22, is it? He sat as king of the flood. He was in charge of the flood. So I'm assuming he took care of the heat problem. I'm giving it in God's hands. Now, people might think that's a cop-out, but that's a result of a lot of thinking on this. And we actually do have some evidence of that in the form of pleochoric halos. The work of Andrew Snelling indicates that plutons cooled dramatically in a matter of days. In other words, we had some kind of rapid cooling of the heat. And if that happened for plutons, which are big granite masses, it can happen all over the world. But I'll tell you, the secular scientists won't accept that. But we believe in a God that is all powerful, and I have no problem with it. I mean, if I could find a solution to it, I would. But all flood models have a heat problem. I readily admit that. Even the one I lean towards, and which is the impacts followed by differential vertical tectonics. So that's about all I can say on that.
I like to point out, Mike, and that was a great answer, great responses so far. I like pointing out the fact that heat is necessary for the flood, as in heat and energy are required to get the plates moving in the first place. So the point I'm trying to make is the heat it's not really a bug, it's an actual feature of the flood.
Right? Yeah.
And we don't necessarily know the temperature of the Earth's core in the pre-flood world. So a lot of that heat and energy may be in the core right now. So
yeah, there's one idea out that the heat ended up down deep in the mantle and the core and heated up the Earth. That's an idea worth pursuing.
Right.
Yeah, I just don't know how it'd get there though. But I'd have questions on that. But that's a possibility.
Right. Great answer. George, did you have anything to add, or did you want to move on to one of these other questions we have here? I've got a bunch I can. Well, I'll say this, because once again, there's a lot of questions that I can kind of just take, Mike, and just fuse into one. And this is a common question that people have, and I know you're no stranger to it. So what is the best explanation for the ordering of the fossils in the so-called geological column? Because we know that the evolutionists will say that the ordering reflects evolutionary history, right? From simple organisms to man and more complex organisms. So what's the best explanation for that ordering, do you believe?
Well, first of all, you can challenge the evolutionary idea of going from simple to complex, and that nothing is simple. Every organism is exceedingly complicated, and you go from exceedingly complicated to exceedingly complicated. You might think that there might be a little bit of transition there from bacteria up to single-celled up to man, but even the lowly trilobite at the very bottom in the Cambrian, as well as in the Paleozoic, its eyes are compound eyes, hundreds of lenses, double lenses that have to focus underwater. Their eyes, some people have said, are more complex than our own. Right from the beginning, and trilobite has no ancestors in the Precambrian leading up to a trilobite. It suddenly appears there, similar to all the other organisms and the gaps in the fossil record that indicate creation and the flood. So we can challenge them on a lot of aspects of the fossil record. As far as us explaining it, which, by the way, the Lord has led me over the years to not necessarily bash evolution, which I found easy, but to answer challenges that they give to us. So in that, I go along with generally what most creation scientists have surmised is due to ecological zonation. Vertical for one thing. You find a lot of bottom organisms first, and then fish, and then you come to the terrestrial organisms, which is a flood that affect the deeper ocean parts and come up and over the land. So there's a vertical ecological zonation in there, which makes a lot of sense. I think there's also a horizontal zonation, which I don't think too many creationists have thought of, that in one side of the earth you had maybe a unique ecosystem versus on another side, and that got buried at the same time, we'll say. But yet, because they're different, they would be put in different slots in the geological column. See, the geological column looks good on a local or even regional scale, but when you talk about a global scale, that's where you run into a lot of glitches. And so, for instance, flowering plants, they don't show up until the Cretaceous. And then you got to say, where were they in all that time before that? Well, it could be that they were deposited just as early as some of the older plants, the ones, the Carboniferous coal ones, but in a different area of the Earth, a horizontal zonation. Nobody's really worked on that too much, and there's a lot of things that could be explained by that. Diatoms aren't seen in the fossil record until I think about the middle Mesozoic. Where's all the diatoms that should be there before in the Paleozoic? There's none. There's radiolaria and there's foraminifera, but no diatoms. So this could be due to horizontal zonation. So these are areas of research. These are areas to explore. And so I would say mostly it can be sum it up mostly by vertical zonation. Some of the more exotic aspects of the geologic column by horizontal zonation.
SFD, can I ask a question?
Yes, actually, I want to say one thing there, and then I'll yield to you, George, because that was a really good answer, and I would agree completely. And I like how you pointed out that when it comes to the whole simple to complex, they are oversimplifying it, because that's not what we actually find. When we go to the first layers with an abundance of fossils in them, you know, we see no fossils, and then layers with every one of the body plans of the major division of creatures and animals.
Right, and even more than are extinct.
Right,
yeah.
Right. So I liked how you pointed that even a trilobite has a very complex lens system, and there's nothing simple about that. So,
right.
Yeah, great answer. Great answer. I apologize, George. Go ahead. You can ask
no problems. Just to give you an idea of the power of suggestion, all the talk about water and floods, I had to run to the bathroom for a few minutes, so I apologize. But Mike, I thought this was a good question from the Fifth Trumpet. He says, what date are you putting the world being destroyed by water using science? I think he's referring to the 4,500 years ago that the flood occurred.
Yeah, I'm just going along with Brian Thomas's article in the Journal of Creation, where he looked at it in pretty good detail, and based on the Bible, the flood was 4,500 years ago. So I think I've been using that ever since.
If I could jump in here real quick, actually, George, because we got what's called a super chat. So people will spend some money to ask an important question. And I want to get this in here because we've got a lively chat and I don't want to miss it. So I'm going to pop it up on screen. Sigi Fredo Sarabia, hopefully I'm saying that right. $10 super chat asks you a question, Mike. Says,
I see
I'm
it.
a heart. Oh, okay. As long as it popped up.
Is it a flat globe? Now, we're not getting into the flat Earth issue, are we?
No. So apparently, is that the question? Is it a flat? Okay, so I mean, that's an easy answer. The answer is no.
Right. In fact, if you want to know more about it, I would say check out Danny Faulkner's articles on AnswersInGenesis.org website, and he counters a lot of this. And I see a lot of evidence against it. It just can't be. And no, if we're talking about the flat Earth, it's not flat. It's not the flat Earth. It's a globe. Sorry,
right.
Mike, I hate to be blunt.
Mike,
it's a simple answer. Go ahead, George. I apologize.
Yeah, Mike, if I can add to your answer regarding the science of the flood, I think SFT has done quite a bit of work. So has Dr. Jensen on when it may have occurred using genetics, and we've looked at haplogroups, the study of mitochondrial DNA, Y chromosome. Mm-hmm. Which is further evidence for the flood. Correct, SFT?
That's right. That's right.
Yeah. I've only looked at that a bit, and since it's in biology, I kind of miss the details of it, so I'm really not in a position to get into that and very, very well. He's finding some interesting stuff, and he's related it to possibly the spreading out of the people from the Ark, and I found some good stuff there, but I have not delved into it too deep. So at this point, being a non-biologist, I'm going to have to say, hey, there's a lot of understanding I need to catch up on before I can really get into that.
That's fair enough.
That's fair enough. I've got a question here from the audience based on some of the things you were saying, some of the research you've been doing. Question, what's the most shocking thing you have found, Mike, in terms of fossils?
Fossils. See, what I've done most of my study in geology. I've been studying it for 45 years. Fossils are to me an incidental. Sorry, but shocking fossils. Let's see. I've seen a lot of dinosaur tracks. They're rather shocking in a way that, and I've seen dinosaur eggs, dinosaur bone beds, and there's a shocking aspect to all this in that people ask, well, they're live animals, and they have to be dead by day 150. So how do they make tracks and lay eggs on in the chaos of the early flood? That's a challenge we get, and now they find millions of these tracks and eggs, by the way, all over the world. And as a result, it was I think John Morris said once that he thought it was one of the most challenging pieces of earth science that one of our most challenging areas. So I spent a lot of time working on it, especially since I'm in dinosaur area right here in Montana. So I came out with a beds hypothesis, briefly exposed diluvial sediments, which I wrote in a book and several articles, where you find these shocking features in areas where there's thick sediments, like around Moab, Utah, very thick sediments. And then you have evidence of huge erosion above that based on erosional remnants and rhododendron anticlines, the rank of coal, and other indications of the amount of overburden. So the beds hypothesis works in that they're in areas of rapid deposition. And so as the bottom of as rapid deposition, here's the floodwaters here, and you're depositing more and more. And finally, the floodwaters become shallow. And the floodwaters aren't just a general rise and fall. They're going up and down like this based on tides, for instance, twice a day, and other features of tectonics. And so you have a sudden drop. And here you have this level, the bottom of the floodwaters exposed maybe for 100 miles. And you have creatures floating in the water or on log mats or from higher ground, the dinosaurs mainly that get out on those, lay eggs, make tracks, scavenge bone beds to leave their teeth in there, damage bones from their teeth. And then the floodwater rises and covers up all that. So it's called the beds hypothesis, and it's written in a book, Dinosaur Challenges and Mysteries, which you can get from Creation Ministries International. So that's probably the most shocking fossil feature that I've run into, and I think I got a good hypothesis for its explanation.
Mike,
I do find it interesting that you oftentimes find the tracks before you find the actual animals associated with the tracks.
Often, but not always.
Right. I also find it funny, based on what you're saying, these fossilized footprints or dinosaur nests, raindrops, which I feel would indicate rapid burial. But I've heard the critics use the argument that the fact that we find these things, for example, dinosaur nests with eggs, they say this is evidence against the flood, because apparently the flood would have destroyed things such as dinosaur nests. Have you heard this argument? I mean, what are your thoughts on that?
Yeah, I've heard that argument, and I've looked into it. First of all, there's hardly any real nests out there. I've actually seen nests where you find a depression with eggs in it on Egg Mountain, about 150 kilometers north of where I live. And that's one of the few nests in the whole world. Nest is defined as a depression or an area where you find evidence of vegetation placed on it. So you see very few nests. And I'd say you find less than a dozen re-nests. But the thing is, this is a tricky area because secular science define a nest as a group of eggs. That's a nest by definition. Or eggshells. They find an area, a bunch of broken eggs or eggshells, that's a nest. Well, no, that's not a nest. It's just a clutch or eggs. Practically all eggs are laid on flat bedding planes. And the problem with that, with no evidence of vegetation over them and not in a hole, except rarely. And I've seen the one major exception on Egg Mountain of a real nest with eggs in it. The problem with that is dinosaur eggs are very porous. And so sitting out there with no vegetation on it or not buried in a hole, they're going to dry out rapidly. And so I see this as evidence of dinosaurs laying eggs in a hurry on beds, briefly exposed to alluvial sediments, just on flat bedding planes, because they didn't have time to dig a hole. And they were swept off this area as soon as they laid the eggs, and then this whole area was covered up with muddy sediments to be preserved to where we see them today. See, preserving all this stuff is a major problem in the evolution, in the uniformitarian literature, because they like this, they believe in about 1 centimeter or 2 centimeters of deposition every 1,000 years is their general average rate of deposition. And so at that rate, how are you going to deposit all this material and preserve tracks and eggs with a deposition that slow? So they have lots of problems. And that's one of the reasons when I looked at the raw data, when I developed the beds model, and I do have evidence for that model, and that's one of them, the eggs laid on bedding planes.
Mike, coming from an engineering background, we've studied earthquakes and the effects of earthquakes, and you've probably heard of liquefaction.
Yes.
You can even do the experiment at home with sand, get an arrangement of eggs similar to how the dinosaurs would have laid their eggs, shake it, and it acts like a quicksand. The eggs will literally sink below the surface, and that would really maintain that structure and shape that the dinosaurs would have originally laid their eggs in. That's the way I explain it. I explain it through liquefaction.
That's a very good hypothesis. Yes, that's a good one.
Yeah.
I'll remember that because I hadn't thought of it.
That's why we pay George the big buck.
You can use it, Mike.
All right, thank you.
One thing I'll say, or a question that kind of came to mind, is we always hear the critics saying that young Earth creationists, flood geologists don't make any testable predictions, future testable predictions. How best to respond to this claim? And is it erroneous? Do young Earth creationists make testable predictions in terms of flood geology, the global flood?
Well, you got to remember, I was in the business of future predictions for 30 years. They paid me good money to be wrong. My weather forecast.
Right.
I'd say none of us really make predictions because this is in the past. If anything, they're what's called post-dictions, or what's that the term? Post-dictions. Anyway, they can make predictions on what you'd expect based on their model. And we would expect, we make predictions. We would expect layers laid over huge areas, and then the next layer laid flat on top of that, one after another in quick succession. And that's exactly what we see in the sedimentary records. They would say it all is formed by 1 or 2 centimeters per 1,000 years, or maybe it might occur rapidly in a catastrophe along a flood along a stream. But you look at the sediments in that, and nowhere near matches what we see in the rock record. Nowhere near, because it changes facies, as we say, different types of sediment in short distances, horizontally and vertically. That's what we see with floods today. But that's not what we see in the rock record at all. We see these huge formations over huge areas with little or no erosion between the layers. And they give them tens to hundreds of millions of years to lay down these layers at 1 to 2 centimeters every 1,000 years. And where's the evidence of erosion? See, their predictions could be falsified when we look at the bulk sedimentary rocks, which is where they claim that you can see evolution, versus we say they're deposited by Noah's flood, and this is what we should expect. And also we should expect billions of dead things in rock layers, buried in rock layers all over the world, and that's what we see. And their fossilization today, based on uniformitarianism, is extremely rare. You got to bury it rapidly under thousands of feet of sediment to get enough chemicals and depth to get the groundwater moving and replace the organic matter with chemicals, silicon dioxide or calcite, for instance. So we can make post-dictions, plenty of them, and they can, and I'd say we could verify a lot of our post-dictions.
Now, Mike, this comes from an atmospheric science point of view. Okay, we all know about the Lost Squadron, but
yes.
one of the questions is: do ice cores contradict biblical history?
I have a whole book on that you can get from ICR, examining the history of the Greenland and Antarctic ice sheet. I think is the title of it. Yeah, I go through all that. Like I said, the Lord's led me to lead challenge, and that's a challenge because they've made a lot of claims about those ice sheets. They're millions of years old. We can see annual layers in them, in the Greenland ice sheet down to 110,000 annual layers for 110,000 years. I'll tell you, that's a deep, long subject to take me a long time to go through it. But and then they claim there's 8 ice ages in what's called the dome sea core, based on oxygen isotope wiggles. There's just a lot I can say, but I'm trying to think of how to summarize it.
By the book.
Well, by the book you can get it in detail, but the annual layers, yeah, they're annual layers at the top. Right, we agree with that. But when you get down in the ice where it's compressed, pushed down and spreads out laterally, everything becomes thinner, and you have problems with diffusion. And then assuming what an annual layer is, see, they make an assumption what an annual layer thickness should be before they make a prediction, and they base it on that the Greenland ice sheet's been in equilibrium for about a couple million years. Antarctic ice sheet's 15 million years old, supposedly. It's when it's equilibrium, but it started 40 million years ago, or 35, something like that. And they would say, well, based on that, the annual layers should be about, well, let's see, about that thick of ice at the top. That's about right, 22 centimeters. And then as you get down, they get thinner and thinner and thinner until they're paper thin. They're about as thin as a dime by the time you get down to the bottom. You can imagine it might be kind of difficult to figure out an annual layer at the bottom, but it's that assumption that is locked into how they analyze these ice cores. And what they're measuring when they get down compressed, they're looking at storm layers, because storm layers oscillate back and forth in all these variables. And if you have a thick annual layer from our model, you don't diffuse those storm layers out. They're still there. And so we believe they're counting storm layers and intra-storm layers, things that happen within storms. Storms are complicated. They're just not a simple, like oxygen isotope ratio. Got the warm sector that with one type of ratio and the cold sector with another, but yet there's things in between that go on. So to upshot, they're counting storms and substorm layers as they get deeper, maybe about 1/3 down. Then they start getting into trouble. And but only the top 1/3 is only about 1,000 or 2,000 years anyway. So it's that deeper part. And so their assumptions kick in, equilibrium. And so that's how they do that. And as far as Antarctica, what they do is they assume the Milankovitch mechanism of the ice age, or the astronomical theory, and that cycles every 100,000 years. And they date deep sea cores that way, assuming that. And they go from deep sea cores, the wiggles in deep sea cores, to the wiggles on the Antarctic ice cores. So it's mainly based on assumptions for that. So I don't know if anyone understood any of that, but you're going to have to get a book. It's or I got articles on the websites about it, creation.com and answersingenesis.org have some articles I've written on ice cores. And Jake Hebert of ICR is working on a lot of details that I just broad brushed in the past of ice core buildup in the flood modeling. So you'll see a lot more stuff from him on that coming up. He's just starting to publish.
I'll add as well, and that's a phenomenal answer. Very good, especially on such a deep topic where, like you said, you can write an entire book on. So in a short answer, that's not always easy. But the book I'm holding up of yours, Frozen in Time, you have an entire chapter on this too.
Yeah, I have one chapter in that, but then I have a whole book, and I'll just. Frozen record.
Right.
Frozen record. Okay.
You can get it from ICR by print on demand still.
Awesome. I'm notorious for ordering books all the time. My wife knows there's always a package coming in the mail, so that'll probably be my next one.
Same with me, yeah. Can I ask a next question in SFT?
Go ahead.
But I'm gonna introduce Mike to one of my theories. Mike, do you know what caused the extinction of the dinosaurs? Just say no.
Okay, this is a joke. No.
They tasted too much like chicken.
Yeah, everything tastes like chicken. Rattlesnakes, rabbits.
Now, Mike, here's my question. This is a serious question. How do you best explain the big 5 extinction events in the young Earth creation worldview geochemically?
Geochemically?
Oh, that's the question here. That's what I've got.
Well, first of all, I think a lot of those extinction events are partly based on circular reasoning. Remember, I said partly. Why? Because they've dated a lot of layers by fossils. And so if you have a vertical sequence, you find one type of fossil in one layer, but different fossils above it. And in between, automatically would be an extinction event. And so when they have these major changes like Cretaceous to the Tertiary, there's different organisms there. So automatically it becomes a major extinction event. And there's lots of minor ones all through the geological column because different fossils are in different layers. So partly of circular reasoning, let's say the Permian Triassic boundary, it's because you have trilobites clear up to the top of the Paleozoic there in the Permian, and then none afterwards. And and then you find different organisms, more land organisms, dinosaurs. So you have a major gap in there. So yeah, it would be an extinction automatically.
Well, Mike, they can't say one extinction event because that'll look too much like a biblical flood scenario. So that's why they have to have like more than one extinction event.
Yeah, 5 major ones.
Yeah.
Now lots of minor ones.
Now, when we were talking about canyons and whatever, I'm sure you've seen the canyon on Mars, supposedly described as of biblical proportions on a planet that has very little liquid water. I find that ironic.
Yeah, it's interesting you would mention that, because I was going to write a perspective article on some new information about the channels on Mars, the journal Creation, and I got going, and it got so long that I'm going to make it an article. And so I ordered a book, The Surface of Mars, that to learn more about the surface features, so I can fit all these things in. Yeah, I've done a lot of study on Mars. I have, in fact, the stack is right down there. I just looked at it. About half a foot thick of papers. And I think I got a good idea on that. As far as you're talking about the I forgot the name of that deep canyon.
Mariana Trench.
Yeah, Mariana. Well, no, not the trench. The big deep canyon on Mars.
Oh, Mars. Sorry. I don't know what they've named it.
Marinara or something like that. Anyway, it's very interesting, and I haven't really looked at the origin of that yet. But the channels look like the channel scablands of eastern Washington, but 100 times the size. And this Marinara Canyon is 100 times the size of Grand Canyon. And I think about several thousand kilometers long. I mean, it's monstrous. And then they got Tharsis and Olympic Mons volcanoes that must be 10 times the size of volcanoes here on Earth. And they got a huge amount of meteorite impacts. So I'm thinking that the impacts and the volcanism occurring at the time of the Genesis flood due to a big impacting event released groundwater at a catastrophic rate to cause the flooding of those channels. That's my hypothesis. And I think I have a lot of evidence to back it up, and need to go into it in detail. And that's what caused me to have such a long article. And you're just talking about something that just happened a few days ago. It's interesting you mentioned that. It doesn't excite me to talk about Mars, but it could tie into the timing of the flood too, by probably one big impacting event over the whole solar system, I'm thinking. And so the flooding on Mars would occur at the same time as the Genesis flood. Anyway, I'm telling you about hypotheses I'm working on right now, and they can change with time. So don't take my word for what I said, which is speculation or hypothesis.
Well, that's what science is all about. And
yes.
I will say this, Mike, we've been going 2 hours and 10 minutes, and you've been so generous with your time and the Q&A. There's been a lot of technical, in-depth questions. So I don't want to keep you any longer. This has been really, really good. And I'm probably going to be re-listening to it tonight, because you gave so much good evidence during your presentation and some great answers. So let's not keep you any longer, since we've been going quite a bit. And what I can do is, we've got questions for probably the next week, Mike. So I could I'll save those maybe for another day. If we ever get the
or you can send me some good ones. I'd be interested in seeing what people think.
I will say this, maybe this will be a good one to end on, because you did answer this in your opening, but a lot of people have kind of just got here, and it's a question that has come in quite a bit. So maybe we can end with this one. We'll end on a good note.
Okay.
And it just came in again. So let me scroll up and find it. This seems to be a question that a lot of people are curious about. And here it is. The chat's lively, so if I don't get them in time, I lose them. But here it is. You did answer this at the end of your presentation, but maybe if you wanted to, you can add a little bit to it. But the question is, ask Michael Oard, where, in your opinion, from your research, everything you've studied, and you're up to date on the evidence too, where do you believe the flood boundary is roughly?
Well, the pre-flood flood boundary, I think the pre-flood includes below the Pre-Cambrian sedimentary rocks. So I'd include the Pre-Cambrian sedimentary rocks as part of the very early flood, deposited in deep basins that sometimes came up afterwards by rebounding to form mountains. A lot of these Precambrian rocks are in mountains now. Uinta Mountains, the Northern Rockies are Precambrian. And so I'd include them. So the flood pre-flood boundary would be below the Precambrian sedimentary rocks. Now, the flood post-flood boundary, I've done a lot of work over 25 years, and people could check my website. And it's under the drop-down menu of models. It's the fourth one. The runoff of the floodwaters is the third submission on there. And I've developed about 33 criterion for where it's located. And based on all those criterion, and I'll give an example here shortly. I put it up in the late Cenozoic, defined as the Miocene, Pliocene, Pleistocene of the geological column. And we can't use the geological column a precise place because I especially think the Cenozoic is all messed up as far as time-wise in the biblical creation model. And I've actually published a fair amount about that. So we cannot take like the Pliocene, Pleistocene boundary. And Pleistocene doesn't necessarily mean Ice Age, because there's some places where there's a few thousand meters of Pleistocene sediments, like the South Caspian Basin, for instance, several thousand meters of Pleistocene sediments. So those are not from the Ice Age. That's flood deposits. And in some of the deep valleys of Southern California, the Imperial Valley, the Santa Clara Valley, the Los Angeles Valley, you have deep basins in there that are filled with a lot of Pleistocene sedimentary rocks. So that's not from the Ice Age. So I have found in some areas that the boundaries in the early to mid Pleistocene in some areas, like the high plains of the U.S. I said that every area has to be examined on its own merits, because we cannot take a line in the geological column as this is the boundary. We can't use their structures. We got to go on our own merits. And that's why I've developed 32 criterion. Actually, I missed one. There's 33 criterion for where to locate it. And when I use that criterion, practically always find it in the late Cenozoic someplace, often in the early Pleistocene in places, but not always. So let's give an example. A good example is coal. Coal is the amalgamation of material from log mats that is beached and then sediments put on it and pressed down and forming coal by the heat. And coal has to have a fair amount of overburden to press it down. It depends on the rank of the coal. Like bituminous coal, you need about 2,000 to 3,000 meters of sediment on top. So if you find bituminous coal at the surface, you know you've had 2,000 to 3,000 feet of sediment put on it and then eroded down to it. So when you find coal, that is obviously a flood signature. I don't think there's any coal that I know of forming today. There might be in some local area, but as far other than that, it'd be very rare and isolated. But other than that, I'd say it's not forming at all. So if you find coal, that would be a flood signature. Well, we find coal, lots of coal in the early tertiary. We have a lot of Miocene coal in Southeast Australia. We have Eocene coal, that's early tertiary, in the Powder River Basin of Montana and Wyoming. In fact, 40% of the energy of the U.S. comes from the Powder River Basin, which has seams that are up to 80 meters thick of almost pure coal, and yet they're dated early tertiary. So the flood boundary would include that, and that puts it up into way up in the early, the late Cenozoic or the late tertiary. or Neogene for the Europeans, up there in the Neogene, way up there. In fact, you can almost say practically all the hard sedimentary rocks below our feet are from the flood, is what I've mostly discovered. So based on criterion like coal and erosional remnants, planation surfaces, quartzite gravels transported long distances, and many other features, not only from geomorphology, but also from fossils, fossil fuel, the volume of sediment. We have a huge amount of Cenozoic sedimentary rock, climatic data, nuclear winter, volcanic winter, things like this. These are criterion that obviously shows it's in the late Cenozoic. And I've written a lot of articles on it. Journal of Creation has a lot of articles on this subject by me. So I have actually researched it, and I have criterion to pinpoint it. And I've actually went to 3 or 4 areas to work on to pinpoint it. I must say that some areas are very difficult to pinpoint it. I don't want to simplify this, but most areas are easy, but there's some areas that are difficult to pinpoint it. And so I've done this in a lot of areas, mostly in North America. So that's where I put the boundary. And so it would generally include practically all the hard cemented sedimentary rocks from the Pre-Cambrian up to most of the late Cenozoic sedimentary rocks. So that's would be flood rocks, and that's based on research for all this. So I can back all this stuff up. And Tim Clary of ICR, I agree wholeheartedly on the location of it.
Well, I can attest to that, Mike, because I've gone through all of your articles on CMI, and you've looked into this extensively, and I really like your points and your criteria. I think your arguments are really strong and powerful and evidence-based. And I like the way you challenge, because I know there are some other people in the young Earth creationist camp who might propose the KT boundary as the flood boundary, but I think
mainly on fossils. And I've worked on that. I got a 4-part article that I sent into CMI just recently, including the Australian marsupials and some of the stuff about North American mammals. But so I've worked on it. They've challenged me. I'm working on it. But I expect people who believe the KT boundary to work on the challenges I've given them in geology and in fossils and geomorphology and tectonics and climatology. And it's interesting. Nobody actually tries to counter those arguments. I'm kind of funny. They almost seem like they ignore it. I'm just
I've noticed that. I've noticed that. That's why your arguments and your reasoning are lines of reasoning are very powerful, because I don't really see anybody addressing the geology. Do you think it comes down to, because like you said, it comes down to the fossils as to why some people put it at the KT boundary?
Fossils. So
is it coming down to the interpretation of that boundary as to whether or not it is the result of a comet, possibly, that the secularists look to? I mean, because I've seen some creationists say that maybe the iridium layers has to do with massive volcanic activity, possibly during the flood, that can result.
Possibly, but I don't think so.
Okay.
It probably are impact debris.
Okay.
And like I said, I think if you looked, you'd probably find iridium layers in a lot of places, and some of the places you do find them near the KT are maybe 4 meters thick. I mean, they're too thick to be a thin layer. They claim it's a thin layer of dust that spread from the Yucatan Peninsula all over the Earth, and should have been a thin layer. So, like I said, some of it's circular reasoning. Remember, I said some, partly,
right,
and some of it's because I think you'll find iridium layers in a lot of different places besides the claimed KT boundary. Now, one of the fossil arguments was done by Marcus Ross, where he said that for the Cenozoic mammals in North America, it's not likely that a mammal spreading out from the arc would come to their exact location of where their ancestors are found in the Cenozoic buried in sedimentary rocks. A reasonable argument. I've looked at it, and I actually, that was one of my 4 papers I've submitted. There's some problems with that. First of all, those mammals that you find either that are post-flood, come from the arc, or are from the flood in the Cenozoic, they're not unique to North America. You find some of those same mammals on other continents, both flood and post-flood. So it's not a unique situation where you find only certain mammals in the Cenozoic that are claimed by me to be flood, and then the same ones, their ancestors on top of them, in the same locations. No, it's not like that at all. It's a lot more complicated, to the point where it's really not much of an argument at all, as I will point out in that argument. It was submitted about 3 weeks ago, so it's going to take a long time. Some of these articles take a year or 2 to make it through the peer review. Oh yeah.
Wow.
Peer review and so forth, and to get published. So I'd say my average time is probably about, for an article, not a prospective article, even those, maybe about a year and a half average.
Wow.
So unfortunately, you won't see the results of this work for quite a while.
Well, I guess that means you're at least getting a lot of critical feedback and people are taking it seriously. So by the time it does get accepted and published, you know that it's based on some solid evidence. And you've got so many articles on CMI, which means they're all over the place, which means you've spent a lot of time writing, sending it in, and then waiting to get them accepted. Because I want to recommend to the audience, I mean, just go to, for example, creation.com, just type in your name, and the amount of articles that'll come up will keep you busy for forever. So I want to say, great answers, great technical answers. Everybody in the chat's loving this interview. I'm gonna yield the mic, and George, I'll give you the last word if you want to. We'll kind of wrap things up. We're now going on 2.5 hours, although 2.5 hours has flown by. I could probably talk about this stuff all day, to be honest with you. George, any final words there, brother?
Yes, we're big on critical thinking on this channel, Mike. But what I'd like to do, I'd like to put you on the spot now. While we're on air, live, and we've got 100 million viewers, I'm going to ask you whether you can come back in a month or 2 specifically to talk about the Ice Age. I think many people would be very interested in that. So the spotlight is on you, Mike.
Yes, I'll do it. The Lord has led me to do things like this, not only to try to answer challenges given to me, but to get the word out as much as I can. So yes, I take this as a high priority to talk to people about these things.
Okay. So,
by the way, speaking of research,
yep,
I still feel like I got 500 years left to go. There's so many pieces of research I can do. I have 15 projects I'm involved in right now, and I feel overwhelmed sometimes, and there's a lot more I can do that I haven't even touched. So for those people that don't have answers to particular questions, I must say that it's because there's not enough researchers out there to do the research, and I don't have enough time in the rest of my life to do 500 years worth. So, but you have to have patience. There's a lot of answers that are out there. So that's what I'd like to, and I'll come back and talk about the Ice Age for you coming up.
That would definitely be an honor. Yeah.
And Mike, feel free to use some of those solutions we suggested, but make sure you say you got them from that fantastic YouTube channel, Standing for Truth.
Okay, I like to give credit where credit's due. And if I ever use that one about the liquefaction for the explanation of, say, as a possibility for dinosaur eggs in troughs, which are hardly any are, I'll give you credit, George.
Good
Hey,
on
there you
you,
go,
Mike.
George. You're famous. You're famous. Yeah.
Standing for truth. Okay.
And the last thing I'll say is based on what you were saying, Mike. I always point that out too. Is we don't have enough hours in the day. All the different, even for us, for me, it's difficult because I've got the books, young Earth creation books on geology, biology, genetics, astronomy. You know, from all of you men of God who've done so much to defend the faith. So it's hard to choose on a daily basis. You know, what am I going to read today? What am I going to study today? So that's why it's such an honor to have someone like you on today, who's so well versed in these topics of flood geology, for example, to help us out, because this has been incredibly informative for myself, for the audience, and I think I could speak for George as well. So the last thing I'll say is thank you again, Mike, for your time and your presentation today.
I second that, and I hope and pray to God that He gives you the time and the years to undertake all that research, Mike. God bless you.
Thank you. It's a privilege to talk to your group.
Good on ya.
Awesome. Well, thank you so much, Mike.
That's good on you.
Yeah.
Good on ya.
I like it.
It's nice that we could throw in some humor within all the technical stuff. So,
oh yeah, you gotta have some humor.
Laughter's the best medicine. Maybe it'll keep us living till 500, 600, 700 years old, like our biblical ancestors, and therefore we can get more research done. So,
there's research saying you can live maybe 5 to 10 more years that way.
Maybe not another 300 years. Okay, yeah, awesome. I'm going to shut it down here, unless you had some final words, Mike. Thanks again for doing this.
No, you're welcome. It's a privilege.
Can I finish off by someone, when we were talking about trenches, someone mentioned the Marinara Trench. Because I have a pizza every Friday, I'm going to order a marinara pizza.
Ooh,
such a thing? I suppose in Australia, maybe.
Yes, that's a name for a seafood pizza.
Oh, it's another planet over there in Australia.
Good on you, Mike. Okay. It's been fantastic to talk to you.
Okay, good on you too. I like the expression.
Yeah.
Okay, guys. God bless. I'm glad that we had a nice, solid audience that stuck with us for 2.5 hours. And thanks again, Mike. And thanks for answering some very sometimes technical questions that require, like you've said, 10,000 books on this. So guys, thanks for tuning in. This has been awesome. Share around, please. We want to get this information out to as many people as possible, because this is the truth, and the truth is important. So everybody, Standing for Truth is out. God bless. All right, guys, it looks like we are live, and I want to thank everybody for joining us today on Standing for Truth. On Standing for Truth, we focus on the truth of biblical creation. And today we have an awesome guest with us. I am extremely excited that Michael J. Oard can be with us today for this incredibly important presentation and topic. Mike has done a great deal of amazing work on creation and the global flood of Noah. And he is best known for his work on the biblical ice age, which is exactly what we are going to be discussing here today, is the ice age. So I want to thank everybody in the audience. Please also tag me with your questions at Standing for Truth. That way I will see your questions. Typically our chats get lively, and today is definitely going to be a good show. So I am going to bring in Mike Oard and our award-winning co-host, George Bond. Thanks so much. Gentlemen, Mike, once again, it's so great to have you here.
Hi, you're welcome.
Well, I want to say, again, thanks for giving us your time for today's important show. And we have a lot of new viewers and subscribers since your previous presentation with us on the global flood and the recessive stage of the flood. If you wanted to take a few moments to give everybody a brief introduction as to who you are, maybe what you're doing in terms of creation research, and why you find this topic so important, Mike.
Well, we have a huge amount of challenges out there, not only from the secular world, the university, and even from our neighbors and friends on how do you explain this? How do you explain that? And so I deal with the questions on the flood, and there's a huge amount of questions of the flood. By the way, bringing the flood back to Earth history solves many of them. Now, some of them are unsolved, mainly because we don't have the data for a lot of them or the time to do it. But it excites me that we do have answers. And if a person is willing to be patient and check us out and see what we say about certain things, they would be most impressed. We have over 50 years of creation research that we've done, like the Creation Research Society Quarterly, Journal of Creation Answers Research Journal. So we have answers, and I'm just happy to be part of that. And so it excites me to do this. And there's a lot to do, as I'm sure a lot of people know.
Amen. Amen. Great introduction, Mike. And I want to recommend your previous presentation and audience Q&A with us to everybody in the chat. Anybody who's new to this channel, please check that out. I do have it in the description box of this video, as well as some links directly to some articles that you can find from Mike on the creation.com website. So we've also got George here with us. Thank you so much, George. A few introductory words from yourself.
Good morning. Actually, very early in the morning. By the way, SFT, I go to my mailbox every morning looking for that award. I still haven't got it. So, good morning.
I'm going to travel
morning,
to Australia and deliver it to you personally.
Yeah. Can I start the proceedings by saying it's a pleasure to have you here again, Mike. For those that haven't really had the pleasure, we had Mike around 6 to 8 weeks ago regarding the receding floodwaters. I urge those that haven't watched it to do so. It's in our playlist. For anyone who hasn't read much creationist material, you'll find Michael's volumes, and I mean volumes of papers and articles, is written on many creationist websites. His wealth of information and work is cited by many other creationists also. I believe, Mike, last time we spoke, you said you had a list of over 500 projects that you would love to complete. So I guess in your case, it's a work in progress, Mike.
Oh, yeah. I mean, I have about 15 projects going, but I keep saying I have 500 years worth of research left to go.
Well, Mike, true to my form, I always start off with a bit of a joke. You'll be happy to know that some scientists from Berkeley were successful in getting a grant in order to determine the height of a flagpole. So they looked and looked at the pole. They had their toolbox and their measuring tapes and everything, and they couldn't figure out how we're going to do this. We don't have a ladder that long. So a woman walked by and asked, what were you doing? What are you trying to do? We're supposed to find the height of this flagpole, said one of them, but we don't have a ladder long enough. Oh, well, the woman looked at the spanner and a tape measure from their toolbox. She began to loosen a couple of bolts at the base of the flagpole and laid it down on the ground, took the measurement and announced 6.5 meters and walked away. One scientist shook his head and laughed. He said, a lot of good that does us. We ask for the height and she gives us the length.
Yeah.
All right.
Very good.
Mike, back to seriously now. Having watched your video on the Ice Age twice now, I'll admit, I have to express my ignorance before having seen it. I was not aware of a lot of what you stated in that video, but rather than steal your thunder, I'll wait till your presentation. For those that are listening, of particular interest was how the mammoths and other mammals got to the far north, and the freezing of the mammoth's stomach contents and how they preserved in the permafrost. My research shows that as far north as Greenland, there is abundant evidence of moderate climate just 700 to 800 years ago. Now, creation research, our friend John McKay and Joseph Hubbard have a documentary on this called Fire and Ice. For those wanting to check that out and see what evidence I'm actually talking about, you can find that in that documentary. However, I'm sure our audience are here to hear from you, Mike, and watch you rather than me. So I'll let you take it away.
The floor is yours, Mike. We can get right into the presentation if you'd like to, and I can share your screen as well.
Okay.
Thank you for that introduction, George, as well, and a good joke to start us off with. I appreciate it. And here we go, Mike. I've got your screen pulled up.
Can you all see it?
Yep.
Yes. Looks good. Looks good, Mike.
Okay, this is my standard talk on the Ice Age. And the title is an Ice Age, only the Bible can explain it. Very provocative subtitle there, but I will explain it as I go. Anyway, there's hundreds of earth science challenges. And here's a list I just wrote down over a 5-minute period. Some of these I've worked on. Here's more of them. Anyway, the Ice Age is one of these challenges that the secular scientists give us. So this is going to be about the Ice Age. And through the Ice Age model, biblical model, we can answer some of these other ones that I've listed here. The results of these challenges, there's hundreds of them. I read about them all the time in the secular literature. They cause many to doubt God's word. And they cause tens of thousands of atheists and agnostics. Some of the people think these challenges are so solid that the Bible can't explain it. It's caused tens of millions of Christians to fit evolution and deep time into the Bible as a result. It's enhanced the local flood myth. It's resulted in a mass exodus of youth. So these challenges are important for us to answer. And this is what I spent 45 years doing. A closer look at challenges. Many do not realize that most of these are also challenges to evolutionary geology. When I research a topic, I find out that a lot of times when you dig below the surface that it's challenging to them. They can't explain it. In fact, there's numerous challenges to deep time and uniformitarianism. Also, we have to realize that we're not going to solve all challenges. And one of the reasons is because there's not enough known in the earth sciences. So we got to be patient with challenges and check into them and do research. And many really do not know that the creation flood ice age model has solutions to many of these challenges already. Some challenges take a long effort, long time. So it's not going to be done overnight. We have a lack of workers and funds. So those are some of the reasons why we have some unanswered challenges. Anyway, let's talk about the Ice Age. First of all, what is an Ice Age? Well, you can't really find much of a definition except that it's a great increase in snow and ice. Currently, 10% of our continents have ice on them now, mainly Greenland and Antarctica. During the Ice Age, 30% of the land surface was covered by ice, mainly in the high latitudes and locally down to the mid latitudes and in many mountainous areas. Also, was the last major event in Earth history. Last major event. And I'm going to come back and revisit that at the end. Okay, actually, there are 5 Ice Age periods according to the secular uniformitarian. There's the Pleistocene, less than 2.6 million years. The late Paleozoic, about 280 million. The late Ordovician, 450 million. Late Pre-Cambrian, several of them during that time period. Some of them supposedly are global glaciations, which brings up an interesting conundrum: is how do you glaciate the globe? And not only that, how do you melt it? big problems. I've dealt with these before. And also there's mid-Precambrian glaciation. So there are generally 5 major ice age periods. There's some minor ones in between. Anyway, it's the Pleistocene is the real ice age. And they claim there's 50 ice ages now in the Pleistocene, but it's mainly their last that is the one that's correlated to the biblical ice age. The reason for the other many is due to deep sea cores, wiggles in deep sea cores. You don't see that evidence on land. Anyway, the Pleistocene ice age is real, but only the last is equal to the post-flood ice age. The other 4 can be explained by gigantic submarine landslides during the flood, because they're from the flood. And I wrote a book about this quite a while ago, documenting this: ancient ice ages or gigantic submarine landslides. Anyway, here's the challenge of the ice age that they give us. Each ice age takes 100,000 years, at least in the last million years. Before that, it was every 40,000 years, they claim. The glacial phase is approximately 90,000 years, and the interglacial phase is 10,000. Now, we live in an interglacial phase right now called the Holocene. And there's been, like I said, about 50 regular repeating ice ages during the past 2.6 million years of various intensities. That's what they claim now. And that's the challenge that they give us. And here's a quote from the anti-creationist Arthur Strahler. He says, increasing the duration of the ice age by a factor of about 10 greatly increases the stress upon the creation scientists, who must compress the events of 15 million years into 4,000 years of post-flood time. Well, this guy's got a huge book with challenges for us, and he did a lot of research. So he looked into our stuff, and so he got some things right, like the post-flood time, and other things he's got wrong. So what's this increasing the time by 10? Well, they decided because of other geological phenomena, mainly ice-rafted debris in deep sea cores, dated as Oligocene or Eocene, early Cenozoic, Paleogene for other people. And therefore they decided that, well, these came from Antarctica. Antarctica must be 10 times the age we thought it was. So overnight it becomes 10 times the age, where it started about 40 million years ago. And the Eocene reached a maximum at 15 million years. So that's the challenge it gives us. We need to not only explain the ice age, but also the Antarctic and Greenland ice sheets, and that they say takes 10 times as more time. What do we do with challenges? This is my theme verse for all research. In fact, it's a great theme verse for life. Examine everything carefully, hold fast to that which is good. 1 Thessalonians 5:21 from the NASB. I can't emphasize more of that word carefully. You got to go beyond the superficial. See, you can go on online and see a lot of challenges they give us, like I saw one the other day on the Ice Age. So, and it sounds kind of convincing, but when you look at it carefully and bring back the Bible into Earth history, you know, there's a whole different way of looking at it, a whole different explanation. And so this is my theme verse for research. I examine everything carefully. So I need to kind of back up and kind of, first of all, answer a few questions. Was there really an ice age? See, there are some people, even a few creationists, that don't believe there was an ice age. Well, where are you going to test to find out whether there's an ice age? Well, you go to places that are glaciated currently and look and see what glaciers produce on the land. And then you see if these similar features are found elsewhere. And of course, here's the beautiful Athabasca Glacier in the Canadian Rockies. And it was out here in 1890. Practically all the glaciers in the world have shrunk due to a little global warming. I emphasize a little global warming. But what you see glaciers do, they produce these ridges and mounds of all kinds of rocks. Like here's one right here in front of it, a ridge of debris that was left. That's called a end moraine or terminal moraine. And along the edges, you find where the debris has been piled up along the side as the glacier advanced. They're called lateral moraines. And here is a picture of the lateral moraine to the north. You see it's got some good-sized boulders in it. It's just a pile of rocks, various sizes, all mixed up. By the way, I was young and stupid when I took this photo. I actually went up on this ice, this Columbia ice fields, Athabasca Glacier. Had a lot of crevasses. I was pretty dumb, but I survived. And then you find scratched boulders. The boulders are scratched because they, at the bottom of the glacier, as it moves, the boulders scratch the bedrock and the boulders get scratched. And sometimes the boulders will shift because the ice is plastic, can shift, and it can form scratches on the boulders in different directions. Like here, there's 2 directions, right in here and right in here. So that's typical. And then the bedrock is scratched in the direction that it moves. These are typical of glaciated areas today. Do we see these areas in places that are claimed to be glaciated? Indeed, we do. This is west of where I used to live in Great Falls, Montana. I live now in Bozeman, Montana, about 150 miles south. And here's the Rocky Mountain front in the background. And in the foreground, you see this mound of, and you see boulders at the top. And it continues over here. You can see it's just a mound of debris of actually rocks of all sizes. It was continuous in here at one time, but it probably broke through here because of it dammed up a glacial lake and cut through here. And of course, that's where they put the reservoir. And when you look at the close-up of the terminal moraine, you see rocks of all sizes in a jumbled mixture, just exactly what you expect for glaciated areas. And then you find some scratched rocks in that terminal moraine. And when you hike up to the top of the Rocky Mountain front, this is the first cliff in the Rocky Mountain front. It's 800 feet high, about 250 meters high. And yet you see the scratched bedrock moving from west to east and down into the high plains about 20 miles east to where it ended. So this area was glaciated, but this area in the summertime gets up into the 80s or in centigrade, 20 to 30 degrees centigrade for high temperatures. And so no glacier is going to survive in the Rocky Mountains or in the plains today. Very, very far from producing any glaciers. And then you find that a lot of the mountain areas in the western United States were glaciated, and glaciers came out of the mountain valleys onto plains. Like here's one at Enterprise, Oregon, Northeast Oregon. And you see this horseshoe-shaped feature right in here with a dammed up, over-deepened lake like a fjord. And when you this feature would not form in the flood, as some people have tried to tell me. Anyway, this is a special shape from a glacier coming out onto a valley and piling up a lateral and a terminal moraine, like you see in presently glaciated area. And when you look from the lake level at the lateral moraine, you can see the trees for scale. This lateral moraine is 600 feet tall. When you look at what's in the lateral moraine, you see it's rocks of all sizes and generally a finer grain matrix. Like here's a granite rock right in here, a lot of granite in those mountains. So this area was glaciated. Enterprise, Oregon, Northeast Oregon gets up in the low 90s for high temperatures in the summertime. You couldn't glaciate the Wallowa Mountains today. It's very far from creating an ice cap there. And then you find all these erratic boulders. Here's a famous train of erratic boulders that stretch 600 kilometers from near Jasper, Alberta, Canada to Cutbank, Montana. This is quartzite. Look how angular that is. By the way, this is John Wood Merapi for scale. This is southwest of Calgary, Alberta, Canada. It couldn't have rolled down in the flood. It had to be transported in an iceberg and deposited. And this probably was a glacial river between the Laurentide ice sheet in central and eastern Canada and the adjacent United States and to the west, the Cordilleran ice sheet that covered the Rocky Mountains and moved down off the Rocky Mountain front for maybe about 50 kilometers. And here's a really interesting boulder. This is about 180-ton argillite boulder. So you can see it's a shale. Argillite is a slightly metamorphic shale. It's in the Willamette Valley, southwest of Portland, Oregon. It's about 200 kilometers south of the furthest southern extent of the Cordilleran ice sheet, which is Olympia, Washington. And by the way, this type of rock does not outcrop anywhere in the state of Oregon. And you couldn't have rolled this. By the way, it outcrops in northern Idaho and western Montana, near where I live. And this part of the belt supergroup rock from the Belt Basin, 20 kilometers plus of sediment in a deep hole deposited. Anyway, the glaciers, it's deposited down here. What's it doing down here? And it's angular. Well, the only explanation is the Lake Missoula flood, where the valleys of western Montana ponded to 600 meters by an ice dam in northern Idaho. And then it broke through that ice dam and flooded eastern Washington and carved it up, moving 80 miles an hour through there, and moved through the Willamette Gorge and spread out in the Vancouver, Portland area, with all kinds of erratic boulders spread over the Willamette Basin, which is what you're seeing here. And this unique one had to be carried by an iceberg from as far away as western Montana, which indicates that if you had a Lake Missoula flood and you had an ice sheet that was at least 2,500 feet thick in northern Idaho, you had an ice age. And here's a quick summary of the Lake Missoula flood. Here's the valleys of western Montana. I lived down about in here, and it filled it up 2,000 feet deep right there. And it carved through that ice into Glacial Lake Columbia, and then it carved up eastern Washington. 50 cubic miles of basalt and silt was eroded. The green areas where the channel flowed. And here it is from space. You can see the path of the floodwater, the Lake Missoula flood. It was 10 times the combined flow of all the rivers in the world. Huge. They rejected it for 40 years because it was too biblical in scale, until they realized that there's hundreds of pieces of evidence for this. And so when you add up all these areas where it shows glaciation, this is the general area of where it was glaciated, generally down into the mid-latitudes of the United States and the mountains of the west. This is a schematic. It's not meant to be accurate. And here's an area not glaciated somehow, right in the within about 300 kilometers north of its furthest extent. And here's Alaska. Only the mountains of Alaska were glaciated, but the lowlands were not. Major mystery of science, which I will say something about towards the end. That's where you find the woolly mammoth fossils, the horses and the bisons in the lowlands of Alaska. And then the same thing in Eurasia. There's the general location of the ice. It's rather controversial how much ice was here, by the way. By the way, this is an old schematic from one of my books from the 90s. So that's questionable how much ice was here. And now they believe the Barents Sea north of Norway was glaciated. And some more mountains besides the Alps were glaciated here. It's just a schematic. The central mountains of Asia, the mountains of Siberia. Only the mountains, but not the lowlands. And that's where you find the woolly mammoth fossils by the millions, especially in the New Siberian Islands here and in the adjacent coastal area in the permafrost. So this is the general location of the ice. 30% of the land surface was covered by ice during the Ice Age. So there was an Ice Age. Can mainstream sciences explain the Ice Age? Remember, I said that they are always challenging us, but I find that they're challenged also. But in order to know whether they're challenged or not, we need to know what it takes for an Ice Age. What do we need? Here's the requirements for an Ice Age. Cooler summers. winters are already cold enough most areas. In fact, most areas would benefit for a warmer winter, because the warmer the air, the more moisture it holds, so you can produce more snow. Then secondly, greater snowfall. You need much more snowfall, and it has to not melt during the summer, so it builds up year by year. So it persists for many years. You just can't have a climate change for 1 year. By the way, how much cooling are we talking about? What kind of numbers? Well, a man did a computer study of to see where the 1 inch line or more snow areas occurred after the summer melt in Canada. And he cooled off the average summer temperatures of Canada by increments of 2 degrees centigrade, about 3 degrees Fahrenheit. So when he cooled it off to 12 degrees centigrade, his 1 inch line was in northern Canada, there and northward. That's where his 1 inch line, cooling off 12 degrees centigrade in the summer. That's about 20 degrees Fahrenheit. And that's where his 1 inch line was left after the summer melting, and supposedly would increase with many more years. And that's where your ice sheet would start. But the thing is, the ice went clear south of the Great Lakes into the mid-latitude. So you need a lot more cooling to get it down that far. And by the way, the glaciers didn't develop in northern Canada and move at a glacial pace down to the northern United States. In general, they form more or less in place. There was a soft movement because the slope, they moved by the surface slope mainly, and so the surface slope was always be to the south, so you'd have scratched bedrock down towards the south. So it generally formed more or less in place. So let's try Minneapolis, Minnesota. This would work for many places along the edges in northern United States. The summer temperature is average is 70 degrees Fahrenheit. That's 21 degrees centigrade. That's the high and the low both. So you have to cool off Minneapolis to at least 32 degrees Fahrenheit. But by the way, snow melts mainly by solar radiation, and it can melt at well below freezing. As anybody that lives where I live knows, when you get a spring storm, it dumps a foot of snow, sun comes out, it's 10 degrees Fahrenheit, and it starts melting at 10 degrees Fahrenheit. So when do we get net melting then? What temperature? How far down do we have to go below 32? Well, I went to a paper on Antarctica, and the Antarctica gets net melting along the low altitude edges when it rises to 14 degrees Fahrenheit from the journal Quaternary Research. So I'll be more conservative and say that if the average temperature of Minneapolis is 20 degrees Fahrenheit in the summer, then the ice will start building 1 inch, a foot at a time, then the next year even more. So that's a summer temperature drop of 50 degrees Fahrenheit. Where are secular scientists going to get a temperature drop of 50 degrees Fahrenheit for an ice age? And by the way, you need a climate change just not for one summer. It's got to be many summers. So as you can guess, the ice age is actually a severe problem for uniformitarian scientists, because they only have to explain this by climate change with present processes of climate change. What sort of present processes of climate change would produce this much of a temperature drop? Well, they haven't really got the foggiest idea. They appeal to something in the past called the astronomical theory of the ice age, or the Milankovitch mechanism, caused by slight changes in the Earth's orbit with time. And so you get slight changes in radiation, very slight. And they say, well, that did it. Well, no, that's too weak. And creation scientists, Jake Hebert and myself, have written a lot about the Milankovitch mechanism. That it's way too weak. So they got a serious problem of finding a drop of 50 degrees Fahrenheit. So as you might think, it's a problem. And so a lot of experts on the ice age admit this, like J.K. Charlesworth in the book Quaternary Era on page 1532. Yeah, it was a 1,700-page book on the ice age. I loved it. It was very detailed. He was a very thorough researcher. He says Pleistocene, by the way, the word Pleistocene or Quaternary is their time scale for the ice age. Pleistocene phenomena have produced some good theories, an absolute riot of theories, ranging from the remotely possible to the mutually contradictory and the palpably inadequate. And by the way, there's over 60 theories on how the Ice Age formed. And by the way, that was in 1957. This is modern times, right? And we know so much more. Well, oh, do we? Well, let's get another reference from 1997. U.S. News and World Report dedicated the whole issue to the 18 top mysteries of science. Some of you might have noticed that some of these mysteries are strange and are actually mysteries of their own making because they believe in evolution, like this one right here. Why should males exist? Well, in evolution, you should only have one sex that reproduces asexually. They can't figure out why there's a male and a female, and they write books and articles trying to figure out this great mystery every year. And guess what? This is where the biblical worldview has evidence hands down, because it simply says in Genesis, God made them male and female. But some of these are real mysteries, like what causes ice ages. So that made the top 10. What causes ice ages? They don't really know. And a more recent theory by David Alt about glacial Lake Missoula and its humongous floods. Yeah, they have to believe in more than one glacial Lake Missoula flood, by the way, about 100 of them now during their last ice age. Anyway, he says, 2001, although theories abound, no one really knows what causes ice ages. They don't know. It's a huge problem to them. And in 2008, these two researchers said in the journal Nature, the most widely read journal in the world, perhaps the longest standing puzzle in the earth sciences is what caused the northern hemisphere ice sheets to come and go. Long standing, 200-year puzzle. So it is a problem to them. But can we explain it? Can the biblical worldview explain the ice age? Well, we need to know when it occurred, first of all. Was it before the flood? During the flood? After the flood? Well, it's obvious it's after the flood because these moraines and erratic boulders are all on surface features with thick sediments below them, sedimentary rocks from the flood. So it obviously followed the flood. So we can place it within a transitional climate between the flood and the present climate. This suggests strongly that the flood may have caused the conditions necessary for such a radical climate change, the ice age. And indeed, that is the case. So what about the flood would do it? Well, the flood was a great tectonic event, volcanic event, meteorite impacts, lots of volcanism. So at the end of the flood, you'd have a shroud of volcanic dust and aerosols. An aerosol is a particle about a micron, 1/1,000,000th of a meter in diameter. And they are so small, they float up in the stratosphere for a couple of years. And they reflect the sunlight back to space, cooling mainly the summer over land. Doesn't affect the water and doesn't affect the winters because of other heating features. Also, the fountains of the Great Deep and volcanism would cause a warm ocean at the end of the flood. This is a very key feature, this warm ocean, as well as the volcanic aerosols. And these mechanisms would persist after the flood, but wane with time. Wane because the volcanism decreases with time. Also, the warm oceans cool with time. And we can time the ice age by the cooling of the oceans. A very physical mechanism, cooling the oceans. So Genesis flood can fulfill these requirements by the volcanic dust and aerosols during the flood, and even after the flood, there was huge volcanism. And the fountains of the Great Deep and volcanism causing the warm water. Here's a schematic showing dust and aerosols. Dust settles out in weeks to months, but aerosols will settle out in a matter of years to even up to 10 years. Reflecting some of the sunlight back to space. Anyway, as evidence that there was a huge amount of volcanism during the Ice Age, Charles says signs of Pleistocene, that is Ice Age volcanicity and earth movements, are visible in all parts of the world. You see a lot of Pleistocene sediments, in a lot of ocean sediments from the Pleistocene. So a lot of volcanism occurred during the Ice Age to replenish the particles that fall out with time to keep the Ice Age going. So here's kind of a schematic of warm oceans at high and mid latitudes. Huge evaporation. And by the way, the key for the warm oceans is the warmer the temperature, the greater the evaporation. For instance, you can evaporate 7 times as much water vapor into the atmosphere at an ocean temperature of 30 degrees centigrade than at 0 degrees centigrade. 86 degrees Fahrenheit versus 32 degrees Fahrenheit, 7 times. And by the way, it would be at mid and high latitudes where the oceans would be a lot warmer than today's ocean. So you have a lot more water vapor in the air at high and mid latitudes. And volcanism and dust in the upper atmosphere falling on the cold land. That's kind of a schematic of it. So, do we need 100,000 years for an ice age, or even 40,000, as the secular scientists claim for each of their ice ages? So how rapid was the ice age? This is my evidence that the ice age was very rapid, right here. This is it, Jenkins. Indisputable proof that the ice age caught these people completely off guard. It dumped on before he got out of the outhouse. No, seriously, I had to estimate the starting temperature right after the flood and the ending temperature when it reached glacial maximum. So what I did was the cooling of the ocean drives the ice age, times it. It'll cool by cooling mechanisms, mainly conduction of heat to the colder air and evaporation. Evaporation is approximately 3 times as efficient as conduction. So by evaporation and conduction, you cool the surface layer of the ocean, and it sinks down to the bottom, and you have a huge overturn of the ocean as it cools. Significant effect for the bottom of the ocean, which no creationist has really got into yet. So, based on the cooling, the cooling versus the warming temperature would be the sunshine. So, I use this. It's called a heat budget equation. It's just like you turn on the heater and the air conditioner in a room, and you see which one's stronger. Well, in this case, the air conditioner was stronger, ended up cooling the room. In this case, cooling the ocean. And so it cools with time, so you can time it. So I assumed we went from 30 degrees centigrade average down to 10 degrees centigrade average. By the way, the average now is 4 degrees centigrade. So you reach glacial maximum before you reach the temperature today. So with 20 degrees centigrade cooling, I plugged it into the heat balance equation and used maximum minimums for these variables because there's no way to be accurate. I just wanted to bracket. So I got a maximum of 1765 years and a minimum of 174 years to reach glacial maximum. Best estimate was 500 years. Then you got to melt all this. First of all, you got to figure out what the average height of the ice sheets was. So I used maximum minimums for variables and got a range. And the best estimate for the northern hemisphere is 2,300 feet. For Antarctica, about 4,000 feet. Those are the best estimates. And then you got to melt it. And the best way to melt snow and ice is to use a physical equation that uses physics of snow and ice melt, that uses the heating terms, subtract the cooling terms. Once the ice gets up to 32 degrees, more heating causes net melting, and it starts to melt. That's how it works. So I use maximum minimums for this heat budget equation for snow and ice. The main variable is the albedo, or the reflectivity of the snow. That's a very key variable, and the climate models are horrible at modeling the change of albedo, which changes radically snow ages, for instance. So I use maximum minimums for the albedo, and I got a range along the edge 40 to 100 years to melt. Best estimate 70 years. For the average ice thickness was 40% of the secular scientists, and there's lots of evidence for that thinner ice sheet than what they claim. I have two articles for the Scandinavian ice sheet and the Laurentide ice sheet in the Journal of Creation of the last couple of years. So time to melt, the interior is about 200 years, but the periphery about 70 years. The periphery is along the edge. So the total time for an ice age is only 700 years. This is an example where we use different variables from them. We use biblical variables, the flood, and we get a rapid ice age of 700 years. And they claim there's more than one. They used to say there's 4 ice ages. For 60 years, they used to claim 4 ice ages. In fact, everywhere they looked, they saw 4 ice ages. Now, that's interesting. Why did they only see 4? Well, actually, when you look at the glacial debris on the continents, you see evidence in most areas of only 1. So was there more than 1 ice age? Well, actually, I believe there was 2 ice ages. There was one before the flood around the Garden of Eden. And this is the Earth's first ice age right here. I got to explain this a little bit. In that when God created man and woman, he created us with no sin, and we had perfect communication at the time. But it doesn't work so well now. And since sin entered the world, communication is broken down. In general, to be very general, women have sensitivity issues and men have clueless issues. Anyway, seriously, there was only 1 ice age. And in most areas, you see evidence of just a single ice age, like this quote from the journal Geology. The title of this, a single late Wisconsin Laurentide glaciation, Edmonton area in southwest Alberta. Edmonton's in central Alberta. Great places for glaciers, ice sheets to occur. And so they're saying that there was only a single one. It was in the late Wisconsin and of the Laurentide. Anyway, that's what you see. And notice what they say in that. Glacial reconstructions commonly what? Assume a multiple glaciation hypothesis in all areas that contain a till cover. Till is glacial is jargon for glacial debris left over. So they assume it, and if they see some complications, maybe some till here, or maybe some sand in another till, you see, oh, that's 2 ice ages. That's how they did it. And that's how they came to 4 ice ages until the 1970s. And then the Milankovitch mechanism took over and claimed there's 50 now in the Pleistocene, based on deep sea cores. And how does that work? Well, they take these cores and they measure all these variables down there and they wiggle around an average. So then they say, when it wiggles this way, it's a glacial. When it wiggles this way, it's interglacial. I think these are climate changes during the ice age, but they would say each one is a separate ice age. So we would interpret them a lot different than they would. So another question, they claim the glacial interglacial cycle is still here. Therefore, the next ice age is about due. And will there be a future ice age? Well, a lot of people think so. In fact, some people even think global warming will trigger it, which is kind of crazy. But anyway, here's the challenge they give us about the next ice age. They say we are still in the glacial interglacial cycle. Interglacials last about 10,000 years. The last ice age melted 10,000 years ago. Uh-oh. We're about due. And in fact, in the 1970s, for those people that like global warming, we actually had global cooling from 1945 to 1975. Global cooling for 30 years. During when carbon dioxide was going up tremendously. That's why there's more to all this global warming than what the hype is saying. Anyway, we had global cooling and sea ice increased. And so a lot of books were written about the next ice age coming. Can we survive it? Articles were published in Newsweek and so forth. And so they said that ice age was coming. Anyway, in the New York Times, this was published. In the past, if the past is any indication, the Earth is at the end of another such warm period, poised to descend into a new ice age. That's from the New York Times. And we believe everything we read in the newspaper, do we not? I don't hardly believe anything from the newspapers anymore. Anyway, the rainbow is a sign that there'll never be another flood. And the flood caused the ice age. Therefore, there'll never be another ice age. So those out there in the audience that were sweating it can relax. And by the way, this gets back to my title of that the Bible explains it. Only the Bible can explain it because of the flood. Now, at this point, I go through the bonus features if I have time, which I do in this case. And besides the ice age, you had a lot of other things going on after the flood. Many, many different things going on. Just think of that, all that moisture being added by the warm oceans. That would cause a lot more precipitation in areas not glaciated. The climate would be a lot different. The general circulation would be different. Things would be quite different during the ice age. So I've gone into other areas. There's a lot of areas left to go. And these are features explained by this post-flood rapid ice age that the secular scientists cannot. And I'll go through these quickly, one by one. In my publications and resources, I go through these in a lot more detail. Anyway, the first one, deserts that were once wet. In Southwest United States, we had all these lakes. Even in Death Valley down here, which I don't show, had a lake 600 feet deep. Here's a lake right here around the Great Salt Lake. It was about 10 times the size of Great Salt Lake, 800 feet deep, while Great Salt Lake right now is only 12 feet deep. So all these lakes in the Southwest United States that is semi-arid today in these enclosed basins, how did they get there? Well, I would say the flood probably filled them up to start with. As the flood drained, it kept water was left in pockets, and they actually increased. We know that they actually grew during the ice age. I will probably say a little bit more about that soon. But anyway, you find shorelines from these lakes all over the place. Like here's Lake Bonneville shoreline. There's several shorelines. The highest one here's the Lake Bonneville level, and the Provo level is a lower one. Anyway, you see shorelines all around where these lakes were. Here's one in east of the Sierra Mountains in California, where you had a mono lake that was about 800 feet deeper, called Lake Russell, and here's a shoreline on it. This shoreline happens to be right on a terminal moraine coming out of a valley from the eastern Sierras. So the what's called pluvial lakes were associated with glaciation because it's right, the shoreline's cut right on an end moraine. And here is southeast Oregon. You find some low-level shoreline features in the desert areas of eastern Oregon. And the Sahara was wet. In fact, people lived in the Saharas. There's a huge amount of evidence of people and animals. Like this drawing, you find tens of thousands of these petroglyphs on rocks in the Sierras. Sierra was green. In fact, James Weller in The Great Sierra says this: the Sierra is a veritable art gallery of the prehistoric paintings. The evidence is enough to show that the Sierra was one of the well-populated areas of the prehistoric world. Yet there is man's work in the most inaccessible corners of the desert. Literally thousands of figures of tropical and aquatic animals, enormous herds of cattle, hunters armed with bows and boomerangs, and even domestic scenes of women and children in the circular huts in which they lived. It was green at one time, during the Ice Age, and even after for a while. So deserts were once wet. This can be explained by the greater amount of water vapor given off by the warm ocean. The woolly mammoths in Siberia. There's a woolly mammoth. It's a small mammoth. The Columbian mammoth was about 3-4 feet taller, the largest mammoth in the world at that time. Spiraling horns, had 3 layers of hair. The outside was about 1 meter long, a hump on its head, a hump on its back, and a sloping on the front of its back, shoulders, and a slumping back. Anyway, those mammoths are found all through the northern hemisphere. You can see in this red area here, but not in the central areas, the northern areas where the ice occurred, which indicates they're associated with the Ice Age. Some of them are in the southern part of where the ice occurred, and they either were there before the ice got in there or afterwards. So they all went extinct. And them and many other animals. And they don't know why the mammoths disappeared. This book by Larry Agenbrod and Lisa Nelson says, why did mammoths disappear from the earth? This question remains one of the great unsolved mysteries of the past. Anyway, it can be solved by the post-flood rapid ice age, where probably about midway in the ice or early in the ice age, they got up into Siberia, crossed into Alaska, down the ice-free corridor in the United States, and some made into Central America. So this can all be explained by the rapid post-flood ice age. And why they would live in Siberia? Well, you can find out that if you took off the sea ice in the Arctic Ocean and left the temperature of the water at the freezing point of seawater, which is 28 degrees Fahrenheit, what kind of winter temperatures would you have in the Arctic and in Siberia? Well, this is in centigrade. The North Pole would be 40 degrees centigrade in the warmer in the winter, 20 degrees in northern Siberia. So a lot warmer in Siberia, just getting rid of the sea ice and keeping the temperature of the ocean water at 28 degrees Fahrenheit. But it was probably 70 degrees Fahrenheit at the start of the ice age, indicating you'd have a lot warmer temperatures in the winter over Asia. So the animals, some of them that can't tolerate much cold, can round the Bering Land Bridge into the United States that way. And of course, there's all kinds of onshore flow of warm air into Alaska and Siberia. Also, there's a strange mix of cold and warm weather animals and plants in glacial debris. This is called disharmonious associations. And we can explain the cold ones during the Ice Age, but what are these warm weather animals doing there and plants? By the way, this is not an anomaly. It's the rule of a mixture of cold and warm type animals. In fact, this book, Quaternary Extinctions, Graham and Lundelius, say late Pleistocene communities were characterized by the coexistence of species that today are allopatric, that is not climatically associated, and presumably ecologically incompatible. Disharmonious associations have been documented for late Pleistocene, that is Ice Age floras, that's your plants, terrestrial invertebrates, lower invertebrates, birds, and mammals. It's the rule, not the exception. How do they explain it? Well, they don't, because their ice ages are bitterly cold winter and summer. But in the post-flood model, we have warm winters. We have mild winters in many locations. In fact, one of the most outrageous examples of disharmonious associations is in Northwest Europe, where we have hippo fossils associated with cold climate animals like mammoths and reindeer. Anyway, early in the Ice Age, the warm onshore flow in the Atlantic Ocean would keep those areas warm. You'd have a very warm winter. You'd have warm summers for quite a while early in the Ice Age. So the hippos, and wet, by the way, warm and wet. So it'd be a great environment for hippos after the flood to migrate up into there. But as it cooled, glaciers started to form in the mountains. They were out of place. They couldn't escape. And so they ended up being buried with cold climate animals. And there's over 100 locations of hippos in England itself. For instance, Don Grayson said in that same book, in the Valley of the Thames, southern England, for instance, woolly mammoth, woolly rhinoceros, muskox, reindeer, hippopotamus, and cave lion had all been found by 1855 in stratigraphic context that it seemed to indicate contemporaneity. In other words, they lived together. They try to separate them into interglacials and glacials, but Why would we're in an interglacial now? Why would a hippo want to migrate up to England in this interglacial? Doesn't make sense. Anyway, there was mass extinctions at the end of the Ice Age. Why is that? Well, here they are. 100 species of large animals disappeared in North America. That's 70%. And these are animals over 100 pounds. Europe and Asia lost 40%, Australia 90%, South America 80%, Africa only 20%. That's the latest statistics. They've changed a bit because of more further knowledge. They don't have a good statistics from Southern Asia, but Northern Asia they do. So why is that? Well, they really don't know. In fact, it only happened after their last ice age, which is kind of interesting. Why didn't it happen after the other 49 ice ages? Well, maybe those other ice ages did not exist. So it's a radical climate change at the end of the ice age. Instead of warm winters and cool summers, which support your disharmonious associations, winters became even colder than today. Summers gradually warmed. The ice sheets melted, sent fresh water over the high latitude oceans, forming sea ice right away. So temperatures got a lot colder and drier and so forth. So this has been a mystery for 200 years. A book published in 1999 said, after many decades of debate, the North American end Pleistocene megafaunal mass extinction remains a lightning rod of controversy. The extraordinary divergent opinions expressed in this volume show that no resolution is in sight. Some think it was climate change that did it. Some think that man did it in a huge slaughter. Some think that man spread diseases. So lots of controversy. Some believe in more than one. Anyway, they haven't been able to solve it. So they got a lot of problems that the post-flood one can explain. Anyway, here's the one about the unglaciated areas in Siberia, lowlands. That's where you find the woolly mammoths and the other animals. In Siberia and Alaska, there were at least 40 different types of mammals besides the woolly mammoth. And they're found in permafrost, that is permanently frozen soil at the surface. And there's millions of them based on the statistics I've seen from the Russian scientists, especially the New Siberian Islands right up in here and the coastal areas adjacent to that. And if the sea level dropped 100 meters, huge areas of the continental shelf would be exposed. So it'd be no problem for them to go from Siberia into Alaska. And early in the Ice Age, there would be a ice-free corridor caused by what's called downslope foehn winds off the Rocky Mountains from northern Canada down into Montana, where I live. And so that's where the animals pass through that ice-free corridor. And when they try to model glaciation, it's very hard to produce glaciation in these climate models because they're so imperfect. Anyway, one model actually produced glaciation in 1994. It was published in the Journal of Climate. Anyway, they're celebrating. We got glaciation now. Siberia and Alaska and the Yukon, including the lowlands, were among the first to glaciate. The first places to glaciate. They're great places for glaciers, but they weren't glaciated during the Ice Age. Anyway, they say we now have glaciation, but mainly outside the area where it existed during the last Ice Age. Oh, no. Yeah, the climate models have lots of problems, which is why I'm pretty skeptical again about catastrophic global warming. A little bit of global warming, I think, is true, but not catastrophic. In summary, the Ice Age was a real event not that long ago. It was real. We have to explain it. It is a major mystery for evolutionary Earth science. Noah's flood caused the transitional climate for an Ice Age. Yeah, Ice Age lasted only 700 years. We don't need 100,000 years for an Ice Age. There was only one Ice Age. Only the Bible explains the Ice Age because of the flood. That's going back to my subtitle. And there will be no future Ice Age. A few concluding remarks. Creationists have a viable mechanism for the last major event in Earth history, while evolutionary scientists are far from a solution. then why should we believe them for all those older hypotheses? Hundreds of older hypotheses about the evolution of this beastie and its death and extinction. They have all kinds of just so stories, as I call them. Why should we believe them for any of them if they can't explain the Ice Age? Another concluding thought: the Ice Age is an example of what can be done with hundreds of other earth science challenges to the Bible. And this is crucial: time is not a side issue. Some people are embarrassed by a short time scale, but a young Earth time scale sometimes is a key to solving major mysteries that have been lasted for 150 years. Well, how so? Well, they know that the volcanoes cool, and so, but you know, the aerosols settle out within 2 to 3 years. That it came up, if they were pushed up in the upper stratosphere, about 10 years. So each volcano going off, it's stretched out to tens of thousands of years, becomes insignificant in the long, big picture. And so they discount volcanism as a major cooling event because of that. But what if we telescoped all those volcanoes that are post-flood, and even the ones that occurred during the flood? By the way, there's 700 stratovolcanoes, and they're probably all active during the Ice Age. If we telescope all that volcanism to within several hundred years after the flood, we have a major cooling mechanism for the summer. So time's not a side issue, but it's key. Another more concluding thought: the Ice Age is based on the flood. Therefore, the flood, one of the most despised events by the culture, is a real event of the past. Therefore, it is easy to believe the whole Bible, which tells us how to live here on earth and how to go to heaven. That's ended, but I'm going to tell you about some of my resources. I've been working on this for over 45 years, writing articles and books. So as a result, I got a lot of resources out there for all ages, all technical abilities. In fact, I'm publishing another one on the Ice Age, an in-depth one. Is being reviewed by Creation Ministries International. Anyway, my main book for laymen is Frozen in Time, the Woolly Mammoth, the Ice Age. And it's actually been changed, the biblical key to their secrets, instead of just in the Bible. And as far as ice cores, see, there's a lot of subjects. Ice cores are a big challenge, but when you delve into it and look deeply at it, they're not really a challenge at all. Anyway, there's a book you can get, and it went out of print for a while, but now you can get it print on demand from Institute of Creation Research, The Frozen Record, dealing with the ice cores. Yeah. And if you like DVDs, Kyle Justice filmed me showing these features in the Northwest states about the Great Ice Age. And also he did it for the Lake Missoula flood, the Great Missoula flood. And I even have a book on the Lake Missoula flood, comparing what happened, what did the Lake Missoula flood produce? And comparing the landforms that it produced with those that you see on the surface of the earth today from the runoff of the floodwaters. And we see the similar landforms, but at a huge scale for the Genesis flood. And so you can get that. Oh, keep doing the same mistake. Gotta go. And we have some children's book that my wife and I did, teaching about the Ice Age in story form. It's a fun read for young people and adults alike. And we have a sequel, Uncovering the Mysterious Woolly Mammoth. And for those that need something, a primer on geology, I wrote Exploring Geology with Mr. Hibb. The Ice Age has got a lot of geological stuff, so I've gotten into geology and geophysics over the years. And so this is one of the resources I have for children grade 6 and up, and even adults. There's one on dinosaurs too, I might add. And I wrote the weather book, which has been updated for newer material. It's a homeschool course also. And if you really want to know about global warming, I have a talk you get from CMI, the Great Global Warming Debate. I go through the data and tell you what the data really says. Anyway, I want to leave you with this verse. Your faith, from 1 Corinthians 2:5, your faith should not rest in the wisdom of men. That the wisdom of men is doctrines from the Enlightenment. deep time, the flood is not real, evolution that came later, by the way, because of uniformitarianism. It should depend on the power of God. God has the power to cause a flood, to create and do an ice age, no sweat. That's where our faith should be, not on the wisdom of men. And here's a few websites that would aid you. Creation.com is my favorite. Has over 11,000 articles for various age groups and various depth to them. I have a website, michael.oards.net, and on that I have 2 free ebooks you can get. Just read them. One is on the evidence of the runoff of the floodwaters in the field of geomorphology, the evidence that we had runoff that produced all these features on the surface of the earth that they can't explain. And then I have another book on where is the flood post-flood boundary, because I've worked inordinate amount of time to figure this out, because I have to separate what occurred during the flood and what occurred during the ice age, so that I have an ice age explanation for what occurred during the ice age and a flood for the flood. And so you can get this ebook, and I've published that book in a lot more detail on the Journal of Creation. So I'm going to open it up for questions now, and pass it back to you, Donnie or George. Still there?
Yes, yes, I was on mute, Mike. I didn't want to give you any background noise during that awesome presentation. I've got to say, that hour flew by. I can't believe it's over already. I'll be re-listening to this probably tonight. So much good information, Mike. Actually, if you wanted to just click that stop sharing button real quick, okay, and I think our main screen should pop up. There we go. There we go. We're good. I want to point out, Mike, a couple of thoughts that came to mind was I love how you point out that the global flood of Noah itself is the perfect event that fulfills the requirements for such drastic climate change, right? Necessary for the ice age.
Yes.
As biblical creationists, we have an explanation for the ice age, while the uniformitarians struggle to explain the necessary conditions for their multiple ice ages. And
cutting out.
Oh, am I cutting out there, Mike?
Yeah.
Yeah, you're cutting out. So I didn't catch that.
Okay. It looks like your camera's back. Yeah, it looks like it was cutting out a bit. George, could you hear what I was saying, brother? Was I cutting out at all?
I could hear you, but Mike's camera was freezing up a little bit, so I think that's why he couldn't hear you.
Yes. Oh. Yeah. It looks good though. It looks like whatever you did, Mike, seems to be fixed. But overall, I just want to point out great presentation, and I want to thank you so much, Mike, for all your amazing work. And last thing I'll say before we get into some questions, I'll hand it over to George. We've got a great lively chat. I want to thank everybody in the chat for their amazing support. We've got a ton of questions, super stickers, super chats coming in to help with the show, help with the ministry. But I like the way you ended it there. You pointed out that a young earth that the scoffers deny is key oftentimes in solving the major mysteries that have been around for over 150 years. So that was a great point, and that really resonated with me. So thank you, Mike. George, I'll yield the mic and hand it over to you for a few words, brother.
Yeah, I'd just like to add a couple of things to what Mike actually said in support of the Ice Age. For those that don't know, there's been some considerable amount of work being done on fossils in Greenland, where they found fossilized leaves, and they could identify the species of these, or they could identify these leaves to a species of tree. And they found that these trees would only actually survive or grow in moderate Mediterranean type climates. So Greenland, for example, was once moderate in terms of climate, and also from written historical records from the Vikings. For those that don't know, the Vikings actually moved to Greenland, and they actually cultivated crops like corn. So Greenland was once lush and green. And as Mike mentioned, these mammoths would have moved to where all the green vegetation was, and they moved further north. And that's how they got caught in that ice age and buried by it. So, Mike, I hope I haven't said anything contradictory to what you said, but that's what I know about Greenland and some of that area adjacent to it.
Okay. You got to determine what is flood and what is post-flood there. Yeah, Greenland has warm climate vegetation at, in the Cenozoic, as they would call it. But this goes along with warm climate vegetation in northern Canada, Siberia, and Antarctica. You find a lot of paleoflora, as they call it, showing warm climates at high latitude. So this just drives them crazy. In fact, the last one, the Pliocene, which was just before the Pleistocene, that had very warm climates. So it's very difficult for them to explain that. But I believe that's from the flood. That the vegetation, as well as some of the animals, like lemurs in the Axel Heiberg Island and Ellesmere Island and the Queen Charlotte Islands of Canada, 80 degrees north. All these, they were transported up there by the flood, is what I've concluded. Now, there is a report that underneath the Camp Century ice core, they recently realized that there is some vegetation at the bottom. They found the bottom core after being missing for 50 years, and they analyzed and they found leaves and twigs, and saying, it melted about 200,000 years ago. I mean, they think it's been there for millions of years, by the way. So I'm going to write a little article on that for the Journal of Creation starting tomorrow. So that's post-flood there, and yeah, a lot of interesting things on the paleoflora. And I've published several articles on the paleoflora before.
Now, Mike, there are skeptics, and they point to ice core data where they identify deuterium and oxygen-18 isotopes.
Yeah,
and they actually cite peaks in the ice cores to identify 8 unique periods, suggesting there could have been up to 8 ice ages or glacial events, which sort of goes against that one ice age that you mentioned. So how do you actually explain those ice cores and the isotopes found in them?
Oh, yeah, okay. In fact, I've got a 5-part series being published in the Journal of Creation as we speak. 2 parts have been published, and the next issue, which will come out in about 3 months, maybe part 3 and 4 will be there. I've reviewed. They reviewed all the first 4 parts that are sent to me. I've sent them back. So I'm trying to I go through all that stuff. Well, first of all, you look at Greenland and also West Antarctica, you see evidence of only one ice age there. You get only to the bottom, you find what they believe is interglacial, but that'd be the warm period caused by the warm water before it glaciated on Greenland, for instance, like the lowlands of Greenland where those deep ice cores are drilled. But it only shows one ice age. It's only East Antarctica that shows many. And Vostok shows 4. It's Dome C that they key on that shows 8. And it's by the wiggles in the oxygen isotope ratio. First of all, they date these ice cores by matching them to the same wiggles they see in deep sea cores, which were dated by assuming the 100,000 year eccentricity cycle and the Milankovitch mechanism. So it's all big circular reasoning network on how you date Antarctic cores, because you can't date by the annual layers like you can in Greenland. Has nice annual layers just at the top. They thin out and they get diffused and messed up midway down there. But Antarctica has too little snow each year, and it blows around, so you can't have annual layers. So you got to go by assumptions. So they date it by deep sea cores, which are dated by Milankovitch. So there's a huge circular reasoning network, not only with ice cores, deep sea cores, but pollen cores, lots of other things that kind of fit it all into this Milankovitch mechanism, they claim, that cycles because of the changes in the Earth's orbit. Jake Hebert and I have written a lot of papers on this subject, if people want to look at the in-depth literature on it. But we would explain, like the Dome Sea. Let's take the Dome Sea. It has 8 wiggles. First of all, those first 4 wiggles, low down, are not very impressive. They're not very big wiggles. It's only when the top 4 wiggles where you really get some good oscillations in there. Well, in this series of papers I'm doing, and it's the same thing in Greenland, but different. There's a different situation. But in Antarctica, I believe that these oscillations with rapid accumulation of ice are decadal oscillations in volcanism that occurred after the flood that are unique to each hemisphere. Each hemisphere is separate because you don't have much exchange in the atmosphere or the oceans between the hemispheres. And so the volcanism in the southern hemisphere determines, causes the lower, more glaciation, faster accumulation, and other variables that are correlated with it that causes the glacial wiggles. And when you have a lull in volcanism, it goes to it goes up. So I've correlated all these things, and due to decadal. Now, decadal oscillations are oscillations that are a couple decades, maybe anywhere from 10 years to 50 years. That's a time scale. And this would occur during the post-flood rapid ice age. During ice buildup, you'd had these causing these oscillations. And I published the basis behind this in 1990 in my in-depth book, which is out of print. That is due to oscillations in volcanism in each hemisphere.
Well, that's an incredibly informative answer, Mike. That was awesome. I appreciate that. We do have a super chat that came in. A super chat is just where our supporters will donate to the ministry with a question attached to it, Mike. So this question comes from Nephilim Free. I appreciate the support and the question. He says, question for Oard. Is there much movement towards accepting that ice layers do not represent individual years in the scientific community?
Oh, no, there's no movement in the scientific community. They've assumed they've been there for millions of years, and each annual layer, like on the top of Greenland, and it's like this on West Antarctica too, that's about that thick of ice, about 20 to 25 centimeters. And as each buildup each year, it pushes it down and squeezes it to the side, so each annual layer thins and thins. And if you assume it's been there a million years, each layer becomes so thin, it's as thin as a dime by the time you reach the bottom. That's your annual layer. In our time scale, you can have 6 meters of ice for the first several years. And so it would compress some to say 3 meters, but all the wiggles from storms are not diffused out when you have a higher precipitation rate. So they would be counting storm layers and layers within storms, these oscillations, as a year. Well, we would consider them storms or within storm oscillations in various things like oxygen isotope ratio, because the storm layers annual oxygen isotope has an amplitude about the same as the annual layer in Greenland. So that's the difference. And they're totally into uniformitarianism, millions of years, and they have this model. They date it by flow modeling is one of their dating methods. So it becomes paper thin, and so they count all kinds of wiggles. We know that there's a lot of circular reasoning going on, because when they first counted in Greenland, they got 85,000 wiggles. But when they got about near the bottom of the GISP 2 ice core, drilled in early 1990s, and they counted 85,000, but they said it was wrong because, according to the Milankovitch theory, it should be 110 layers by that level. So guess what they did? They went back and redated the bottom 500 meters using a sophisticated laser light mechanism that has a resolution, instead of 8 millimeters, it's 1 millimeter. And guess what? It got a lot more wiggles down there in that bottom 500 meters, and it magically became 110,000 layers down, or years at the bottom.
Wow.
Circular reasoning based on the Milankovitch or astronomical theory of the Ice Age.
I know this is a bit of rough maths here, Mike, but I was doing a bit of research last night, and I got these numbers from the Australian government Antarctic program. They state that the mean thickness of the Antarctic ice sheet is 2.16 kilometers, with the maximum known thickness of the ice sheet is 4.8 kilometers in the Terrier Dell. Now, I being an engineer, I like a little bit of maths, so I sort of compared that with the average snowfall or thickness of ice above. Sorry.
Oh, I think Mike is cutting out a little bit there. Mike, it looks like your camera might be frozen. It looks like we got you back, Mike. So I'm not sure. It looks like it.
Anyway, I see a lot of questions. Chat.
Mike, it looks like you're. It looks like
freezing.
Your camera might be freezing. Maybe.
Oh.
Mike, maybe shut off your camera for now, and we'll see if we can save some bandwidth. But it looks like we got you back, Mike.
Camera, I guess that's.
It looks like we do have you back, though, Mike.
Okay. I have a lot of questions that are piling up here. I see them.
Yes. I want to get to these questions. Maybe we'll do a rapid fire Q&A. Mike, are you hearing us again? Is your connection back?
Yes.
Okay. My recommendation. Okay, perfect. My recommendation would be next time, if it does happen again, oftentimes if you click the stop cam button right next to the mute button,
okay,
that'll save bandwidth and you won't have that issue again. So
okay.
So George, we're gonna fire through these questions.
Okay. Yeah, I'm gonna do that right now.
There we go.
Yep.
There we go.
Good.
So that should solve the issue.
Okay.
So our next question would be, well, let me see here. A question just came in. At least I could put this one on screen. Question from Baldy Cat. I appreciate the question. What is Michael's view on climate change records specifically?
I'm getting
Are we losing you again, Mike?
Yeah, I can't hear him.
He might want to, I don't know if it's an internet issue or what. He might want to jump out of the stream and then jump back in, just kind of refresh it. Because the last time he was on, we had him on for almost 3 hours with no issues. So maybe if you wanted to just refresh it. Mike, can you hear us at all?
Yeah, I'm hearing you now.
Okay. Okay. Sometimes an easy fix is to leave the stream and then click the link and come back in just to refresh it. But if you can hear us now, we can kind of move on and hope that things are fixed from here.
Okay.
Okay, we'll try this for now.
Send the question.
Okay, so the question comes in from Baldy Cats. He asks, what is Michael's view on climate change records?
Well, they've been taking measurements of temperature. Now, there's a lot of glitches in those temperature records. So they claim about 1.6 degrees Fahrenheit or 1 degree centigrade warming since about 1880. But, and especially in the polar areas where it's amplified because the snow and ice is melted. So I believe all those records, but I think the temperature record may be exaggerated, but I'll take it for data to start with. And we know the CO2 has been going up, but we can run correlations.
Mike, it looks like you're kind of breaking in and out. I think we're losing you. Did you want to maybe exit the stream?
Rising.
Yeah, Mike, we can't hear you. It might be a good idea to leave the stream and then come back by clicking that link.
Oh wow!
That Standing sent you in the email.
It sounds like it's a connection issue, possibly on your end, Mike. So sometimes if you were to, we've had this happen before with guests on, and typically when they leave the show and then kind of refresh and come back in, usually that fixes it. And then George.
Yep.
I'm going to go over a couple reminders and announcements for the. Okay. I'm going to go over a couple announcements, George. If you wanted to mute yourself and give Mike a quick call, because he did give us his number to give him a call if there's any glitches. And at the same time as you're doing that, I can go over some reminders with the audience. Might be a good time. So I wanted to remind everybody that tomorrow we have our third event for the Genesis Flood Week on Standing for Truth. We have Sal Jardina back with us. We're going to be discussing how geology demonstrates and confirms the flood. We're also going to be having a Q&A that kicks off at 8 p.m. EST. So make sure you're here, bring your questions. Should be a lot of fun. It's going to be Sal's second time with us. And let me see. I think I got... Mike, it looks like your camera is... Can you hear me, Mike? We've got you in the stream, Mike, but I'm not too sure if you can hear me or if your connection's improved at all. Okay. We'll wait for George to... call.
I don't have his email with his phone number standing.
Okay, here, let me get it for you real quick, because it's definitely a connection issue. Let me see. I'm going to put it in the private chat, George.
Okay.
Just 1 second.
Hello?
Oh, there we go.
Mike, we got you. Can you hear us, Mike?
I got some great questions here.
Yeah. Is the connection improved, Mike? Can you hear us?
So, what are we going to do?
We can definitely start asking you some of these questions, Mike. I just want to make sure that your connection is okay and you can hear us at this point. Are we coming through, Mike? Can you hear us? Okay, I'm going to give Mike a call real quick, just so.
United States and for connection. The internet's up.
We do see a couple comments in the chat. Somebody saying that they had this earlier on their podcast. The internet gremlins are out today, he's saying.
Can I suggest something, Standing? Michael, is there someone else in the household that may be using the internet at the same time?
Okay, here, I'm going to go on a intermission here, and I'm going to give him a quick call. So I'm going to put so we'll be back in just a few minutes, guys, just so we can fix this. We'll try one more time with Mike.
He's coming back.
Any improvement at all, Mike? Okay, we'll be back, guys. I'm going to, on a brief intermission, I'm going to give him a call.
Yeah, there.
Mike, can I ask, is there anyone else in the household that may be using the internet at the same time as yourself?
No, because I have the laptop up in my office and I have the other computer here. So okay. No, I got both computers. And I can hear you. I heard that.
Maybe there's an improvement. We might be good now, Mike. So is our audio coming in okay now?
Yes.
Okay. Okay. Maybe we're in luck. Maybe it was just a couple minutes there of connection issues. But if you can hear us, we can jump right to the next question if you want.
Okay, let's go for it.
All right.
SFT, Standing, would it help if you turn off your camera as well?
I can try. I don't think it's coming from my end, but we'll see if there's an improvement. And there's so many questions there. So George, since I just asked the one on climate change, you pick one of those questions and we'll run with it. Maybe we'll go with Ryan, the Raptor guy's question, George, since he asked it a while ago. Go ahead, brother.
Okay, Mike. Ryan, the Raptor guy, has asked a question. Does Dr. Oard think the unfossilized rhinos, horses, and other animals at the Ashfall fossil beds are from the flood or post-flood? I'm not familiar with the Ashfall fossil beds. Is he talking about the Ashley fossil beds?
No, Ashfall fossil beds in northeast Nebraska. I'm familiar with them.
All right.
That was a tough one. I had a debate with Carl Frody about it. He thought they were post-flood. I examined it twice, the site and other features. And even though there are features there that would indicate post-flood, I think it's flood. And I gave several reasons. I have 33 criterion to determine the boundary, and I use those criterion. One of them was a formation of gravel, quartzite gravel from the Rocky Mountains that was spread clear out into Nebraska that was associated with them. And that's a flood signature, a spreading of resistant gravels. By gravel, I mean up to cobble size out there. And that's to me is a big signature that it was from the flood. And let's see, what else? There were several other things. And some of the animals that were fossilized were not ones you see during the Ice Age at all. There were some really strange ones. And But like I said, there are other indications that it's from the flood. So that's a tough area. Most areas where I've evaluated the flood post-flood boundary, I've found it fairly easy. But that's one of several that I found it difficult. And I had to look at all the data I can before I made up my mind. And I think it's from the flood. And I've written about it. It's in the Creation Research Society Quarterly, what I wrote about it, and what Carl Frody wrote about it.
Mike, one of the evidences that I point to with the Ice Age is the frozen stomach contents of the animals that were fossilized. In the secular sort of scenario where you'd get an Ice Age occurring slowly and gradually over time, that piece of evidence just contradicts that slow, gradual Ice Age. And would you like to talk about that the frozen contents in the stomach of the mammoths as evidence for a global flood and a quick Ice Age?
Well, it would be evidence that they were frozen pretty fast. So the main question has always been how fast. Bird's Eye Frozen Food Company said, well, it has to drop instantly to 150 degrees centigrade or Fahrenheit, I forgot which, below zero. Flash frozen, in other words. And I looked at the data and found that as far as stomach contents, you find some stomach contents with mastodons in the Northeast United States, and no one believes that they were flash frozen. Also, the state of vegetation in the stomach indicated different seasons of death for those mammoths. And a flash freeze would have happened all at once in one instant, according to people who've written about it. And so different seasons indicated that they died at different times. Also, I examined the digestive system for elephants. Elephants and mammoths are very similar. And the digestion system, the food does not digest in the stomach. There's acid there that partially breaks down the vegetation. The digestion occurs after the stomach for mammoths and elephants. So the stomach is just mainly a holding pouch for their food, and it's partially decayed, but you have to freeze it fairly fast. So I postulate a moderate freeze from cold fronts from when it was much colder in winter in Siberia than now. And they're interred in the permafrost because they're in windblown silt, and the permafrost comes up into the windblown silt, as well as the cold air freezing it from the top. So it was a moderate freeze at the end of the Ice Age. And that's when they all went extinct at the end of the Ice Age. I hope I answered that question.
Yes, you did. That was a great question and great answer, Mike. Here's a question that has come in quite a bit, a question that I have on my mind as well. And since you're here, and I know you've written on this in your book that I've got in front of me, Rock Solid Answers, the question essentially is, do varves, the existence of varves, contradict young Earth creation and the global flood, Mike?
Oh, yeah. Well, a lot of secular scientists think so. But when you look at that extensively, which I've done, I wrote a two-part article on it in the 1980s in the Creation Research Society Quarterlies. I especially examined the Swedish varves. First of all, you got to realize that these varves are really rhythmites, alternating two or more subcouplets. They're rhythmites that form in 1 year, they believe. But you can form rhythmites like turbidity currents, distal or the finer turbidity currents will have multiple rhythmites. In the Muir Inlet, that was glaciated in about 1700. The glacier's been receding, and you've had heavy sedimentation, and you've had rhythmites form as much as one per day from the mud and stuff that's given off by the glacier that's receding. So you can form more than 1 year. So they're not necessarily varves. They have to prove that they're a 1 year cycle, and they can't do that. And these varve scales are just short sequences of rhythmites, maybe about, we'll say 200 in one area. And then you go and they try to match the wiggles in the varves, the dark and the white layers and the thick varve layer sequence with the bottom of another. And so that's how they did this all the way up through in Sweden north, and got about 10,000 years. They did it in Northeast Canada and Southeast Canada, the Northeast United States also. And it's all superficial and based on assumptions that there really are varves, and that you can really connect them like that. Dozens of sequences connect the bottom and the top of one or the other. So yeah, you have mechanisms to form rhythmites fast, and a lot of different types of scenarios. So the varves really do not show what they think they are. They're based on too many uniformitarian assumptions.
Yeah, well, Mike. Yeah, Mike. On that one, I believe there were cores done at Lake Sagutsu in Japan, and in two of the cores, they found ash layers, and the number of layers between the ash layers were different. So if they represent years, then why did we get more, I guess, varves in one core than the other?
Oh, yeah. You have those situations. Also, the Green River Formation has 6 million of these rhythmites in some places. And yeah, they don't correlate between ash layers there either. So there's a lot more going on. And you can form these rhythmites rapidly by especially turbidity currents, what they call distal turbidity currents. That's after they're then transported a long distance, they thin out, and they form layers. They form layers, and so you find a lot of these in the rock record, these rhythmites, and so they are always trying to make a case that they're varves and are 1 year oscillations, and it's speculative on their part, and so a lot of this, like the Lake Sagistu, if I pronounced it right, in Japan, a lot of this stuff is just dated by assuming the Milankovitch mechanism, and that stretches out the last ice age 100,000 years and so forth and so on for each other ice age. And so they blend things into these time scales, and a lot of this is circular reasoning with dating methods that are questionable and based on assumptions and uniformitarian assumption. So there's a lot more that I can say and write about it. There's a lot more research projects involved in all this for the post-flood time scale. Anyway, that's about all I can say about varves.
Yeah, that's a really helpful response, Mike. That was really good, and I appreciate that, especially on such a common objection from the uniformitarians, an objection that they almost say is unanswerable by us, but you know, as you've shown here, you've given a great answer. I appreciate that. This question I have here, Mike, kind of brings us back to the post-flood ice age in terms of biogeography, because the question is, Mike, do floating log mats, do you believe they help explain at least some of the Earth's biogeography post-flood?
Oh, yeah. Land bridges. There was a land bridge between France and England that broke during the Ice Age, and that's how the hippos got over to England. There was a land bridge between Siberia and Alaska, and I think this land bridge was exposed early in the Ice Age because some of the mammals that I analyzed that rounded it and where they're found told me. In fact, I wrote a paper on that in the Journal of Creation, I think about a year ago, on the land bridge, but others have to be explained by the log mats. For instance, I think the Australian marsupials have to be explained by log mats. First of all, I have a paper that I've submitted to Journal of Creation on these marsupials, and first of all, when they found them, they thought they were all Pleistocene, which means the Ice Age period. But then because they date, they actually have a unique dating system for those marsupials. It occurs in South America and North America too. It's called stage of evolution. So when they find a marsupial, particular marsupial, they say, well, that's a little different than what we expect. It's got a primitive feature here. Oh, primitive. Oh, it's got to be older. So let's shove it into the Pliocene or the Miocene. So they keep shoving these things back based on the stage of evolution. That's how they've been dating there for years. They have very few radiometric dates to lock all this in. And so it's all a house of cards. And then I always try to explain how we would explain. I mean, the Lord's led me to answer challenges. And so I got to say, how did they get there? Well, I think the only way we can explain them, they couldn't have got there by a land bridge from Southeast Asia, because there's too many deep straits in Indonesia between Southeast Asia and Australia and New Guinea. And so I don't think they could have got there on a land bridge, or I don't think they could have gone there by island hopping either. So the only possibility is by log mats, where they migrated south, maybe in mass. I don't know why they stayed together, but it appears that they stayed together and ended up on the shores of the Indian Ocean somewhere. And log mats were floating around. Some were beached, and they got on these log mats, and they were spread hither and yon, and ended up in Australia, probably northern Australia to start with. And other features of that I noticed that would support this is that some of the animals that had to be on log mats were snakes and other creatures besides marsupials, and some insects. So they couldn't have got there by even a land bridge. So they have to come by a log mat regardless. So the log mat idea, I think, seems pretty strong. And so that's the article's in review right now, and maybe will come out in a year, depending on how fast. Publishing is very slow, by the way. Sometimes it takes 3 years for something to get out that I do. So I find it frustrating that it's so slow. By the time they get back to me, I've forgotten half about what I wrote.
Yeah, I can see how that would be frustrating. We kind of talked about that last time. And it's even frustrating for me. I'm addicted to reading these articles and papers. I've spent a great deal of time reading through your huge number of articles and papers coming out of CMI. And this question I have is it pertains to some articles you've submitted in regards to some possible objections regarding the fossil distribution of animals post-flood, including the marsupials, as it relates to your position on the post-flood boundary. Now, I know we could probably talk about that all day, but for the audience sake, especially some of the new viewers, I was wondering if you could touch on some of the content in those articles and papers that you've submitted in terms of refuting those objections, Mike.
Oh, okay. Let's see. I submitted them 6 months ago, 4 of them. The Australian one was actually, there was 2 of them for Australia. One was to explain how I would explain how they got there, and second, did a critique with the uniformitarian ideas. Then I had one on North America. The key question is, we have a lot of mammals in North America in the Cenozoic, and it's claimed that they have to be post-flood. So that's been the question all along, and I've examined that. And first of all, the person that challenges me on that set up several straw man arguments, saying that if I believe that those Cenozoic mammals are from the flood, what I have to believe is that before the flood, that they left North America, rounded the Bering Land Bridge to where the Ark was, somewhere in Asia. And then after the flood, they migrated back to exactly where, after the flood, for the Ice Age fossils, and they died exactly on their Cenozoic representatives in the Cenozoic rocks. Well, first of all, we don't have to migrate them from North America to where the Ark was. They could be living near the Ark or on one big landmass. North America wasn't existent then. Secondly, it was claimed that the climate would be too cold for them to round the Bering Land Bridge in Siberia. They were thinking of present-day climate. No, during the Ice Age, it was a mild winters and cool summers, as I said in my talk. So a lot of them would have no climatic problem rounding the Bering Land Bridge after leaving the Ark. And so mammoths and 40 other creatures, mammals, came into Siberia, Alaska, then down the ice-free corridor in Alberta and Montana, into the southern United States and Central America and South America. That's how they would go after the flood. And so there was some straw man. But anyway, I looked at the North America genera that were supposed to be in the Pleistocene, defined as post-flood, and the pre-Pleistocene was defined as the flood from my point of view. And I found out that a lot of these North American mammals, see, it's the claim that why would they migrate just to North America and die with their ancestors? Well, the problem is they're not necessarily North American mammals. You find them on other continents. You find them in Asia and Europe, Africa. So we're not talking about unique North American mammals rounding the Bering Land Bridge and dying above its Cenozoic ancestors, from my point of view. No, not at all. And the Cenozoic mammals could be transported long distances from who knows where. So I've answered a lot of that stuff, but there's still questions that need to be explained. And I was planning on writing 2 or 3 more papers, but I got bogged down into other projects and have not got back to that. So it's been 6 months since I sent it in, and I haven't heard anything yet. So I don't know how it's going.
Well, I got to say,
that's a quickie on that.
That's great. That's a great answer. Extremely helpful. And I got to say, I'm looking forward to hopefully those articles being released at some point, and therefore going through them and reading them. So that was a great answer. And I think we all wish there was just more time in the day, given how many projects, just how many projects you want to get through. So, George, I know you had a question. as well, brother.
Yes.
I don't want to hog the mic here, but George, go ahead.
Yeah, Mike, there was a question from Andrew P. that was posted early into our presentation. He's asking how to explain, and I hope I don't butcher this, and I hope you understand my pronunciation of it. He says, asking how to explain lacustrine indicators in the GRF and the Bidahotchi Formation, such as exploded fossil fish, basin-centered paleocurrents, and Mar craters. That question is in the private chat if you want to read it yourself.
Yeah, I did. There's a lot that can be said. You got to figure out where the flood post-flood boundary is and all this stuff. And there's ways to interpret, like the Green River Formation as post-flood lake. And there's other ways to look at it. John Whitmore and I had a debate about this very subject in 2006 in the Journal of Creation. You can get it all online from creation.com. And anyway, he pointed out what he thought was a post-flood lake. He wrote his PhD thesis on the fossil fish in the Green River Formation. We spent a week together out there looking at various features. And one feature I noticed he overlooked was that the huge amount of erosion in the area. That's the thing that first got me. You go to one of the basins, Fossil Basin, and you can go up over 2,000 feet up a slope. And all the sediments in that whole area were at least eroded 2,000 feet. Now that is an incredible amount of activity after the flood, but that's not the end of it. I discovered in the southern part of the Green River Formation that the Green River Formation was part of what's called the San Rafael Swell. That's a big bowing up of the strata, about 100 kilometers north-south and about 50 kilometers east-west. And the middle of it got eroded off, leaving the edges dipping away from the center. And by trigonometry, I calculated based on the 8-degree dip of the strata to the north, with the Green River Formation being the top formation, I discovered that the San Rafael Swell was eroded about 17,000 feet. 17,000 feet of erosion in the center of it. And the Green River Formation was the top formation on that San Rafael Swell. So what does that tell you? If it's post-flood, you got to deposit the Green River Formation over a huge area, 40,000 square miles, up to 6 kilometers deep near the Uinta Mountains, 6 kilometers deep. And then you got to bow up this swell, erode it, all after the flood, rode 17,000 feet. And where did the sediments go? They're not found anywhere nearby. They're swept clean off the continent. This is an obvious flood signature. And I published this article. You can look it up in 2009 in the Answers Research Journal. Not only that, the Green River Formation has so much oil in it that it has enough energy to supply the energy needs of the United States for 100 years. Where are you going to get that much oil after the flood in a lake and get that thick of sediments over a huge area? No, so much of it doesn't make any sense for a post-flood lake. But like I said, there are indications there that would indicate that. So something happened in the flood to account for some of those features that they talk about as evidence for the post-flood lake. And John Whitmore did challenge me in a few areas on that, and I haven't any answers on a flood formation. The flood waters were draining. So that's it for the Green River Formation. The Betahoche Formation is a little more complicated. You're going to see something about that for those that actually subscribe to the journals. Recently, Steve Austin and two others defended the dam breach hypothesis for the origin of the Grand Canyon, which I believed at one time until I went out there and looked closely and found so many contradictions that with time I gave it up. I didn't give it up right away. I was hoping those that believed in it would answer it. Betahoche Formation is part of this. But anyway, they wrote in the early 2020, they wrote an article in the Answers Research Journal. Well, anyway, I've done a response that'll be published in the Creation Research Society Quarterly in the next issue, going through their challenges and answering them. And the Betahoche Formation is, it's intriguing. It's mostly a volcanic or fluvial deposit. There's a little bit of what's called lacustrine. Now, by the way, lacustrine, and this goes along with a lot of other paleoenvironmental deductions. Those are all based on uniformitarian assumptions. Lacustrine, generally what they call it, they define it as lacustrine. They find some rocks, cobbles, rounded. Well, that's automatically fluvial, up from a river. And so on and so forth. They got dozens of these paleoenvironmental interpretations, all based on crass uniformitarianism. You bring the flood back, and these things are not necessarily lacustrine, even though late in the flood you could have some pockets of lacustrine that look like lacustrine formations. That's probably how I would explain the Green River Formation. So fluvial, of course, would be runoff. I find a lot of rounded rocks in Montana and Washington and Wyoming, and that were eroded from the western Rockies, clear out into central Saskatchewan, southwest Manitoba, central North Dakota, 800 miles from their source. Rounded rocks, quartzites, resistant, tough rocks. And they would just say these are from rivers. Well, they're all over the place. They form sheets, billions, trillions of them, east of the Continental Divide. They came from west of the Continental Divide, 800 miles. So to them, this would be fluvial. To me, it'd be flood runoff. So you could see that the various mindsets define the terms. So the term lacustrine is a very vague term, as well as many other paleoenvironmental interpretations. I hope that answered the question kind of in a roundabout way.
Well, yeah. Well, that was a very in-depth answer. Actually, I think Andrew would be happy with that. I'm not sure where SFT has gone, but I've got just one more question to ask with regards to the magnetic polarity changes. You recall I mentioned the ice cores earlier, but
yeah,
they claim that there's been a number of magnetic polarity changes in those ice cores. How do we explain those?
Let's see. I don't believe that they're in the ice cores. They're in deep sea cores.
Oh, sorry. Yes, you're correct.
Well, Humphreys, I think, has a great mechanism that during the flood there was a lot of oscillations in the magnetic field reversing rapidly. You can look in his material on that, and then but it continued after the flood and damping out during the ice age. And I go along with that model. Yeah, this is, and then they got a whole time scale called the Standard Polarity Time Scale. And this was developed in the 60s by potassium argon dating. See, they had to date all these accurate so that they can get reversals and normals with time. And I think there's a lot of fudging that went on in all that data. But by the way, in the 60s, the potassium argon dating method was not very good. And so I think there's a lot of shenanigans that went on in developing this polarity timescale. But be that as it may, we need to explain the evidence for reversals, and which are about 50% reversals in like lava rocks and in marine sediments too, and the normals. So I would use Russ Humphrey's a mechanism for the magnetic field. I think it's a pretty good model, and that explains them. And they continued for a while during the Ice Age. And by the way, they talk about dating these things. They have, if you saw the polarity timescale, the last reversal was about 780,000 years ago. Went from a reversal to the Bruns normal, and they use that boundary to date other things. By the way, lots of circular reasoning. But when you look at the literature on this, I should publish an article. It's one of those many articles I need to publish but don't have time. When you look at the Bruns normal, 780,000 years, you look at it and there are short segments of reversals through it, about 10 of them, where the polarity went from normal to reverse really quick, and they call them excursions. One of the main ones is called the last camp excursion, 42,000 years ago on their time scale, where it reversed and lasted several hundred years and went back to normal. Well, with so many reversals and normals throughout this time scale, you can have very precise dates to really pinpoint all this stuff. And that's where the problem lies, is that it's just too complicated for them to really do that. The dating methods aren't that precise, and there's so many of these reversals, not only the main ones, but also these excursions, which are supposed to be tiny ones that last a short time. And sometimes they don't reverse totally the whole way. And so many of them, it's just a mishmash of polarity changes. So I consider it a big problem. By the way, paleomagnetism doesn't date anything, because it's just a sequence of reversals and normals that if you include a faster sedimentation rate or a hiatus somewhere, you can make any sequence in the deep sea cores fit the polarity timescale by adding faster sedimentation, slower sedimentation, or a hiatus, a gap. And that's what they've been doing all this time to make everything fit and look like it's really consistent, and it's not. Anyway, I should write an article on that. Anyway, what they do is they have to date these reversals by other mechanisms. They got to say, is this sequence Pliocene 4 million years ago, or is it Cretaceous 100 million years ago? So they date by other mechanisms to put the same sequence in various slots. And so it has to be dated by other mechanisms. So in itself, it's not a dating method. It depends on the other dating methods. Same with the Milankovitch cycles. They depend on other dating methods to calibrate it. For what time periods, the Pliocene, Cretaceous, you don't know unless you date it by another method. So there's a lot of circular reasoning and correlating one dating method to another. So there's a lot of problems in all this. And I've only touched on the part of the iceberg above the water.
Well, I just want to say one thing, George, because I want to point out how I love how thorough your answers are, Mike. And there's just so much good information, even in just this one show. We've had people in the chat point out, they're going to rewatch this a few times just to get all the information. I really love your passion on these important topics. And a question that came to mind based on what you're saying, because to be honest with you, your answers are so informative and thorough that you're answering a lot of questions that we have all in one. For example, the dating method question. I've heard the critics, I've heard the uniformitarians say we've got so many different dating methods that all corroborate each other. They all correlate on deep time, right? But from the sounds of it, you're pointing out that is that based on circularity, or what's the answer to that?
Yes, it's based a lot, mostly on circularity, where they correlate one method to another. In fact, Marvin Lubenow actually demonstrated this, because they don't publish a lot of dates, so you can't really check all this stuff. Anyway, there was a big dispute over Leakey's 1407 skull. I think that's the name of it. And they had to piece it together from several hundred pieces, and it was first dated 2.8 million years by 6 different methods, one of which was paleomagnetism, 2 were fossil dates. So 6 methods, and they all agreed it was 2.8 million years. And that's what they published. Oh, but the paleoanthropologist said that skull, which was pieced together, is too modern. It can't be that old. So they redated it and used 5 out of 6 of the previous dating methods, and lo and behold, they got 1.8 million years. And five of them agreed with that. And so he's in his book, Bones of Contention. The first edition he has it, but in the second edition he left it out, and I really had a problem with that. But anyway, it's published online on creation.com. You can obtain it there and show how these were all correlated, make them look precise. It's all through circular reasoning that they did this. And this is probably just the tip of the iceberg for this sort of thing, because we can't verify. Oh, by the way, they found some old dates on some of them to over 200 million years were some of the dates that they got back with argon, or potassium argon method. I can't remember which. And then they threw those out, and then they got other dates that were 6 million years and 4 million. They got a lot of dates. Anyway, they pick and chose the dates that were closest to what they expected. And it's admitted I got a great quote where they actually pick and choose the dates that agree with what they believe from geology. And John Woodmarape has other great quotes in some of his books on how they pick the date that they believe is true out of probably a smattering of dates. So anyway, it's all a bag of worms. And if people want to know more about it, I actually have a book on dating called The Deep Time Deception, Examining the Case for Millions of Years, put out by Creation Ministries International. So I do touch on these things. This book was written for total laymen that have no science background. So it's not very deep. They want to get some deep stuff, look at Andrew Snelling's stuff. And but anyway, this is for laymen to get them started and to show the case that we do have we can defend a young Earth, and there's lots of problems with these dating methods.
I've got that quote, Mike, if I can read it. It's by E.H. Andrews, Professor of Materials, University of London, and Head of the Department of Materials at Queen's Mary College. In a book, God, Science and Evolution, he says, quote, "Whatever the figures arrived at by the dating tests, they are weeded out before publication in scientific journals. If they do not accord with the preconceived dates assigned to the Evolutionary Geology column." And then there's another one by Richard L. Morga. He's Associate Professor of Geology at East Carolina University. He says, in general, dates in the correct ballpark are assumed to be correct and are published, but those in disagreement with other data are seldom published, nor are discrepancies fully explained. And I've got more quotes that say that, but yeah, the KBS stuff is an embarrassment, isn't it? With the
yes,
the range of dating methods that they used and the range of dates that they received that contradicted
Yes.
each other.
Right. I hadn't heard those quotes before, but I got other ones.
Yeah, like
the
I
same
said, there's
thing.
heaps of them. You just have to search.
Yeah.
There's quote after quote of them admitting to the circularity. Mike, I want to point out that was a great answer, and you have so much good material available for everybody. That's why it's such a blessing to have you on. And I wanted to ask something based on what you were saying earlier. You were pointing out how you've had some cordial debates and dialogue with fellow creationists on some of these issues, right? And
Yes, I have.
And correct me if I'm wrong, because I've read so much on CMI, but I do recall, I believe that you've had a written debate on some of these issues with Dr. John Baumgartner.
Correct.
Okay. I was kind of curious. What were a couple of those issues? What was the debate on? The bigger picture. I find that interesting, and I have read through that. It was a while ago, but it kind of came to my mind when you pointed that out, Mike.
Yeah, I think it was in 2002. There's an online debate in the Journal of Creation with John Baumgartner and myself on catastrophic plate tectonics. As some of you may know, I believe there's evidence for it, but since I read, try to keep up with 50 earth science journals, I find a lot of contradictions, problems with it that aren't solved yet. And I wish they'd work on them and solve them. And I can easily believe catastrophic plate tectonics, but I see so many problems with it that is why I'm skeptical of it at this point. So there's for instance, I've done a lot of work on what's called subduction zones, trenches. There's lots of anomalies there that make one question the plate tectonics and the catastrophic plate tectonics model. But one I just published in the Journal of Creation maybe 3 or 4 years ago was that I don't get into this too much. It's a subject I don't really like getting into. I don't spend a lot of time on it, but I do publish a few of them now and then. And one was 4 years ago, where I discovered that there's these deep sea fans. That's right, deep sea fans that started on the North American plate and spread onto the Pacific plate during the Cenozoic. They dated the Cenozoic. And if there was motion of the Pacific plate compared to the North American plate, which is about 6 centimeters a year to the northwest for the Pacific plate, in relation to the North American plate, which includes not only North America, but Alaska and Northeast Siberia, you should have seen about 1,000 kilometers change, and you should see no consistent deep sea fans going from the North American plate to the Pacific plate during the Cenozoic. And yet you do. You have one that actually crossed from southern Alaska. From Alaska, went south. And it's called the Zodiac fan. It actually is a south of the Aleutian Trench, and even the fan is south, and it's a couple hundred meters thick. It's very wide. They know it came from Alaska. The paleocurrent directions and stuff indicate that, and it wouldn't be consistent. You wouldn't have seen a fan like that from Alaska if the Pacific plate was moving relative to Alaska. And then you go to northwest part of the Pacific plate, you have the Meiji fan that started the North American plate and spread onto the Pacific. And there's no disruption of that over the 1,000 kilometers it should have moved. The plate should have moved relative to each other. So I find stuff like that. And that's published. You can check it in the Journal of Creation. There's another one, the which isn't so convincing. It's the Monterey Sea fan that spread from North American plate near Monterey across the Pacific plate. And it doesn't show any north-south movement between the plates for all the Cenozoic that fan supposedly was being deposited. So I find lots of glitches. I think down the road, I'm going to spend more time looking at it. And right now, I don't spend a lot of time on it. And so 2002 was the debate I had with John Baumgartner on. It's pretty old. And so you can read it on the creation.com website. And so he believes what he believes, and I believe a little bit of what he believes, but I was a weather forecaster for 30 years, and so when there's a lot of uncertainty, I would give probabilities. Like there's a 20% chance of rain today. You've heard them. And anyway, I use probabilities for some of these things. And so I give catastrophic plate tectonics a 20% probability of being right, 80% chance of being wrong at this point. But those probabilities can change with further information. I might end up believing it one of these days, but I need to be convinced on a lot of anomalies.
Well, so many great points there, Mike. And I do remember reading that. And I'd recommend all of the articles and papers that we've kind of referenced and sourced today. I want to respect your time because we are going on 2.5 hours, and therefore maybe out of these 1,000 questions we have, maybe I'll pick out one that kind of sums up many, because there's a question here that I believe does so. And the question, Mike, is, and I believe you've written on this too. I remember reading an article on this. Are fossils as neat and organized as the evolutionists would have us believe? Or are there any out of order fossils? Mike, what are your thoughts on that?
Oh, okay. Well, there's certainly a lot of out of order fossils with overthrusts, but I believe that many of these overthrusts are real. I was skeptical at one time, but I've come around to believe that most of them are real. Yeah, I run into them now and then. For instance, dinosaurs. I've run into 6 research reports of finding dinosaurs above the Cretaceous into the Paleocene, or Paleogene as the Europeans would look at it. And they've been eggs or tracks or something like that, or bones. And there's a statement by a famous dinosaur researcher that says that we actually date the strata by the dinosaurs. You find a dinosaur, it's automatically older than 65 million years, and we don't find them above. So there's a lot of some circular reasoning there. And these other ones, they claim were reworked. They have that one where in the Paleocene, it was eroded from a Cretaceous sediment, and the fossil went with the erosional debris and was deposited in the Paleocene. So that's usually what they say. But eggs and tracks, you can't do that because they don't erode. So they just simply redate the strata and say, hey, this is not Paleocene, it's Cretaceous. So they do that. But one in the San Juan Basin in New Mexico, they found some big dinosaur bones out there that were claimed to be Paleocene, above the Cretaceous Paleogene boundary. And the guy is sticking to his guns. I haven't read anything on it, but these are big bones. You can't really rework a huge dinosaur bone from the Cretaceous up into the Paleocene. So I haven't seen any responses. I haven't seen what they say about it. It's just kind of left hanging as far as I'm concerned. They probably don't know what to do or say. But this is kind of how they do. So you're not going to find too many out-of-place fossils because they make them in place, a lot of them. But there is order to the geological column in the fossil order. I go along with the general geological column and a general fossil order, but I've run into enough exceptions that I'm kind of skeptical of a precise order that they claim occurred based on evolution over deep time.
Mike, in a recent debate on this channel, an atheist who was debating a Christian stated that if there were fossils found, dinosaur fossils found above the iridium layer that was caused by the Chicxulub impact, then that would disprove evolution. I've got news for that guy. Dinosaur bones or dinosaur fossils have been found above that iridium layer.
Yes,
paleontologists have reported on it.
Right. And they just explain it away by several possibilities, of which I mentioned two: reworking and just redating the strata.
Yeah, that's why it's unfalsifiable, because they always have a rescue device for whatever contradictory piece of evidence that we find. And that's why it can't be a scientific theory, because they have all these rescue devices.
That's right. Rescue device is a very good term for them.
Yeah.
Well, I'd wonder, George, if that specific individual you are talking about, if he saw that information that he said would convert him away from evolution, if he would actually convert or do what Mike said, rework and resort to circularity, because I would probably bet on the reworking, as they're so good at. So that being said, I want to respect Mike's time. We're going on 2.5 hours, and I want to thank the audience for so many great questions. I mean, we could probably ask questions all day, and Mike, I could listen to you all day. You're incredibly thorough, and your presentation was awesome. It's a must watch. It's an honor to have you on, and we're happy to have you on anytime again in the future as well. So Mike, thank you so much again for giving us your time. I also want to hand it over to you for some final thoughts and some final words.
You're welcome for the compliments, and I hope it really blesses people. In fact, that's the point of the ministry that the Lord's led me to try to answer questions. And so I've done this, and there's a lot more to go. And so that's why I keep working full time, including Saturdays. I just hope hopefully the Lord will give me good health my later years, and so I will keep on keeping on, and I hope it blesses people.
Amen, brother. Amen.
Amen. Yeah.
You will be in our prayers, of course, because you are an incredible blessing, and this really was a blessing, and so many people are profiting from it. Your answers have been incredibly helpful. George, thanks for joining me as well to help host this event that I think was so great. George, did you have some final words, brother?
I'd like to thank Michael as well, but I'd also like to apologize to him, because it seems these streams just give him more ideas for more articles to write. So, sorry, Michael.
Yeah.
Never-ending projects.
I'm working on one that's going to be at least 5 parts right now. They actually discovered, or actually have measured, the amount of sediments in the ocean. And so I'm working that backwards, because that sediment came from the runoff of the floodwaters, practically all of it. And you know what? The amount of sediments in the ocean indicate that the amount of erosion on the continents was about 1,900 meters. 1,900 meters was eroded during the recessional stage of the flood. And it's in the ocean, various places, especially the continental shelf. And they all got this all measured all over through the ocean. It's pretty hardcore. And so I'm working that and working it backwards to say, what does it say about the late flood? First of all, a lot of huge erosion, and I've calculated 3 areas of erosion that are giving me big numbers, so it's about right. And then we got to say, well, we have about 3,000 meters left of sediment on the continents. The exact number is variable. We're getting various researchers that give us various numbers. I'm doing this with John Reed and Peter Klevberg. And so if you have 3,000 meters and add another 1,900 meters for approximately 5,000 meters at the peak of the flood, what is this saying about the early flood? You got to generate enough sediment to have 5,000 meters at the peak of the flood. Wow. Where does that come from? I mean, there's a lot of questions working it backwards. We got 5 papers already semi-outlined out, and I've done almost the first 2. So that's what I'm working on right now.
And Mike, we've done quite a few streams on erosion. I mean, the secular erosion rates suggest that the Earth's dry landscape should have eroded within 10 to 12 million years. So that's a problem for them. Even when you consider orogeny or uplift,
right?
You still can't get that figure down like 10 to 12 million years. Like that's like the landscape eroding 300 times in that life of the Earth, the deep time life of the Earth.
Right. They got a lot of problems trying to explain that. But I'm trying to explain from the flood what's there. We finally found out what's there in the oceans, and I'm trying to figure out what's there on the land, and I'm getting different numbers, but it's getting to be about 3,000 meters about, if I averaged several of them. So that the sediments, where they're at, that tells us a whole lot. Huge. I think at least 5 papers are going to come out of this, and probably send them to the Creation Research Society quarterly. So your readers should subscribe to the Journal of Creation, the Creation Research Society quarterly. If they don't, they'll see all kinds of good stuff, new stuff by me and a lot of other creation scientists doing research.
And did you recently speak? It must have been a few years ago now, but on the Creation Conference, the latest one, I believe it was, Mike.
Which Creation Conference?
I think it was it 2016 or I can't quite remember what. I'm not sure if it was on the recessive stage of the flood, or I could be wrong. I've got it mixed up right now. I'd have to look it up. But yeah, I would definitely press my audience to subscribe to the Journal of Creation, where tons of good information is constantly coming out. And I think you said it last time in our presentation, Mike, where we all know we could attack evolution in deep time all day. They got so many problems. Right. But you are seeking to answer some of the tough questions. Some of the
I am.
Problems with the flood itself. And I really respect that, because you're coming up with so many good answers to essentially some tough questions and objections sometimes.
Mm-hmm. Yeah, and the Ice Age after the flood, that both periods.
Right, and that kind of brings us back to the topic that we were here today, to present and discuss the post-flood Ice Age. The Ice Age being best explained through, you could say, the ripple effect of the flood itself. So I really appreciate this presentation and the time you've given to us, Mike, because I think our previous presentation was about 2.5 hours as well. So I think we've got almost 6 hours of answers and amazing information from you, Mike. So I cannot thank you enough. I know George as well is extremely excited for these. So thank you again, Mike. Thank you. You're welcome. Thank you to the chat and all your questions. And God bless everybody. We'll see you tomorrow for another flood presentation with Sal Jardina. So everybody, God bless. God bless Mike, and God bless
Michael.
Yeah, you too.
Okay, looks like we are live, and I want to welcome everybody to Standing for Truth On Standing for Truth, we focus on the truth of biblical creation. And it is a privilege to have Mike Oard back here with us today for an incredibly important show. Now, I want to point out to the audience, this is Mike's third time on Standing for Truth, and I have linked his previous presentations in the description box. The first presentation focused on the recessive stage of the flood, while the second focused on the Ice Age. So please check those out. Tons of great information. They are definitely a must-watch. Today, we will be focusing on evolutionary challenges debunked. And I want to thank Mike for giving us his time. Mike, I know you're busy, so I really appreciate it, Mike.
You're welcome.
If you, I want to point out to the audience, they can tag me with their questions. They've already been doing so. Just make sure you're tagging me at Standing for Truth. We will have a short audience Q&A after the presentation. So, Mike, since this is your third time here, maybe I'll just hand it over to you. You can have the floor. If you wanted to give a few words of introduction, you can do so, and then we can kind of get right into the presentation.
Well, the Lord has led me over 45 years of creation research to answer or attempt to answer challenges to the biblical worldview. And of course, I work in earth science, so that's what I've been doing, like the Ice Age that I talked about last time. What about woolly mammoths, dinosaur tracks and eggs, which I will talk about. Anyway, I've titled this Reasonable Answers to Earth Science Challenges. The reason I added reasonable is because it's in the past, you know. These are reasonable answers, and they could be wrong with further data. But anyway, I think they're reasonable. I can't say they're exactly a fact, but they're reasonable answers to the biblical worldview. So I read, try to keep up with about 50 earth science journals. And by the way, there's many, many more. It's a time factor for any more. And I come across all kinds of challenges. Actually, there's hundreds of them. Some of them I've worked on myself. Like, how does the flood cover Mount Everest? I've done that one. This is a short list I made in about 5 minutes off the top of my head. But if I spend a year, I could probably get a couple hundred. To me, they're research projects. And we do have answers to many of these already. And some are we don't. We have partial answers. Partly because it takes a long time for some of these things to be able to give answers. Here's another list. I've worked on some of these, and these challenges have really affected a lot of people over the years, since they assumed the Earth was old in the late 1700s, throughout the flood, then added evolution in the middle 1800s. So these challenges have produced some really bad fruit within the Christian churches. It's caused many to doubt God's word. Caused tens of thousands of atheists and agnostics, if not millions. Caused tens of millions of Christians to think what they're hearing or reading is a fact, so they try to fit it into the Bible. From my experience, you don't have to do that. The Bible can defend itself. It's enhanced the local flood myth. It's resulted in a mass exodus of the youth, as a number of polls show that after college, many Christians, a majority of Christians, leave the faith for various reasons. The biggest reason, from another poll from Answers in Genesis, indicated that the age of the earth question was the number one issue, and evolution was a secondary one. So these things, we're just not talking about academic things. We're talking about things that affect many people. But a closer look at challenges. Many do not realize that most of these are also challenges to evolution or geology. A lot of people wouldn't know this because a lot of times they papered over their difficulties with another hypothesis, and it sounds reasonable. But when you dig into it, you find out that many of these same challenges, they can't answer either. Also, there's not enough known in the earth sciences. There's a lot unknowns. A lot of people don't realize this. In fact, we have probably tens of thousands of earth science researchers, and researchers always do research on questions and unknowns. This just gives you an example. The biggest unknown is what's below our feet exactly. We can tell a lot of things with geophysics, but still there's a lot of guesswork in all this stuff. Many do not know that the creation flood ice age model does have solutions to many of these challenges. Just look on the websites, for instance, you can find answers. Some challenges take a long effort, and some will not be are not able to be answered now. So we can't have every question answered, but we have a lot answered to give us faith that there are answers out there. It's either a long effort or there's just not enough information. And one of the problems is the lack of workers and funds. Those are some of the closer look at challenges. When I read challenges, I read them all the time, I am like the Bereans. I check it out. And my theme verse is that examine everything carefully, hold fast to that which is good. I'm going to hold fast to the Bible as God's word, and Jesus is my Lord and Savior. But I'm going to examine everything carefully that I read in science. One thing you'll find out when you examine these things is there's observations and there's interpretations. The real issue is over the interpretations of the observations, not the observations themselves. You need to remember that anytime you're reading secular literature. Also, 1 Peter 3:15 says that we need to set Christ apart as Lord in our hearts and be ready to give an answer to anyone that asks us the hope that's within us. Yet we do it with courtesy and respect. In other words, we need to have answers to people. And we can't answer every question, of course, and that's why we have those great websites, the books and DVDs out there to help us. So I got, George gave me 2 challenges he wanted me to answer or to provide a reasonable answer. So I'll do those 2 first, and then I'll do some ones that I've worked on. And then I'll let you in the audience ask questions, and hopefully I can get a reasonable answer to many of them. Anyway, the challenge of how sedimentary layers form rapidly. Well, there's, I think, several mechanisms. Turbidity currents. We know that turbidity currents, they have a lot of water in them. They're not like debris flows, which have a lot less water, but they flow down a slope and then spread out long distances. And when they do, they kind of segregate into different layers for some reason. I haven't read yet why they do this, but it's generally a coarse and a fine layer, and there's a number of them all at once. But you can imagine during the flood, you had huge turbidity currents, probably 10,000 times the size of the little ones we get today. And you could possibly form rapid layering over, say, 500 feet really quick. Another mechanism, which could be similar to turbidity currents, is that when you have particles of different shapes, mass, and or density, when they're flowing out, they will segregate by the differences of shape, mass, or density all at once. Like you have a coarse layer and then a finer one, and as the current moves, it deposits coarse, fine all the way, forming 2 different layers. This was illustrated and worked out by Guy Berthaud of France. Also, another one that people really aren't aware of is internal waves. We know that the ocean they have surface waves, but there's all kinds of waves down below in the surface, caused by a current going against an obstacle causing a wave, or any difference in density, or any other property of the water. You can cause a wave on it. Sometimes these waves, they will have sediment in it, and when it does that, it will sometimes even erode the bottom, and then they redeposit it, forming layers. So internal waves. And by the way, there's thousands of internal waves probably going on right now in the oceans. They're very common. And during the flood, I imagine with all the tectonics and chaos, there'd be millions of internal ways. So there's lots of ways to get layering rapidly during the flood. The second challenge that George wanted me to get into was mechanisms for rapid formation of unconformities. There's several types of unconformities, but he meant angular unconformities, where you have sedimentary rocks like this and at that angle, and then on the top you have it horizontal. There's an angle maybe 15 degrees between those layers. That's an angular unconformity. Anyway, there's a classic spot in Scotland that was used in the late 1700s to put over on people and scientists that uniformitarianism must be true. Uniformitarianism, present processes over millions of years. And that was unconformities, a famous angular unconformity. But before I get to that, the main mechanisms of forming the angular unconformity is tectonics. During the flood, you had a lot of up and down motion of the sediments and the granites, and then you had rapid currents. So as you bow up, say, a ridge, you can have a current sheared off, and then another layer lay down on top of it, all in rapid succession. This is what you expect during the flood. So we should expect many angular unconformities. Anyway, I thank Taz Walker of Creation Ministries International in Australia for this section. It's a kind of an icon of geology, unmasking Sycamore Point, secular geologist sacred site. It's right there in Scotland. That's where this senior moment, his name skipped my mind, but I'm coming to him. It's where he claimed in the 1700s that that can't be explained by the flood, therefore uniformitarianism must be true. This is Sycamore Point. You can see, it's kind of hard to see, but you see over in this, you see vertical strata that was once horizontal and now it tilted up like that. And there's horizontal strata on top of it. Here it's not tilted vertical here, but here it is. And you can't hardly see it too much, but I'll show you other pictures. Hey, James Hutton, yeah, called the father of modern geology. Anyway, you can go visit there. It's kind of a special geological site that many people visited. James Hutton Trail opened in 2006. You can walk it. It's on Hutton's farm. Anyway, Hutton ignored the Bible and is generally regarded to approve the Bible got the age of the earth wrong. Of course, he didn't. He assumed it. Here's a better picture of it right here. You can see the vertical sedimentary rocks, strata. And here's the horizontal sedimentary rocks on top. Vertical, horizontal, boy, that's quite a change. Well, you know, when you look at the signage at that site, you actually see how they think it was done. And this is exactly how I think it happened fast in the flood. You had the folding of strata. We had some vertical strata fold like this and like this. This is hard to see. It's on the right side of my screen. And then you fold the strata and then you shear it off. Now, with uniformitarianism, you don't expect really fast currents. How are you going to shear all this off to a generally flat surface? Big problem. You can do it in the flood. Then after you shear it off, you deposit sediments on it, and then it deforms a little bit. So that's how supposedly Sycamore Point was formed. And most people that at this time thought the world no older than a few thousand years. Hutton realized that geology time is virtually unlimited, but he assumed it first. And here's kind of a block diagram of it, an illustration that Taz did. See, old red sandstone, nearly horizontal on vertical Caledonian strata. And it's generally flattened to a nearly flat surface. And if it was long periods of weathering, you know, I mean, they give these things millions of years for each formation and between these formations, you see. You should have huge weathering and big, deep valleys, but Taz only made little tiny valleys and ridges in here. And that's what you should expect. weathering, but you don't see that. You see it's cut flat. And not only that, you find breccia layers. Breccia are angular rock fragments in it, indicating that you had a ferrocurrent that probably formed this flat surface and eroded some of it, leaving it in the bottom layer as angular rocks from the substrate, indicating catastrophic action. So that's how unconformities form. So here's, let's move on to some challenges that I've worked on. I haven't worked on this one too much, but my late friend, Harold Coffin, did. He spent 30 years working on the so-called Yellowstone fossil forests. And this is considered a major challenge in geology. Well, here's some pictures of it. Notice the sediments in it. It's actually volcanic breccia. They're volcanic breccia flows that are spread. It's called the Absaroka Volcanics. They're spread over 6,000 square miles and 6,000 feet deep, and then deeply eroded after they're all deposited. And within these, you find these vertical trees. You find horizontal ones too, I might add. A number of vertical trees up and down a cliff like this. They're petrified. By the way, some are not quite petrified. I've seen some that in the middle seem to be unpetrified. Anyway, this is at Specimen Ridge. And here's kind of the picture that geologists tell people. This is a diagram, a crude diagram, where they say there's been successive forest grow. And they're overwhelmed by this volcanic debris flow, or lahar. And it took, the forest is 500 years old to start with, because some of these trees are 8 feet in diameter. And it overwhelmed it, and then it took 500 more years for it to grow. And then so we got about 1,000 years in each layer, they claim. 1,000 years. And on Specimen Ridge, which is in Northeast Yellowstone Park, which is only an hour and a half from where I live, by the way. As you can see, I'm wearing a nice Yellowstone Park t-shirt. There's about 24 levels there. So that represents 24,000 years approximately. But there's another place in the Northwest Yellowstone Park called Specimen Creek. They're two totally different areas. Here's a quick picture. When you even see one vertical petrified tree at an angle, but if you got to look close to see them up here, but there's about 65 layers here up this cliff. 65. And that would represent maybe 65,000 years. So the geologist has been parading this around for dozens of years. And here's an example of who was once a young Earth creationist that said this example made him lose his faith. It was Ronald Numbers. He talks about it in the second edition of the book, The Creationist, 2006. By the way, this book is just tremendously biased and lots of errors. Anyway, he says on page 13, born and reared in a fundamentalist Seventh-day Adventist family of ministers, I learned George McCready Price's version of Earth history at my parents' knees. I subsequently attended Adventist church schools from first grade through college, and though I majored in science, I saw no reason to question the claims of strict creationism. In fact, I do not recall ever doubting the recent appearance of life on Earth until the late 1960s while studying the history of science at the University of California at Berkeley. I vividly remember the evening I attended an illustrated lecture on the famous sequence of fossil forests in Yellowstone National Park, and then stayed up much of the night with a biologist friend of like mine, Joe Wiley, first agonizing over it, then finally accepting the disturbing likelihood that the Earth was at least 30,000 years old. Having thus decided to follow science rather than scripture on the subject of origins, I quickly, though not painlessly, slid down the proverbial slippery slope toward unbelief. He's considered an agnostic, but this last part of the quote. Notice he decided to follow science. Well, he should have followed scripture, really. But he didn't really follow science. This was not science. This was the interpretation of those petrified trees in Yellowstone Park. It's an interpretation. My late friend Harold Coffin has spent 30 years researching this, and he's published in the Seventh-day Adventist Journal Origins and elsewhere a good solution to this problem. Before Ronald Numbers published a second version in 2006. In fact, I looked, and Ronald Numbers doesn't even reference Harold Coffin or any of the new work done on this. Poor scholarship. Anyway, what you find there is that, first of all, trees need soils. There's no soils. There's organic layers. And in those organic layers, which are either paper thin or maybe about 5 inches thick, at maybe the thickest, you find organic matter that's not decayed. You find fossil leaves, you find needles, but no soil. They're not soils. So there's no soil. Also, when you examine the types of trees, you find out there's about 200 species of trees from tropical climates to cool climates all together there. So there's other problems, many problems that he should have known this, especially for a second edition, and realized that he made a mistake long ago when he accepted this and claimed this is why he lost his faith. There's probably much more to it than this, but this is what he said. So these challenges have some big effects on people, and they need to learn how to deal with them, to think through them, look at the observations and stick to scripture and look and challenge the interpretations. Okay, let's move on to another one, which I have worked on a fair amount, the challenge of dinosaur tracks and eggs early in the flood. So many people think the early flood was chaotic everywhere. It was chaotic in a lot of places. The more I know about the flood, the more chaotic I've seen, but there's calm areas, and a lot of things happened early in the flood. So this is a challenge that they give us to answer. But the secular scientists have their own challenges when it comes to dinosaurs. They think dinosaurs are on their side. They can use it to influence people to believe in evolution and deep time. But they have a lot of challenges. I'm not going to go into these. These are just mostly a summary of challenges I worked on because I want to allow room for questions and answers. Anyway, they find they don't have any answer to the origin of the dinosaurs or how they went extinct. They have over 100 theories on how they went extinct. Also, they find polar dinosaurs, a lot of places, Antarctica, Alaska, Spitsbergen, Siberia. Also, there's a lot of desert dinosaurs, a lot of three-toed dinosaur tracks in the desert, supposed desert. Well, what are they going to eat in a desert? Maybe these aren't desert sandstones, these dinosaur tracks are. Maybe they're water laid after all. And one of the biggest one is the dinosaur soft tissues issue, which the Creation Research Society, their iDino project, is spending a lot of time and effort to really research. There's lots of dinosaur soft tissue, and from what we know, it can't last more than thousands, maybe 10,000, 100,000 maybe years at the most, but yet they claim these are hundreds of billions of years old, some of this. And by the way, they're finding soft tissue in other organisms besides dinosaurs. This indicates that their millions of years is untrue. Anyway, when you look at dinosaur tracks and dinosaur material, you'll find it's it's at the top of the continental layers. It's usually on top of thick sedimentary rocks. And from areas around it, erosional remnants or eroded anticlines or other features, the rank of coal, you can find out a lot of sediment was eroded to get down to the level of the dinosaurs. And that's Roy Holt called that the Erodozoic, and that's actually retreating stage erosion. You have the flooding stage for the first 150 days where the waters rise, and then the retreating stage where the waters fall for 221 days. And during that time, you eroded a lot of the continents as the continents were coming up out of the floodwaters and the ocean basin sinking. Lots of evidence for this. By the way, one of my latest research projects is to try to determine how much sediments is left on the continent and how much was eroded off. And I'm getting some fantastic numbers based on new data of how much ocean sediments and how much sedimentary rocks are left on the continents. Thanks to the work of Tim Clary of ICR, he figures there's probably about 2,300 meters of Phanerozoic sediments, but there's another 1/3 of Pre-Cambrian sediments. So altogether, there's about 3,000 meters of sedimentary rock on the average on the continents. It varies a lot, from 0 to maybe 20 meters or more. And in the ocean, they've determined how much. And most of this, I believe, is that we find in the ocean was eroded during the retreating state of the flood. And based on maybe half the deep sea sediment being post-flood, there's lots of mechanisms to get rapid sedimentation during the ice age on the bottom of the ocean. I estimate there's 1,800 meters that was eroded off on the average on all the continents during the retreating stage of the flood. We're talking about massive effects. So at the peak of the flood, there was an average of 5,000 meters of sediment on the continents. That has a lot to say about the early flood, which I'm in the process of exploring what all that means right now. But that's kind of got off myself on a tangent. But anyway, the dinosaur are on thick sedimentary rocks. And then when you look at the tracks, you find a lot of unusual features. Assuming they were made in a natural environment, it's unusual. For instance, tracks of likely poor swimmers are rare. For instance, Stegosaurus, Triceratops, and Ankylosaurus. You wouldn't, because these aren't just built for floating very well. That they likely died early in the flood and didn't leave tracks. Then another really key factor is practically all tracks, and there's millions of dinosaur tracks now. They're finding them fairly frequently. Practically all from adults and older juveniles. Where are the young? Well, when there's a catastrophe in, say, Africa, where there's a lot of elephants and other animals, you find tracks of not only the adults, but also babies. Lots of babies. So the fact that they're not there indicates, well, what happened to them? It's not a natural environment. Possibly thinking that, well, maybe the young were too small to escape the floodwaters and got buried and destroyed, pulverized right away. Well, the adults and older juveniles were able to escape for a while. I'm not saying there's no baby tracks, I'm just saying practically all tracks are from adults and juveniles. There's some baby tracks, not very many. And also, when you look at the tracks, when you find 2 or more tracks as a trackway, they're practically always straight or gently curved. And they're always on a single flat bedding plane. They don't seem to ever climb hills to the next layer. They're always on a single sheet of the bedding, the top of a bed. And also, when you find tracks in areas with a lot of sedimentary rocks, and you find different layers of tracks, like in northeast Wyoming, there are sometimes the same or similar tracks on 2 different layers of strata, which in the case in Wyoming, they give it 3 million years apart. What's the odds of the same dinosaurs coming in the same area 3 million years older and making the same tracks, the same dinosaurs? Not very likely. So that got my interest up. So I did further research. So here's a few pictures. This is in northeast Wyoming. Here's you can see this straight track right through the 3-toed carnivorous dinosaur. There's other ones. Here's the plot they gave. This is the one I showed you right here. I imagine everyone can see my cursor. And then there's other tracks there. And then there's unusual egg features. There are also millions of dinosaur eggs in the strata. First of all, there's very few nest structures. There's probably less than a dozen that I've read about or heard about. A nest structure being a bowl where the eggs would be placed in it with the upraised rim. And there's also the eggs have no vegetation, indication of vegetation if they're laid on a flat surface. So the eggs look like they're just laid on a flat bedding plane. What's the issue with this? Well, they're finding out that dinosaur eggs are very porous. And if they're sitting there out in the air, they're going to dry out really quick and die. The embryo will die. So this is an unnatural situation. And here's probably one of the few good actual nests in the geological record on top of Egg Mountain, Montana. By the way, this so-called Egg Mountain is about 50 feet high. I mean, we have some good high mountains here, but why they called this Egg Mountain is beyond me. But anyway, the dinosaur eggs are in this plaster jacket, and here's the upraised rim around it. So that's a real nest structure. There's a number of them in the area, by the way. So I explained it by the beds hypothesis. BEDS stands for briefly exposed diluvial sediments. Diluvial is an old name for the flood, and they're only briefly exposed. Well, how does this work? Well, I have a block diagram to show you. Well, first of all, why were you going to form briefly exposed diluvial sediments? Because sea level, if you quote unquote, or flood level, is going to oscillate up and down during the flood at various scales, temporal and spatial scales. So a local drop in the floodwaters can expose a freshly laid deposit of sediment, and then a rise can cover it up and preserve it. So here's a nice block diagram. And they're in areas of thick sediments. So you had rapid sedimentation. So at T1 right here, the top of the sediments are here, and you're having rapid sedimentation. And then at T2, it's up to here. In T3, you're up here. You're getting close to the top of the floodwaters. But the floodwaters are oscillating up and down at various scales. And one scale, you have a local drop, and it exposes the top. This block diagram might represent an area 200 miles wide. But I'm just making a block diagram to illustrate the point. So there they would make tracks, lay eggs, and then another rise comes and covers them all up. See, you got to bury all this stuff to preserve it. Tracks are ephemeral. They're not going to last long, maybe a days to weeks. So you got to bury them rapidly. So the flood would be, this BEDS model would do it. So there's 5 mechanisms. I'm not going to go into these, except maybe one. There's 5 mechanisms that cause the floodwaters to oscillate at various scales. And of course, lunar tides, 2 a day, and especially on a mostly flooded Earth, probably are going to be huge. And they're going to be twice a day. So that's one mechanism out of these 5. There might be more, but these are the 5 that I've found. Anyway, here's a little block diagram. Thanks to Melanie Richard for drawing this. Think of this area as maybe 100 miles wide. So it becomes exposed. Dinosaurs come on up, make tracks, lay eggs. Some die during a local fall, and then suddenly it rises again. And of course, the floodwaters are muddy. And so they're going to lay down a layer of sediment rapidly on what was done, the tracks, the eggs, the dead dinosaurs. And in this case, it doesn't have to be the case, but they stayed there. It could have been washed off. But then when you get another drop, they do it again, because it's illustrating that you can have multiple layers of these things in regions or local areas, which you do have. So this is how you would explain it. And by the way, there's a lot of associated features with these dinosaur tracks, like true mud cracks. By the way, you can form mud cracks underwater. They're called synergesis tracks or diastasis tracks, if I'm pronouncing them right, caused by generally chemical changes and things like this. Also, raindrop imprints. I could show you pictures of these. Bird tracks, coprolites, so-called paleosols, which I think are just, they claim a lot of paleosols in the rock record, but I think these are just chemical effects on the sediments. And so they claim they're paleosols. They account for burrows and tracks of invertebrates and also even social insect nests. You can account for all these also with this. And if you want to know more about it, a lot more about it, you can get it out of this book, Dinosaur Challenges and Mysteries, how the Genesis flood makes sense of dinosaur evidence, including nests, tracks, nests, eggs, and scavenged bones. So that's one challenge that I think we have a reasonable explanation for it. Well, the secular scientists still have a lot of explaining to do on those unusual features of tracks and eggs. The challenge of the deposition of coal. You probably all heard that coal forms in a coal swamp over hundreds of thousands and millions of years. But that model has lots of problems, as many creationists have pointed out, especially when you think of a 200-foot seam of almost pure coal, which they claim represents 2,000 feet of peat scrunched down to 200 feet as it compresses. So why wouldn't you have other debris in there? Why pure? They have numerous problems with the origin of coal, but I think one good explanation is this beds model. And you got to kind of use a little imagination here. Anyway, here's a flat bedding plane, and during the flood, you had billions of logs and other vegetation ripped up and floating on the surface of the earth. And this log mat model can account for a number of geological puzzles, by the way, but that's a topic for another time. Anyway, these log mats, as the local sea level drops, the log mat or debris mat, vegetation debris will beach on top of the beds. And a local rise can, if it has sediment in it, could sedimentation so fast that the vegetation can't refloat and it forms a layer. And even it's possible that dinosaurs can walk on top of this vegetation, making tracks in the vegetation, which ends up being tracks on the top of coal mines. Yes, indeed. Coal mines in Wyoming, Colorado, Utah, Queensland, and the UK have dinosaur tracks at the top of some coal mines, connecting it with this beds hypothesis. So as more sedimentation occurs and compresses the vegetation, coal forms. Coal forms around 150 to 250 degrees centigrade, depending on the rank. And like here, right in here, with thick sediments. And then during the recessional stage of the flood, you eroded a lot of sediments, exposing coal at the surface in many areas, like this right in here. In fact, for bituminous coal, which we have in Montana here, it takes about 2,000 feet of overburden to compress it and heat it up enough to form coal. 2,000 meters, according to the secular science. And then all that has to be eroded to expose it at the surface, like we have some mines at the surface right today. So that's how you can form coal rapidly in the flood, by the beds model. Also, they challenge us on the origin of caves and speleothems. Many of you have heard, it takes millions of years to form caves with these beautiful stalactites and stalagmites and columns. Well, just check it out. But here's a column. Look how wide and how much calcium carbonate has collected there. And so that has the appearance of being millions of years old. But we need to gather the data first. And here's the challenge Arthur Strahler has challenged us a number of times in this. I consider this a book of research projects, but he got a lot of things right. He read a lot of our books and got a lot of our what we believe correct, but he got some things wrong too. Anyway, this was published in 1987. Here's his challenge to us. If it can be shown that either the excavation of caverns or their subsequent filling, that is with the stalactites called speleothems, must require a vastly longer time to accomplish than the post-flood limit, that is about 6,000 years, literal acceptance of the Genesis chronology is untenable. We turn first, he's going to try show the readers, to the rates of removal of limestone by the process of carbonic acid reaction. Okay, there's a number of problems with this. First of all, he has problems with carbonic acid even doing any of this stuff. As Emil Silvestru has pointed out in his book, the Cave book, and articles he's written. Carbonic acid is formed by carbon dioxide in the atmosphere that combines with water, rains, and enters the soil. And then the soil has organic matter and the roots of trees, so forth. And so you build up soil carbon dioxide also that supposedly combines with water and seeps down into the limestone below. There's a lot of problems with that. Carbonic acid in the soil is neutralized within 1 to 10 meters down. If it goes down a crack, it reacts with the carbonates and soon is totally neutralized. It's no longer acid. And it stops. It's not going to do anything. So how are you going to go down, sometimes 1,000 meters down, and form a big cavern? Problem. And then they say they find out that the speleothems that they claim are millions of years sometimes can form pretty fast. And they're too young. I'll give some examples. They generally form at 0.1 to 3 millimeters a year on the sides, increasing on the side and on top too, for the ones that are stalagmite mites on the bottom. So one thing you observe with caverns is that it appears the cave opening was formed first with no speleothems, and the speleothems formed after that with no increase in the cave. If it's uniformitarian, cave openings and speleothems will all be forming at the same time, and you should have a mess in those caverns, not the beautiful stalactites, stalagmites, and columns that we do see. Anyway, from the book Cave Minerals of the World by Carol Hill, an old Earth creationist, by the way, from the University of New Mexico, and Forte, heard this statement a lot. This is not what they believe. This is what they commonly hear. A large stalactite or stalagmite takes millions of years to form. That's what people think. That's what they hear. But this is what they've discovered themselves. Caves take more likely only tens to hundreds of thousands of years. That's it. Not very long within their time scale, assuming uniformitarianism. But that's just the problem. They assume uniformitarianism. And this can be explained by the flood and the ice age. So we have two creationist challenges. First, form the opening. Secondly, fill that opening with speleothems after the opening is formed. Okay, the first challenge, the origin of the cave opening. Well, they've discovered recently, probably after Arthur Strahler wrote that about carbonic acid in 1987, that sulfuric acid dissolved as was the dissolution process in Carlsbad Caverns. By the way, I think there's about 300 other caves in that Guadalupe Mountains where Carlsbad Caverns is located. Anyway, they believe that all those were formed by sulfuric acid dissolution. You know, sulfuric acid is going to eat out limestone much, much faster than the weak carbonic acid. So at one time, they thought that 10% of the caves were what they call hypogenic, that is dissolved by sulfuric acid. But now, with more research, knowing what they're looking for, they now believe that more than 50% were dissolved by sulfuric acid. That can happen rapidly, and that can happen in the flood. And here's how I'm going to show you how I think it happened during the flood. But here's Carlsbad Caverns. Many of you have probably been there who live in the U.S. And down in there, they say there's massive gypsum on the floor. And here's a picture of it. It's about 12 feet thick. Gypsum is a product of sulfuric acid dissolution. See, that's the evidence. And there's other evidences for sulfuric acid dissolution besides gypsum. Anyway, here's a picture of it that I took in Carlsbad Cavern, about 12 feet thick of gypsum from the dissolution of the limestone by sulfuric acid. And here's a quote from a recent book published in 2017. There's about 700 some odd pages. And in the introduction, they say, more attention to hypogene karst. The karst is the limestone where the caves form and sinkholes form and other features form there. Hypogene means from sulfuric acid or any acid dissolution besides carbonic. I mean, there could be strong organic acids possible too. More attention to hypogene karst since 1990, and particularly the dramatic burst of studies in this field during the last decade, has changed our notion of hypogene karst from a curiosity to one of the fundamental categories of karst, at least a comparable importance with more familiar epigene karst. Epigene is the carbonic acid type. It's at least comparable in importance to these. But and he says later on, I think I got this, yeah, okay. Hence, the potential for the development of hypogene karst, that is by sulfuric acid dissolution, is immense, not only in the continental domain, but also in the oceanic domain. Moreover, even in Europe and North America, many areas have been recognized only recently to host hypogene karst, and its study is still ongoing. This means that the next edition of volumes under this title will be next editions of volumes under this title. In other words, you have a 700-page book going through all these in the world at that time. And he's thinking that more are going to be discovered, that we're going to need more books of this size. In fact, I think all these caves were formed by sulfuric acid or strong organic acids. How? I think it was the oxidation of sulfur or hydrogen sulfide based on the organic matter laid down in the flood. A lot of organic matter in the sediments. And the combination of water, oxygen, and hydrogen sulfide would form sulfuric acid, and that could eat out these caves. So here's a little block diagram of how I think it occurred. Well, first of all, the limestone has to collect, and it's a chemical. It comes out of the water as a precipitate, as it shows here. And it just comes out of the water and collects on the bottom. And as time goes on, it stops and you get other sediments on top of it. There's your limestone. Then in the retreating stage of the flood, when the mountains rose, the valley sank down, Psalm 104, verse 8, to drain the flood waters, and the continents rose, and the ocean basin sank. The limestone would expand and crack, and sulfuric acid would start running through the cracks and along some weak bedding planes, eating out holes in them. And then when it's all over, you got all these cavities within the limestone like this. And sometimes the planation, some of these places are planed. And like in the Guadalupe Mountains of New Mexico, which I need to check out a little more, according to a researcher, some of these, the planation surface at the tops of this mountain formed during flood runoff cuts through some caverns, indicating that caverns were being formed as the sediments were coming up out of the water, expanding, cracking, and draining, and eaten out by sulfuric acid. So you have all these caverns sitting there right at the end of the flood. So that's the origin of the opening, the cavern opening. Some of these are pretty good size. So during the Ice Age is when you filled them with the speleothems. The origin of the speleothems that decorate all these caves. And speleothems can grow fast today. Hill and Forte in their book said 0.1 to 2 millimeters per year on the average. And yeah, I'm quoting this again. How fast do they grow? We can predict a rate for a particular speleum, but on the average calcite travertine, that's a calcium carbonate on the speleothem, grows about 1 millimeter or 2 a year. A lot of times they grow a lot slower than that. Silvestro has thought this through, and in the Creation magazine article, Caves for All Seasons, he says they can actually grow fast, even if we assume uniformitarianism. Now let's consider one of the tallest stalagmites in the world in the Cave Armand in France, shown above. At 3 millimeters per year, which is a very generous rate, I might add, at today's rate, it would have reached its present 38 meters, that's huge, in only 12,700 years. Clearly, this contradicts the ages of hundreds of thousands of years obtained from radiometric dating, or even millions of years. And when I did research on caves, which I published a series of 3 articles in the journal Creation probably about 2 to 3 years ago, I discovered that some stalagmites in Belgium were growing 2.7 to 4.3 millimeters a year. An article in Creation magazine showed a growth ring in southern Siberia grew at 15 millimeters in 1 year. A man named Shaw did some research on all these things about 100 years ago, and he listed 25 current rates that average 3.7 millimeters a year. There's one cave in Yorkshire that is growing 7.3 millimeters, and a lead mine in Iowa, 300 millimeters for a year for 3 years. I had to go check this out, and it took me to the verification of it through kind of an indirect route, but yet they verified this in a cave in a lead mine in Iowa. So they can grow fast. So how do they grow fast? Well, there's 6 main variables that determine stalagmite growth. The concentration of calcium ion in the drip water. As it drips down, how much calcium ion is in it. Number 2, the cave temperature. The warmer the cave, the faster the speleothem grows. Also, cave CO2. You want to get rid of the CO2 because as the calcium carbonate gets plastered on the speleothem, it gives off carbon dioxide. So you need to ventilate the cave. And so you got to get rid of the cave CO2. The more you get rid of it, the faster it'll grow. Also, the drip water flow. If it's very thin, it won't form a lot of on the stalagmite, which is the ones that grow from the bottom of the cave up. So if you have a thick drip water flow, you'll form the calcium carbonate rapidly. A thin, not less so. And so it depends on the film thickness and also the drip rate, how fast it drips. Also, a variable that is the relative humidity. But because of the evaporation of water in caves, the relative humidity is usually 100%. So most caves, practically all caves, the relative humidity doesn't do a thing. It's too moist. But it's interesting that in Carlsbad Caverns and those other caves in New Mexico, the Guadalupe Mountains, they're so dry that they're not growing except by relative humidity change. It's too dry for them to grow. In fact, it's huge. So what cause them to grow so big? That's a big problem for them. You have to have a much wetter climate. Hint, hint. Ice age, early ice age, wet climate. Anyway, so if the relative humidity is a little low, say only 90% or 80%, you'll cause calcium carbonate to form on the speleothems, and that's the only way they're growing in Carlsbad caverns today, is by the lower humidity. The caves are dry, and New Mexico's a dry area right now. So based on these main variables, we can kind of look at it. First of all, it's not the calcium carbonate in the air that determines the amount of calcium carbonate that ends up, or calcium ion and carbonate ion that enter down in the cave, but also it's what's formed in the soil by tree roots and organic matter. They oxidize, so carbon dioxide forms in the soil. The carbon dioxide in the soil is usually 2 times that of the atmosphere or more, sometimes 3 times. You have a huge amount of carbon dioxide in the soil. So it's the soil carbon dioxide that is the important thing. And it depends on a lot of variables, but especially tree root respiration and organic matter left in the soil that oxidizes. So think of this. As the floodwaters were draining, a lot of soil with high organic, or dirt, I should say, or mud, with high organic matter in it would accumulate in a lot of pockets, and maybe in a lot of areas. And in that would be a lot of organic matter. And that organic matter, as it oxidizes, would form a lot of carbon dioxide, huge amount. And that would be available to form caves as the water combined with the carbon dioxide seeps down through the limestone, which you see below. This is a geological pattern for limestone right here. So it's a soil carbon dioxide in aqueous form that the calcium ion in the drip water depends on. And that depends, this is a summary of what I've explained in that block diagram, and that depends upon the soil respiration and the quality and quantity of soil organic matter, which at the end of the flood would be huge. And as trees start growing bushes with fairly good precipitation during the ice age, you're going to have a dense canopy and lots of plant material to form carbon dioxide. So you have high carbon dioxide early in the ice age. This all depends on the soil temperature, thickness, and moisture. And with a lot more plants growing, say, and maybe 4 times the precipitation in many areas like Southwest United States. This is from a calculation I once made, published in the Creation Research Society Quarterly in 1993. With warm oceans off the coast, you should have 4 times the precipitation in the Southwest United States. So you can have thicker soils, more organic matter, more vegetation. This is all going to result in a huge amount of soil carbon dioxide. Then as this water, as it comes down into the cracks, it does change a little bit, but there's variables along the flow path. But regardless, when it gets down to the cavern, it's going to have a high amount of carbonic acid that's going to mix with the calcium from the walls for calcium and carbonate ions. So the possible flood variable aftermaths, I've already mentioned, after leftover sediments with high organic content would greatly aid the development of caves by increasing the soil carbon dioxide. Also, another variable, very warm rock. I indicated to you about 1,800 meters of sediment and sedimentary rocks was eroded from the continent during the retreating stage. Well, there's what's called a geothermal gradient where the temperature increases with depth. If you rapidly take off 1,800 meters, the rock at the surface And even down below where the cave is going to be very warm to hot. So you're going to have hot rock for a while. And this is going to make a major difference in that all these speleothems can grow rapidly from this effect. And it's found that where you find these big columns, which is the vast majority of where the thickness of the speleothems is in these columns, a lot of times when you look at the surface, there's a little valley on the surface. As Hill and Forte say, typically the largest columns in it's Ogo Cave. There's 300 caves in New Mexico, are aligned along sealing joints. A joint is a crack in the rock, and that's where the water is going to drip down pretty fast. But the greatest amount of water is dripping into a cave. Hill correlated the location of the most massive columns and stalagmites in Ogo Cave, New Mexico, with a valley on the surface. The joint along which the valley had developed is the same as that along which the massive travertine, that's a calcium carbonate, developed. In other words, after the flood, it's these little valleys on the surface that probably have the most organic matter. And therefore, and then there's a joint there, and then you can have rapid formation of soil carbonic acid, comes down the limestone, picks up calcium, and forms the columns. So there is a correlation. I think that's a good indication of a rapid formation due to leftover mud with high organic matter in the flood. And of course, I don't know if this is the Cave of the Swords in Mexico. That's a person for scale. These are gypsum, and they form differently than calcium carbonate, but these formed rapidly, but they claim, based on what's called fluid inclusions, that it was formed by the cave walls were hot. They say that these things are about 12 meters long, 4 meters wide, and weigh 55 tons. And the temperature of growth, depending upon the fluid inclusions, were 47 to 54 degrees centigrade. That is really warm. Therefore, that's why you're going to have rapid growth. In this case, it was gypsum in the form of these swords. In other cases, it'd be rapid formation of calcium carbonate. So early to the mid-ice age, you would have a number of features conducive to rapid cave formation. Warm winters, cooler summers. So there'd be much more precipitation because of the warm ocean. Like I said, in Southwest United States, I made a rough calculation of about 4 times the precip in Southwest United States, where New Mexico is located. You'd have thicker soils resulting in high drip water calcium. Very warm cave temperatures, and probably because of the storm activity in the ice age, it'd be able to ventilate, suck out the carbon dioxide. So you have generally low cave CO2, and you have much higher drip rate because you have much more precipitation, and you have thicker water film, of course, and the relative humidity, don't know about that one. But anyway, based on all these variables, I made a table, which I hope you can read. Didn't come out right, but based on 6 variables: equitable temperatures and more moisture, 1.5 times 3 times that of today. Another variable, thicker soil and more vegetation, 1.5 to 3 times. Higher cave temperatures, 1.5 to 3 times the current rate. Greater ventilation, 1.5 to 3 times. Much faster drip rate, 2 to 6 times. These are just crude estimates. Thicker water film, 1.5 to 3 times. It all adds up to growing up probably around 100 times faster than today's rate. So they can form early and mid in the ice age. By the end of the ice age, climate changes considerably. So things don't work out like this. So it's slow way down. But so you can get your speleothems early and midway in the in the rapid post-flood ice age. So I'm going to conclude all this. There's a lot more challenges I can talk about. By the way, I'm doing research on quite a number. I do research on maybe a dozen projects at the same time. Anyway, this is the take-home message. Bringing back the flood and adding the post-flood rapid ice age can solve numerous challenges which assume uniformitarianism. We've got to remember, they're assuming present processes, the present environment. And they say that therefore the flood is wrong. But they can't do that. They're using present processes. The flood was a gigantic catastrophe. But they always assume uniformitarianism. Also, often the challenges are challenges also to uniformitarianism. They have problems explaining many of these features, like coal, for instance. Anyway, if you want to know more about it, we do have answers to lots of things, as many of you know. There's a number of these answers book, but here's my favorite, the Creation Answers book by Creation Ministries International. Those are generally 3 to 5 page answers, but if you want more in-depth answers, John Reed and I edited this book, Rock Solid Answers. Got to read that. The Biblical Truth Behind 14 Geological Questions. So we answer 14 questions. This is an edited book, so we have a number of authors besides myself and John Reed that wrote chapters in here, like about reefs, paleosols, stuff like this. Anyway, that's all I have. I'm open to questions and answers now.
Mike, that's a great book right there, Rock Solid Answers. That has been a huge help for myself. I've actually got it around here on my bookshelf. And I want to say, great presentation, Mike. It's a blessing to have creationists such as yourself working so diligently to answer these challenges. And I want to say before I get to these questions, I love your approach to these challenges. As you pointed out in your presentation, that you look to them as research projects.
Mm-hmm. Yeah.
So I'm sure you would agree there's just not enough time in the day, unfortunately, to get to all the massive number of research projects we want to. So
that's right.
if only we can live as long as our biblical patriarchs, how much more we could do in terms of research projects.
Yeah, right.
So we've had a great chat. So much great information, Mike. Very rewatchable. I really appreciate it. And we've got a ton of questions. So what we're going to do is I'm just going to get right into them, and we'll get through as many as we can. Most of these, just looking at some of these questions, Mike, you could probably do a 1-hour presentation on alone. So what I'll do is I'll start with this question. We had a couple questions come in even before the show. They were left in the comment section.
Wow. Here's a lot of comments.
Yes. Yeah, there's a question here from Sam Schultz. I hope I pronounced that right, Sam. He sent this question in before we went live, and his question is, an evolutionist claimed that the mud flume experiments of Schieber, I probably mispronounced that, only show 27 centimeters or less speed for mud. And that's not the 1,000,000 times speed they claim the flood needs. I know you have talked about density waves. Would you please elaborate? Would more experiments with waves help? I'm just reading it word for word. I think I'm not sure if that makes sense to you, Mike, that question.
I go to the beginning again. I'm not sure what I missed the first part of that, or I'm not sure about what he said.
Yeah, he said an evolutionist claimed that the mud flume experiments of, and it's spelled Schieber, only show 27 centimeters or less speed for mud, and not the 1,000,000 times speed they claim the flood needs.
They're going 27 centimeters a second. That's Schreiber, I think. Scheiber.
Yes, I think so.
Okay. I'm not familiar with that particular experiment, but
he does elaborate. He says, I know they open.
I think I wrote an article on something like that not too long ago. That was just one way to do it, to form the layers. Yeah. Okay, I think I understand. Keep going.
Okay. But he just elaborated and said, I know they opened the largest wave flume in China in 2015. I'm not sure if that helps at all, but if say I'm going to go to the next question. If you are in the chat still and you want to try and elaborate, then go ahead. But I'm going to go to this next question here that came in near the beginning from Jerome. Thank you so much. He says, question for Mike Oard. Is ice considered rock? Example, hailstones.
If you got hit by one, you'd sure know it.
Yeah, I'm sure it'd feel like you're getting hit by a rock.
You can consider it kind of like a plastic. It'll flow under pressure and deform. But otherwise, it's pretty hard. But it's not rock. It's unique in itself, but it's hard when it's frozen, of course. But you put pressure on it, it'll flow. That's how glaciers flow. One of the ways glaciers flow, by the way.
Right. Okay. Thank you for the question. Thanks for that, Mike. Here's a question that comes in from Joe Wilson. Her question is, does Mike think the original creation was one supercontinent or more than one?
Oh, good question. If you read Genesis 2 carefully, it does not say there was one continent. It says that the seas were gathered into one place. So what does that mean? I'm not quite sure, but I know one thing. It doesn't say that there's one continent before the flood. There could be, there could not be. And I'm going to, at this point, say I don't know. And that's what I've been publishing for years. And as I gather more data in these research projects, because that's going to be that's going to kind of be a side issue later on. But the seas in one place, I kind of look at that as kind of like today, in that they seem to be connected. They're in one place, but seas are kind of off bodies of water like the Mediterranean Sea, but everything's connected. So it almost seems like the ocean was kind of similar today in that it's all connected, but yet there are pockets that are slower moving, kind of cut off from the main thing, but still connected. Maybe like you think of the Mediterranean Sea. Anyway, I'm just going to say I don't know on that one.
Okay, I appreciate it. I appreciate that. Is a good question. Good answer, Mike. Here's a question that came in from Douglas. Thank you for your question, Douglas. He asks, how are wind and water gaps formed?
Yeah, I got a book that includes that, including an ebook on my website. And Flood by Design talks about it. Anyway, as the floodwaters are draining and they're going over a ridge, perpendicular to a ridge, they channelize. When they channelize, they speed up because the same amount of water has to go through more narrow areas. As say that, I have this stuff on my computer, but it take me time to access it, showing a block diagram. But as the waters are draining and say a ridge is coming up, the water's channelizing and the ridge is exposed. So the channelized water speeds up, and erosion is approximately the fourth power of the velocity. So you erode out a gorge really quick from the top down. And at the end of the flood, it's going to be the low spot. So rivers are going to go from one side of the mountain to the other, right through the gorge, through the water gap. Now there are wind gaps where the water was rushing through it, but for some reason it got diverted and quit going through there and didn't dig it down far enough, so it's left high and dry as a wind gap after the water's drained. So only wind goes through it. That's why they call it a wind gap. So that's how they would form during flood drainage, during the recessive stage of the flood, mainly during the channelized phase.
Well, thank you, Mike. I love how informative your answers are. I could learn from you all day. So I appreciate that. I appreciate the question from Douglas. And here's a question that came in from George Bond. And he asks, why don't all layers show signs of erosion if they are millions of years old? So it essentially sounds like a good line of evidence for the global flood.
Big problem for the secular scientists. When you see sedimentary rocks, they're practically always one layer flat on top of another. Yeah, for thousands of feet, Grand Canyon being a typical example. In fact, I got a quote that, I have lots of presentations where I show stuff like this, but I have a quote from 3 secular geologists who wrote an article on the origin of the Teton Mountains in northwest Wyoming. The southern and northern part of the Teton Mountains are sedimentary rocks that used to be on top of the granite and gneiss that got eroded up there, but it's still to the south. And they say that there's 2,000 feet there, and it's flat, one on top of another, and it says they have the appearance as if they were deposited in an uninterrupted sequence all at once and without any breaks. And that's what we expect during the flood. They say, no, we can't believe that. So they put 200 million years there. But if that was the case, where's all the erosion? I mean, some of these environments they claim they can tell the environment from these things. I think they're just based it on uniformitarianism and guesswork. There's terrestrial environments and shallow marine environments. That's most of the environments they have. And in those cases, you should have valleys and cuts formed in hundreds, even thousands of years. But millions of years? That's one of our strongest evidence from the sedimentary rocks that uniformitarianism and deep time are false. The flat gaps, Ariel Roth has written a lot about that. You can get it on the creation.com website. His articles, flat gap, it's typical. It's worldwide. You just don't have to point out Grand Canyon, the flat layers, or the Tetons, southern Teton Mountains, but all over where you see it. What you do see is that after they were formed, then they were deformed. In other words, pushed up, fall down, cracked, broken up. But they were originally laid flat, one on top of another. Powerful evidence against deep time and uniformitarianism.
It really is powerful evidence, Mike. And in your experience, how do the critics respond to this line of evidence? What's their best response? Are they mostly ignoring it, coming up with rescue devices?
It's practically ignored. It's almost totally ignored. I hardly ever read something. I've read about the Grand Canyon. There's some areas where you see a little scour mark, and they claim that's from a river, and so that's the evidence of time. Or you see maybe some chemical reactions at the top of the Redwall Formation, and therefore that means there's a lot of time up there. Yeah, I mean, we have a lot of chemical reactions during the flood. In fact, I think we can really use several creation chemists, because there are a lot of chemical problems I run into about in the flood. And so they point out things like that as trying to say there's a lot more time there, but those are minor. They miss the big picture, the elephant in the room. The vast majority are just flat as a pancake. Right. And sometimes they say there's 10 million years missing at that gap. There should be a lot of erosion there. In fact, you can erode at the present erosion rate, you can erode all the continents down to sea level in only 10 million years. That's a minimum, because there's a lot of caveats to that. Because as the mountains get smaller and smaller, the erosion rate decreases. So, but but you could put a maximum on it. So I've seen several secular estimates of 23 million years and around there. I've been more general. I say 50 million years is a maximum due to these other variables, which I've worked on. It's on my website. I have a whole part on the section on that. And so
I'm gonna make sure to link your website in the description box as well, Mike. So you mentioned mountains, and I think this would be a good question to go to next then, Mike. The question is, which model best explains the formation of mountains and valleys, the global flood model or uniformitarianism?
Well, I suppose the uniformitarians can explain valleys by slow erosion over millions of years and slow mountain uplift for the mountains. We have to form them rapidly. And yeah, during the late Cenozoic, most of the mountains of the world uplifted, 40,000 feet for some of the mountains in the Rocky Mountains. Late Cenozoic, which is why I put the flood post-flood boundary most of the time at the top of the late Cenozoic. But we could form those valleys rapidly during the channelized flow of the phase. The origin of valleys was one of the early questions that or challenges that the secular scientists gave in the early 1800s, saying you can't explain the origin of these deep valleys because look at that river down there; it couldn't erode that fast. Well, look what they were doing. They're thinking of uniformitarianism. Yeah, of course. But if you had a channelized flow, you can carve that valley almost instantaneously during flood runoff. And you form water gaps, canyons. You can form all this really fast during the channelized phase of the flood, the last phase of the flood. I hope I answered that question. Got kind of little off on a tangent a little bit, but the original question is, how do they explain the flat layers? I would say in general they ignore it.
Yeah, and like you said, it looks like when it comes to the critics, it always goes back to those uniformitarian-based assumptions. The key is the present to the past, and so they miss these great answers that flood researchers like yourself have provided. It's 2 Peter 3. They deny the world that then was, being overflowed with water, perished.
Yeah, I want to back up to that original question.
Sure.
Was he trying to ask of how you form layers in thick mud rocks? I was wondering.
Is this the question all the way from the beginning, or the one we just did, Mike?
No, the very beginning, the first one you did. I'm still thinking about it.
Yes, he did say. You know what? He did say something in the chat. Oh, here we go. He says, so to clarify, I appreciate your clarification, Sam. He says, so to clarify, can mud rocks be deposited in moving water in addition to still water? Can the floodwaters slow down enough to deposit mud?
Oh, yeah. Okay. Yes. Yeah, you can form them in moving water and still waters, but if it's moving too fast, you won't form layers. Unless you're really dumping a lot of mud, and if you have a huge amount, it'll just totally saturate the flow, and it'll have to be deposited. But mud can flocculate. They found out that it's very easy to. What they do is electrical charges cause them to coagulate and form larger particles, and they come out a lot faster. We have some thick mud layers in the western United States, Mowry Shale. That sort of thing, and I've been thinking about that, and I think they formed probably late in the early flood, when the water slowed down and became calmer in a lot of areas. In fact, I believe the very early flood, the first 40 days, were pretty violent, and not much was deposited except in deep pockets. Rifts and basins. I think a lot of them formed by meteorite impacts. Down in pockets, the currents would be going a lot slower. So mud and sand and other things can be deposited in those pockets. But higher up, I think there's just too much commotion in most places for those sediments to collect. And those are mostly the Pre-Cambrian sediments that are down there now. And then things kind of calmed down after the Great Unconformity was formed. And then you had rapid deposition, like in the west here. If you look at Grand Canyon, which many are familiar with, you see 5,000 feet of sedimentary rocks. But you go to the Grand Staircase, you have evidence that you probably had 10,000 feet of sediments above that got eroded off as a sheet first before Grand Canyon formed. So you had about 14,000 feet of sedimentary rocks, and they're practically all horizontal all the way up, indicating that it was deposited in an area that was fairly calm. And that's how I think most of the mud formations, a lot of them that became shales, formed by flocculation in generally calmer waters. Probably some currents, but not strong. If they're too strong, they will of course erode and won't deposit. So, yeah, I think I provide the adequate answer to that.
Absolutely. Absolutely. I appreciate the clarification, Sam, and great answer, Mike. I appreciate that. So here, these questions are flying in like crazy. There's a couple here that I will put on screen because let me see here. Question from Jamie Russell, and he asks, can the winding of Grand Canyon be explained quickly?
Oh, yes. I have a whole book on the topic called The Grand Origin of Grand Canyon, if you want to know more about it. There's several problems that I address. Essentially, the Grand Canyon is a water gap. It's a long water gap. There are well over 2,000 water gaps across the Earth. Grand Canyon is not the deepest water gap on the Earth by far. Some of the water gaps through the Himalaya mountains are about 4 miles deep. And even in North America, the deepest water gap is Hell's Canyon, the Snake River between Oregon and Idaho. That's 50 miles long. The Grand Canyon is probably the longest water gap. So Grand Canyon is a water gap, and it can form rapidly during the channelized flow of the phase as it channelized through there across those plateaus, and it cut them from the top down.
Well, that looks like it's another book I'm going to have to add to my collection.
You can get it from the Creation Research Society.
Okay. Okay, perfect. Because we do, I'm going to link all of those in the description box because we got a ton of people specifically asking for links to all these different books that we've been talking about. So those will be in the description box, ladies and gentlemen, after the show. So here's another question that it looks like I think I might be able to put onto the screen. Let me see here. You did mention this.
You do that.
Yeah. And then it's unfortunately the earlier questions, they're gone because the chat's been so lively. These are some more recent ones. And Science Rules, you did mention this as a challenge, I believe, at the beginning of your presentation, Mike. He asks, how did the flood form angular unconformities like the famous one at Sakar Point, Scotland?
Oh, that was part of my presentation.
Right.
Anyway, what I think is that you had rapid bowing up of the sedimentary rock, and the currents are going fast, and they just sheared it off, and then a layer of horizontal sedimentary rock were laid on top of it, and we have things like that in a lot of different places. A lot of times they're not vertical like at Sicker Point, the bottom. A lot of times they're at an angle, maybe a 30-degree angle or various angles. And then another, but you got to realize we had a lot of tectonics during the flood.
Right.
Just if you got, we know that there are 200 meteorite impacts that we find in the strata, and some of them fairly large. That's going to cause tremendous deformation of the sedimentary rock. In fact, I've been reading about what's called the belt supergroup rocks in western Montana, Idaho, and Washington and adjacent Canada. It's a huge area, very thick. And they talked about there's Salmon, Idaho, in the Beaverhead Mountains, which are along the Montana-Idaho border, of a fold that rose up 10 kilometers. It folded, and some of it was overturned. 10-kilometer fold. That is so huge. I got to wrap my mind around that. I'm doing more research on this whole area at the moment. And so I come across that just the other day. And so you can have rapid uplifts and then sinkings and shearing off. So you can form angular inconformities in a lot of different places. Not a problem rapidly.
And your uniformitarians assume continental drift. And correct me if I'm wrong, Mike, would we as proponents of the global flood, at least during the time of the flood, would we assume continental sprint, meters per second plate movements, as compared to what we see now, right? Your snail pace. What are your thoughts on that, Mike?
Oh, I have a lot of thoughts that could take me hours, but I'm just going to sum it up in that that's called the catastrophic plate tectonics model. And I will add that most creation scientists believe that model or lean towards it. A lot of them don't believe it wholeheartedly. I know that from talking to them. Since I've been doing research in neurosciences for 45 years, and I've read a huge amount of secular literature, I come across, most of the time by accident, many problems against plate tectonics, and that would probably also be for catastrophic plate tectonics, even though catastrophic plate tectonics could probably solve some of these problems. I run into so many, and I published them in this Creation Research Society Quarterly, in the book Plate Tectonics, A Different View, which you can get from the Creation Research Society, which I wrote 40% of. John Reed was the editor. And so it has evidence, but it has a lot of evidence against it. And I would like to see the researchers do the research to solve these issues, and it's slow in coming. And so I run into these things a lot of times by accident. And so I can only believe. I was a weather forecaster for 30 years, so I give probabilities for things. I don't jump to say yes or no when I don't have enough evidence. So I give it a probability. So like 30% chance it'll rain today. Right. And so I give catastrophic plate tectonics a 20% chance of being correct, 80% chance of being wrong. This will probably shock some of you out there. Oh, before I get into that, why? I'll give you one reason why. I believe that in meteorite impacts followed by differential vertical tectonics, where rock goes up and rock goes down. It drains the floodwaters. That's the last half of the flood. Early in the flood, it was impacts. And I certainly don't believe the number of impacts extrapolated from the moon to the earth, which would be 58,000, 30 kilometers in diameter or greater. It's way too much. It melt probably melt the mantle of the earth. We have that many quickly. But I believe in maybe about 1,000, and I think there's evidence for them, and I've published some of this evidence. But anyway, people are probably shocked, and my position is well known, by the way. It's I'll give them one piece of evidence. You have the Pacific Plate, the Pacific Ocean, and you have the North American plate that is to the east and to the north, wrapped around it. And so the Pacific Plate is moving about 7 centimeters northwest in relation to the North American plate. So if there was a lot of time where that moved, or catastrophically moved in catastrophic plate tectonics, you should see, okay, I got to back up. There are deep sea fans that erode from a continent out onto the deep ocean. And there's 3 of them that I mentioned in an article about 6 years ago. I published that in the Journal of Creation. You can get it online, creation.com. But there's a fan called the Zodiac fan. It's practically out in the middle of the Pacific Ocean. And the current directions and the channelizing indicated that it came from Alaska. And it's dated Cenozoic. And it crossed the Aleutian Trench, which it couldn't have crossed. If it came from Alaska, it should have filled up that trench, but it's on the other side of the trench, south of the trench, and all indications that came from the North Alaska. So, but then when you look at that, they date it for what it's 40 million years old. I'm using their system, or in catastrophic plate tectonics, it should have been off the west coast of the United States, well off, where it couldn't get sediments, and then drifted northwest off Alaska if there was actually motion. But it appears there was no motion between the North American and Pacific plate. It was just eroded from Alaska, and the Aleutian Trench wasn't there and formed after the Zodiac fan formed after the huge erosion of Alaska. There's a second fan in the northwest part of the Pacific. I think it's pronounced the Meiji fan, where it eroded from the North American plate onto the Pacific plate. And it's thick. And there's no deformation or little deformation in it, indicating there's no differential movement between the North American and Pacific plate. So there isn't 1,000 or 2,000 kilometers of motion between them like you would assume in the Cenozoic or sped up in catastrophic plate tectonics. So that's just one of many things. So for people that are confused about all this, is that there's a lot of unknowns in science. So I say that we should use the principle of multiple working hypotheses when there's a lot of unknown. That was propounded by the geologist Chamberlain well over 100 years ago, saying it's good to have a lot of ideas out there. Let's have a lot of ideas. Catastrophic plate tectonics, impacts followed by vertical tectonics, and get the data to try to prove these. And so that's a good thing. A good thing. It's not a problem having different ideas, because we all have different ideas. It's just that we need to demonstrate it. And like I said, catastrophic plate tectonics has evidence, and so that's why I believe at 20%. So that kind of sums up something I could talk about for a couple hours. But it's controversial, and I'll discuss it with anybody in charity.
Well, once again, so much good information, great answer. And I like those rules you live by. I completely agree. Well said. And I think that's why you have been so effective and successful as a researcher, specifically a flood researcher. So those are some great points. And so many questions. I think this is actually might be the record for the amount of questions that have ever come in, Mike. So people are really interested in your answers. And this is something you talked about a great deal in your presentation. And we've got a lot of people who are now just joining us. Ryan, the Raptor guy, asks if you could talk about the beds hypothesis. So I will say first off to Ryan, definitely go back and watch Mike's entire presentation. Tons of great information.
You came in late.
Yeah, you came late. So he's obviously aware of it. And Ryan oftentimes joins us and asks us great questions. He seems to be really up to date on the different models in young Earth creation. So I don't know, Mike, if you wanted to just kind of briefly recap it, or
okay, I'll recap it. In the flood, you have areas of rapid sedimentation, and in those areas, it forms so rapidly that the bottom of the sediments comes up to near the top of the floodwaters. And so a local drop in the level of the floodwaters exposes that freshly laid sediments, briefly exposed alluvial sediment. And therefore, you can form tracks on it, lay eggs, raindrop imprints, even mud cracks. Even a day of drying will cause a mud cracks. I've seen it in Tucson, by the way, after a rain. And so you can form these, and then another rise covers it all up to preserve it. So that's in a nutshell. You can read all about it in my book, Dinosaur Challenges and Mysteries, or you can go look at this presentation, which is actually still a summary of
that book.
Yeah, I would say go rewatch the presentation and get that book. That book was one of the specific ones people were asking links for, so I'm going to provide that as well. Here's a question that just came in from Science Rules. I guess it has to do with dating methods. If both strata were deposited in the same year, why do they date so differently in your opinion?
Well, they date strata mainly by the fossils in it. And they're dated indirectly by radiometric dating methods of igneous rocks. And I think these igneous rocks have different chemical signatures. And so you get different dates out of them. That's still a huge area that we are still doing a lot of research in. We can account for the millions of years they give from Humphrey's research on helium and zircon crystals. And we know that a lot of dates are wrong, and there's also a circular reasoning tendency. But I'm thinking that a lot of it are chemicals. Say one igneous rock has more argon in it and than another, and it'll be dated older, obviously, in the potassium argon method. And their assumptions of that they would totally become zero argon they know are wrong. They don't use that anymore anyway. There's always some, and they got to go to other assumptions. But if you want to read a good book on it, you can get Cups's new book put out by ICR. Yeah.
Rethinking radiometric dating. Okay, I'll take that.
It's a great book. It's a bit in depth, but I just read it, and I knew. So I've read a lot of stuff on it, but he kind of summarizes all this why you can't really trust the dating methods, and so you can have things that are dated millions of years apart that happened in the flood.
Well, haven't they attempted to date rocks of known age, and yet they get millions and millions of years?
Oh, yeah. In fact, he points out some of that. The rocks in the Grand Canyon and then the volcanic cones and stuff on the northwest rim, mostly on the northwest rim, that are fresh lava. You date some of that as 1 billion years old, and it's pretty fresh. You date a volcano in New Zealand. I can't pronounce it. Snelling did this research. Nagara, something like that, and in northern New Zealand. And they got dates of millions of years. And then there was one date, I think the lead method, that gave several billion years. So if they can't, this is the takeaway message of this. If they can't date correctly rocks of known age, why do we believe them for their dates on rocks of unknown age?
Exactly my thoughts. We're supposed to trust the dates derived from rocks of unknown age, and yet, as you're pointing out, we're getting these incredibly divergent dates on rocks of known age. So I think
I will admit we do need more research, because there's a lot of dating methods out there. Right. Even besides the radiometric dating. And some of this is being done like thermoluminescence. Vernon Cups talks about that. There's a lot of what's called quaternary dating methods that I've seen. They all have issues and assumptions and so forth. So, but we do need more research. But in answer to the question, it really doesn't matter whether one igneous rock formed at the same time of the flood as, say, 100 million years based on the chemicals in it versus 1 million in another. It's not an issue.
And if we're getting detectable levels of C14 in samples such as, I guess, coal, diamonds, fossils that evolutionists say are, millions to billions of years old.
Yes.
Right. So that would, I guess, again, be a problem for their point of dating methods. I imagine that shouldn't be there if they really are millions to billions of years old.
Oh yeah, every time they date coal by a carbon-14 method, they do it to calibrate their instruments, and we've done it. You get detectable carbon-14 in it when it should be all gone within a maximum of 80,000 years. If it's over 80,000 years, all carbon-14 should be gone. But they claim contamination a lot. But come on, hundreds of times. I mean,
right.
Researchers don't go and sample a coal that they know has a crack in it where young carbon came down in. They will go through a sample that's uncracked. They'll collect it. They take great pains to find a sample that's pure and not contaminated. I mean, it still can happen, but not all the time.
Right.
So, and they date coal anywhere from 15 million to 350 million years old. And of course, diamonds are several billion years old, and there's detectable carbon-14 in diamonds. So there's lots of problems with the dating methods.
Right. Great points. Well, here's a question that came in a while ago from Chris Peacock, Mike, and unfortunately I can't put it on the screen because it's a question from so long ago earlier in the stream. But he asks, how can a flood with the power to split the continents and push Everest to where it is also be gentle enough to preserve raindrops?
Well, because the flood wasn't chaotic everywhere at all the same time.
Right.
You had the early flood. It probably was very violent over most areas. I would say not all. But after the mechanism slowed up, probably I take about 40 days is when it started to slow up. Then you had rapid sedimentation. Things were calmer. So you can have oscillating sediments. You can have deposition of thick muds, these sorts of things. And Mount Everest, of course, that whole area was under sedimentary rocks during the flood, and it came up out of the floodwaters late in the flood. Okay, I need to get back to the original question. I got off on too much.
No problem. Let me see. Yeah, no, I think you answered it well too initially, that it obviously wasn't equally chaotic on all parts of the earth during the flood, because the question was, how can a flood with such great power also at the same time be gentle enough to preserve raindrops?
Well, yeah, because the raindrops are preserved on the beds during the when you have them exposed. You can have raindrop imprints that are formed on them. And by the way, you find these raindrop imprints clear to the late Archean, which is about 2.6 billion years old, according to the secular time scale. And this tells me that much of the Pre-Cambrian sedimentary rocks are from the early flood. I see a question I can answer real quickly on the right here. How could a flood deposit layered fossil forest like in Yellowstone? Well, yeah, because that breccia there was deposited in one area, broke up, and was redeposited as huge flows over such 9,000 square miles. And above it, you had the log mats floating, and they were sinking as it was depositing these breccia flows all 6,000 feet. You find layers. In fact, you find 9 areas in Yellowstone that we know of where you have a lot of them on a cliff, but you find isolated ones here and there all through that Absaroka volcanic. So that's how the log mat and rapid sedimentation in fairly deep water. I have a talk where I actually have a diagrams kind of illustrating this principle. But anyway, you were going to show me another question. I just quickly caught that one on my eye.
Yeah, no, I appreciate that. That's a fascinating answer, because I've personally heard some of the skeptics and critics of the global flood model look to that argument that you just answered as just a number one argument against the flood. And as we can see here, there is an answer.
Yeah.
So I appreciate that. Yeah, this question here comes in from Landon Freeman. He says, if you came across a Christian who believed that the flood was local, what would be the first main piece of evidence you'd present as a counter argument?
Well, I'd ask him, does he believe the Bible's account of the flood? And secondly, I would say based on that, it says that all the animal, 2 of each kind of animal came to the ark. And there'd be no point of collecting animals at all if it's a local flood. No animals at all. You don't even need an ark. Just flee to the mountains. There's at least 9 reasons right from Scripture against a global flood. For instance, the ark landed in the mountains of Ararat. If it's a local flood, it'd end up in a floodplain or out in the ocean. It wouldn't go backwards up in the mountains from probably where the flood supposedly would originate. It's a local flood.
Right.
So forth and so on. And then you look at the sedimentary rocks, and they're deposited one layer upon a layer over vast different areas, like the Teton sandstone, the bottom layer of Grand Canyon on top of the granites and metamorphic rocks, about 200 feet thick. It's spread over half of North America as a sand. Up in my area, it's called the Flathead Sandstone, lying on granite, and the Belt Supergroup, which is a Pre-Cambrian rock that I believe formed earlier in the flood, but it's mostly on the bedrock of the upper crust, the granites of the upper crust. So that's not slow processes of erosion and deposition over millions of years. Slow processes are you'll find a little bit of sand that changes to gravel, then the mud. It's just a laterally, horizontally, and vertically. It's just great changes. But you see this layer of sand spread over half of North America. I mean, the sediments themselves scream flood. So not only does science of geology say that, but also the Bible is clear that it was a global flood.
Right. That's a great answer. And you mentioned sand there. And here's a question. And there's even an article on this as well, where the critics of the global flood have stated that it only takes one example of desert sandstone to disprove the young age of the earth. So I thought that was an interesting question to ask you. What are your thoughts on that,
Desert sandstone. Okay. They claim a lot of sandstones in the geological record are windblown from a desert. A lot of this is old research based on that, and it's kind of been led a life of its own, because they see these big cross beds. Mm-hmm. See, as sand moves, it forms kind of a delta feature as it moves out. They're called cross beds. And a lot of cross beds are 30 meters tall. I mean, that imply a huge flood to deposit that. I mean, at least the water would have to be 5 times as deep as the cross bed. So they automatically got a bias that, oh, this can't be a marine deposit. Actually, now new information shows that marine sand waves can have huge cross beds too. So, but anyway, they made that claim. But John Whitmore and Ray Strom and colleagues have written some great papers you can get on the Answers Research Journal, showing that the classic area of a windblown sand, the Coconino Sandstone near the top of the Grand Canyon, is obviously a water-laid deposit, because it has mica in it and feldspar and a lot of other things. In fact, a lot of the statements made by the top researchers on that sandstone were half correct or wrong, and they didn't do a lot of good research. And so I think, have demonstrated positively that it's a marine sand. And so I don't believe there's any desert sands in the rocks at all. But that's an ongoing research project, because we got to check other ones like the Navajo sandstone,
right,
and things like that. But in fact, the Navajo sandstone has a lot of indication of water-laid sediments in it. It also has a lot of dinosaur tracks, it has petrified trees. I mean, it has a lot of evidence that is laid down in water. So, and it's massive. I mean, there's areas where there are hardly any shale interbeds, like you see in Zion. I mean, it's just massive sand that's been cemented to sandstone. So, yeah, we don't believe there's any such thing as desert sands. And we have evidence of the classic case, the Coconino Sandstone, that it's not a desert sand.
Well, that's a great answer, because those are the two big ones they look to is the Coconino sandstone and the Navajo example that you pointed to. And you demonstrated that yes, this can certainly be explained through a global flood model. So that was a really important answer you provided the audience, because it's an argument commonly put forth as like a one and done against the flood. So I appreciate that one.
They have a lot of those things, and like I said, we have answers, and we're still working on answers, but we do have a lot of answers to a lot of these questions.
And here's an interesting question, actually, that I have here saved. And let me see here, because there's so much. Okay, I got it right here. I'm curious as to your thoughts, Mike, because the question is, critics of a global flood state that a flood would have washed over everything equally. And so terrestrial creatures should be as abundant as aquatic creatures. But according to the questioner, we see shallow marine creatures making up most of the fossil record. Therefore, is this a problem for the Genesis flood model?
Well, like a lot of problems, it can seem like it, but we haven't got all the facts in yet on all this. And so we got to watch out jumping to conclusions. There are a number of answers to this. Like ecological zonation being one, is that it was zones, ecological zones that were buried. For instance, marine creatures first, and then going up to more creatures that swim, to more terrestrial features. And there's a lot of unique features. Now, I take the geological column as general guidance, broad scale evidence, but I think there's a lot of fine details that are not correct with it. But in a broad general scale, I take it. And what you find is in the Paleozoic, it's mostly limestone with marine creatures. Then you go to the Mesozoic, you find a lot of floating ammonite fossils and then dinosaurs. And then Cenozoic has a lot of terrestrial creatures. Anyway, there's a pattern there, and I think ecological zonation, vertical ecological zonation, marine creatures live down lower and terrestrial creatures higher up. But there's a lateral zonation in that the trees that form the coals in the western United States are mostly from what's called angiosperms, or flowering plants, or probably coniferous trees too, but those on the East Coast come from extinct lycopods, different type of tree altogether. And so it almost seems like two different ecosystems deposited, difference, East Coast, West Coast. And I don't think we got good answers to that yet, but I think this research project I'm working on possibly could answer some of these. Namely, remember I said that at the peak of the flood, it appears we had 5,000 meters average sediments or sedimentary rocks on the continents. Average. And even in the continental, the Canadian Shield, you had Paleozoic rocks. We know at least because there's pockets of them there, like Hudson's Bay. So that was covered. So the question is, where did this sediment come from to reach 5,000 meters at the peak of the flood by day 150? Well, I am leaning more strongly all the time, like several other creation scientists, that, like, let's take North America, which I'm familiar with. That North America was actually part of the ocean, the pre-flood ocean. And out in the Pacific Ocean was actually the landmass was mainly out there. And that when the flood first occurred, it was the marine creatures in the U.S. that got covered up first. And then you had currents coming from the west. From the east first for the Paleozoic, and then the west and the Mesozoic. And that came from off the Pacific, and that brought in creatures that were out there on the land masses, like flowering plants dinosaurs that came up and ended up on top of the Paleozoic marine creatures in a lot of places, especially the Western United States. And I think it was different on the East Coast, of course. But so I think some of these trends can be explained this way. These are thoughts that are just entering my head in the last month. So I think we got ways to explain that, but I have to work it all out, and it might take quite a while. But that's an idea I have, that a lot of the ecosystems came from off the ocean onto the current continents, which were under the water early in the flood. And therefore we have marine creatures first, followed by more terrestrial creatures on top of the marine creatures.
Yeah, that's a great answer. And that pretty well answers this question too about, how do we answer the fossil record being claimed by the evolutionists to have been sorted in an order convenient for evolution. And as you point out, this burial by ecosystems and communities. And what are your thoughts then Mike? Because don't we have evidence right from scripture that in the pre-flood world, we may be dealing with different elevations because we have rivers that are flowing out of Eden. And since rivers flow downhill, would we expect humans on one elevation, a different ecosystem than, let's say, dinosaurs?
Oh, yeah. You can have dinosaurs living in low country just off the Pacific coast. Once you form the Paleozoic rocks, marine creatures deposited mostly in North America, which are widespread in North America. The currents come from the west, deposit that ecosystem there with flowering plants, forming coals later on, and dinosaurs. And then I don't know how the people would get in this, but a lot of mammals say were at higher elevations further out, and they'd come out and then end up being deposited on the Mesozoic dinosaurs. There's intermixing in all that, by the way,
right,
too. So anyway, these are by the way, these are research thoughts, called speculation, if you like, that is current and ongoing, and is not meant to be a factual answer. But I think a reasonable idea that I'll share is preliminary. That's what I'm trying to say.
Right.
Some of this is preliminary research ongoing.
Yeah, that's a great response. And something that came to mind is if we start from the account in Genesis, well, we know God created two human beings, Adam and Eve, and populations of animals, and I would imagine fully working ecosystems. So in your opinion, Mike, would we expect to find a lot of human fossils as compared to billions of animal fossils?
Well, that would be true. My wife's called me for dinner. Anyway,
no worries. My wife too. We can start wrapping up.
I can keep going. Anyway, I got suddenly distracted. Repeat that.
I guess, what are your thoughts on if we started from the Genesis account of origins? We've got God creating, he's creating two humans, but then populations of animals, I would imagine, spread out over the supercontinent. So wouldn't we expect billions of animals versus probably very few human fossils?
Yes, the Lord probably populated all these ecosystems with millions of animals already. I mean,
right.
He didn't have to start with two, but humans did. Yeah, from a statistical point of view, we shouldn't find many, but there's several possibilities why we don't find any. There's some human fossils in the rock record, even though there's been some equivocal evidence that they're there. I just don't know what to make of it. And artifacts found in coal. So
right.
There's stuff like this around. Some of it seems pretty good. I just don't know what to make of it total, and I haven't given it much thought. One possibility is that humans were deposited in the upper layers of strata. They being at higher elevations out in the Pacific Oceans, we'll say.
Right.
And they come spread, and they're on the very top. And then when the retreating stage occurs, 1,800 meters average erodes from the continents, and they're at the top, and as they get down, turbulence and just totally pulverizes them down to molecules. So that's one. Another one is that it said that that the Lord could have just totally wiped out man by right away in the flood. I mean, the object was to destroy humans, so he could have done, say, with a lot of meteorite impacts hitting the right places at the right time, so that there weren't hardly any humans left within, say, 10 days. I mean, that's another option I've heard said. But like with a number of questions, I'm going to say at this point, I don't know. I have ideas.
Right.
And I call it reasonable speculation, but not reasonable answers.
I would say some very plausible ideas. And that's what's so fun about, being involved in this creation versus evolution debate and controversy, is because there's so many active research projects, as you pointed out. And I personally find that to be fun. I like studying these issues as you as well, Mike.
Yes. Amen.
Now, I surprisingly, I looked over at the time. We've been going for 2 hours and 10 minutes. So time always flies by with you, Mike.
It does.
And you've done a great job. Our last show, we went almost 3 hours. I couldn't believe it. So we've got almost 10 hours, I think, of material with you. We've just gone rapid fire Q&A with you on some of the toughest questions. You did a great job. So I really appreciate that, Mike. And I think you've earned dinner, as your wife is calling you, for.
If you want, we can have just a Q&A session of some time. There's so many questions, and I haven't been able to get to a lot of them.
Well, what we can do, if you like, because these Q&As fly by, I can save the questions that we didn't really get to, and maybe, we can schedule just an audience Q&A where we just kind of deal with as many of these as possible. Because
that'd be great.
Yeah, I find this a lot of fun. This is, I think that's why time really flies by. So maybe we can, touch base through email and we'll get that going. Mm-hmm. We've even got people in the chat already saying question and answer would be great. So, and that gives already people are agreeing with us. So maybe to everybody in the chat, think up some questions. And you can even email me them and we'll set that up. Hopefully, sooner than later. So that being said, Mike, another fantastic presentation, so much great information, an awesome Q&A. To the audience, thank you so much for your questions. I think this is now our top show in terms of most questions asked. It was even hard for me to keep up. So I did my best. I apologize to those whose questions I didn't get to, but we will save those for a future show. Mike, I want to hand it to you for some final words, final thoughts, and thanks again for giving us your time.
Oh, you're welcome. Glad to do it.
Awesome. I appreciate it. I appreciate it, brother. So anyways, I'm going to let you get to dinner. My wife's calling me up for dinner as well. So well earned, well deserved. Okay. And to the audience, thank you so much. God bless. And Standing for Truth is out.
If you like this type of content, be sure to hit subscribe and also smash that like button. It actually does help. Thanks for watching, and I'll see you soon.